Manufacturing Practices, IMP 2026, being organized as part of the 20th Symposium on National Frontiers of Engineering at IIT Dhanbad in association with the Indian National Academy of Engineering, INAE. Manufacturing is no longer limited to converting raw materials into finished products. It has become a powerful integration of scientific knowledge, advanced materials, digital design, precision processes, and intelligent automation. The strength of a nation increasingly depends on its ability to transform new ideas into reliable, scalable, and globally competitive technologies. IMP 2026 brings together researchers, engineers, and industry leaders to examine emerging manufacturing methods, sustainable production, and indigenous technology development. By connecting academia, research laboratories, strategic organizations, and industry, the program seeks to transform innovative ideas into scalable industrial processes and strengthen India's technological self-reliance. I extend a very warm welcome to the UG, PG, and PhD students along with the faculty members of BIT Sindri College. I also welcome the UG students of Government Engineering College, Goda. As a part of this event, an e-summit is also being conducted by the e-cell students, where about 300 students are participating. I also welcome the venture capitalists and the representatives from MIT and startups. With this note, I feel deeply honored to welcome our chief guest of the event, Professor Suhas S. Joshi, Director, IIT Indore, and request him to kindly grace the dais. I wholeheartedly welcome our distinguished guest of honor, Dr. Ankati Rajuji, Director, DRDL Hyderabad, and Professor VMSR Murthy, Director, IEST Shibpur, and request them to grace the dais. I also welcome Professor Sukumar Mishra, Director, IIT Dhanbad, and Professor Alok Das, Coordinator, IMP 2026, and request them to join the dais. I welcome all our distinguished dignitaries, INAE fellows, invited speakers, delegates, faculty colleagues, researchers, and our very dear students. May I now request Professor Sukumar Mishra to do a floral welcome of our chief guest, Professor Suhas S. Joshi, Director, IIT Indore. May I request Professor Sukumar Mishra for a floral welcome of our guest of honor, Dr. Ankati Rajuji, Director, DRDL, Hyderabad. A floral welcome for Professor VMSR Murthy, Director, IEST Shibpur. May I now request Professor Alok Das for a floral welcome of our Director, Professor Sukumar Mishra. May I now request Ms. Suprabha Palata Singh to do a floral welcome for Professor Alok Das. Welcome once again to all our dignitaries on the dais. To formally inaugurate today's program, we shall now proceed with the ceremonial lamp lighting. May I request all our dignitaries on the dais to kindly come forward for the lamp lighting. The flame reflects the spirit of innovation, where an idea grows into knowledge and knowledge is transformed into meaningful progress. Thank you, sir. May I now request the students to kindly come forward for the invocation song. Thank you, Tripti and Ankit, for filling the atmosphere with serenity through your melodious rendition. It is now my privilege to invite Professor Sukumar Mishra, Director, ITI SIM Dhanbad, to deliver the welcome address and highlight the significance of IMP 2026. Over to you, sir.
Good morning, dignitaries on the dais. Professor S.S. Joshi, Director, IIT Indore, Chief Guest of this occasion. Dr. Ankati Raju, Director, DRDL, Hyderabad, Guest of Honor. Professor VMSR Murthy, Director, IIT Shibpur, Guest of Honor. Distinguished Fellows of the National Academy of Engineering, eminent scientists, industry leaders, academicians, researchers, faculty members, and my dear students. It gives me immense pleasure to welcome all of you to the second day of this 20th Symposium on National Frontier of Engineering at FOI 2026 and the inauguration of Innovation in Manufacturing Practice, IMP 2026. And also, I heartily welcome the participants of E-Summit. So basically, there are three programs at a time is being held today, and all these three are interlinked to each other, which you will see at the end of this day, and the outcome of this program will be seen by that. Yesterday, deliberation has been done in many aspects, and it affirms that India possesses immense scientific talent and engineering capability. The discussion on strategic technology, advanced manufacturing, and national priorities clearly demonstrate that meaningful progress is possible only when academia, industry, research laboratories, and government work together. Today, we shift our focus from exploring engineering frontiers to translational innovation and its impactful practice. Innovation has little value unless it reaches the laboratory branch, the factory floor, the marketplace, and ultimately the society. Manufacturing has always been the engine of economic development of any country. And today, it is equally central to India's aspiration of technological leadership and Atmanirbhar Bharat. Whether in advanced material, defense system, precision engineering, smart manufacturing, or digital production technology, innovation in manufacturing will determine India's global competitiveness. The design of IMP 2026 reflects this philosophy. Over the course of the program, participants will benefit from 5 plenary lectures and many more, 4 keynote addresses delivered by some of the most distinguished fellows of the Indian National Academy of Engineering, alongside 16 expert members and many other talks by accomplished young engineers and innovators, providing participants with perspectives that span both established excellence and emerging leadership in engineering. A distinctive feature of this year's program is its emphasis on student innovation and entrepreneurship. At IIT ISM Dhanbad, we firmly believe that innovation should not end with publication only. It should lead to prototypes, patents, products, startups, and solutions that address national priorities and the societal needs. Through our innovation ecosystem, incubation facilities, industry partnership, and entrepreneurship initiative, we remain committed to nurturing this journey from idea to impact. We invite our undergraduate, postgraduate, and doctoral students to present their innovative ideas before different expert jury members, to recognize outstanding creativity and technological potential. Different cash awards of different amount are given to the best innovation in different categories. Many of the promising ideas have emerged through the hackathon organized by our dean under the e-summit. The shortlisted team have been provided a larger national platform through IMP 2026, where they will interact with distinguished academicians, industry experts, innovators, and innovation leaders, along with the pitching deck with the venture capitalists. We hope this exposure will help transform innovative ideas into viable technology, startup, and enterprise. I encourage our students and young researchers to make full use of this opportunity, engage with the eminent fellows of INAE, interact with experts from industry and national laboratories, ask questions, seek mentorship, and build collaborations. These conversations often, this conversation often become the foundation of future research partnership, successful startups, and transformative technologies. I express my sincere gratitude to all our distinguished guests for joining with us and enriching this program with their expertise. I wish all the participants highly productive days of learning, innovation, and collaboration, and I look forward to witness many ideas presented here evolve into technologies that contribute to the nation's progress. With a clarion call, I would like to conclude the future of Indian manufacture will not be built merely by better machines. It will be built by better ideas. And those ideas are sitting in this auditorium today. Thank you. Jai Hind, Jai Bharat.
Thank you, sir, for your insightful welcome address. Your words have shown how academic research, industrial collaboration, and technological vision can come together to create manufacturing capabilities of lasting national value. We are honored to have with us Dr. Ankati Rajuji, Director, Defense Research and Development Laboratory, Hyderabad. A distinguished scientist and technological leader, Dr. Raju has contributed to the advancement of indigenous missile systems, propulsion technologies, and other strategically important defense capabilities. His leadership reflects a strong commitment to transforming complex scientific research into reliable engineering systems to enhance India's technological preparedness and self-reliance. May I now request Dr. Ankati Rajuji to kindly address the gathering.
Today's chief guest, Professor S.S. Joshi, Director IIT Indore, Professor Sukumar Mishra, Director IIT Dhanbad, Professor Murthy, Alok Kumar Das, Coordinator of this conference, distinguished guests, participants, students who are present here. Very good morning to all of you. First of all, it's my honor and pleasure to be here with you for this conference, Innovation in Manufacturing, Process and Technologies. It's apt for today's situation in the country. It's very much required for all of us to think. I just say a few words that innovation is the foundation for any technology, and also innovation is the future of sustenance of the country. All of you, I would like to say that, please note the word innovation. It is the order of the day for all of us, not only for the students who are here, but everyone who are sitting here, because everything depends on the innovation. We need to identify the gaps in the country, and then we need to march towards the progress of the country. Not only in terms of manufacturing technologies, but each and every field, what we are looking at. Coming to the defense technologies, what we are working on, we have made a lot of progress in development of defense systems for the nation. But still, we have a long way to go. But to achieve this and to make this country, Viksit Bharat, innovation is the order of the day. I request all the students and everyone to stress on innovation and then march towards the progress of the country. Yes, we have made some systems. Lot of difference, from the time we started in 1960s till now. But then we need to develop futuristic systems for the progress of the country. I always believe that we need to be focusing on the new systems. Just think where we are at this point of time. We are good at making the systems, but not good at innovating the things. We are procuring many state-of-the-art systems from outside the world, but why we are not making within the country? Why we are not focusing on basic research? Because there is a lot of gap in the innovation in the people's mind. So the students who are the future of this country has to focus on innovation rather than pursuing in a monotonous manner. Normally we are used to do it. I think we should give away all those things and then focus on innovation. It can be on manufacturing, it can be on propulsion systems, it can be on semiconductor devices and many more. Unless otherwise we build new systems by ourselves, we cannot be technology leaders, but mostly we are technology followers. So with this mindset, we should progress so that at the end of the day, by 2047, we should make this country Viksit Bharat. Thank you. Wish you all the very best. Thank you.
Thank you, sir, for your valuable insights. Your words will certainly inspire our researchers and young engineers to pursue solutions that contribute to India's technological strength and self-reliance. Our guest of honor, Professor V.M.S.R. Murthy, Director, Indian Institute of Engineering, Science and Technology, Shibpur, is an accomplished academician and institutional leader with extensive experience in mining engineering. A recipient of the National Geoscience Award 2019 and a fellow of the Indian National Academy of Engineering, Professor Murthy exemplifies the integration of research excellence, industrial relevance, and institutional leadership. His perspectives are particularly valuable to IMP 2026, where research and manufacturing converge to shape sustainable technological progress. May I now request Professor V.M.S.R. Murthy to kindly address the gathering. Over to you, sir.
Namaskar. Thank you, Professor Madhulika, and our honorable chief guest, Professor Joshi, and our Raju sir, Professor Raju, and Professor Sukumar Mishra, Director, IIT ISM, and Professor Alok Das, and distinguished audience, particularly this particular symposium, 20th Symposium on National Frontiers in Engineering, particularly focusing on innovation in manufacturing, with a couple of more items in it. It's a novel idea that is basically being organized on the aegis of INAE. So it's a grand gathering of all, distinguished INAE fellows and members, and whole lot of faculty colleagues from IIT ISM and entire academic community and research community and industry. So it's my proud privilege to be a part of this second day inaugural session. I would like to, after listening the first day deliberations and today's, whatever are slated, it looks like, it's a good feast for three important areas, as already mentioned by Professor Sukumar Mishra. That is the raw material, first of all, that comes from different resources, particularly mining, and then the processing, and then the manufacturing. If you connect these three, probably this is the best place where we have all these departments and faculties that are contributing to excellence in innovation and research, using our, the young engineers who are studying in various programs, UG, PG, and PhD, which are continuously being updated in line with the national missions. If you look at any IIT, NIT, or any education system today, we're all riding in the same, curve or wave. And the wave is, a bit steeper. That's the interesting part. The way that when we entered into the academic foray, research foray and academic foray, the challenges and targets were, pretty organized, and, maybe the growth rate that we were expecting in terms of research or teaching or whatever you say, it's more like a planar level. But today, it's riding on a wave that probably unprecedentedly, we have to gear up ourselves. And of course, innovation is the one that basically makes us, different from others. And this particular part, as mentioned by Dr. Raju, is, it has to start from universities only. And looking into, a bit of my background, I started my career as a scientist in Central Mining Research Institute. After doing my post-graduation from ISM and then, of course, bachelor's from NIT Nagpur. So what I understood was this education, when I pushed into the research and working with the industry problems, particularly facing the frontline, problems and understanding them, and spending good time of about 7 to 8 years gave me a kind of exposure to understand the industry problems and overall, perspective of at least mining industry or infrastructure industry, particularly construction. So this kind of exposure, what I see is probably when we just get into teaching and start modeling and then doing designs at the laboratory scale, and then finally stopping there probably was happening only for the last 10 to 12 or 15 years. Prior to that, it was more of a fundamental research, which was necessary, which is necessary today also. But now the, the merger that is happening between the fundamentals and the laboratory scale research to a particular pilot scale. And this is happening in some of the advanced institutions like IITs and ISM Dhanbad and a few NITs also. But there's a long way to go. The faculty members particularly need to understand this, and we have the best lot, sitting to be trained. So it's a good opportunity for, to make really the country towards, inching towards Viksit Bharat 2047. We have to integrate all these areas and make our students, particularly the UG, the best cream of the country, and then the PG who comes, with a lot of aspirations, and the PhD problems that today talk about, in NEP 2020 also. We are looking into process innovation and product innovation. And this has come, in such a small, gap of say 5 to 10 years if you look at for the last decade. It has been, a very good challenge also. And I'm sure because of this AI and ML integration and digital twins that we talk about in most of the, industries that is pervasively being applied, it has become easy also now. The research, when you talk about 5 years of, research for PhD, today it's getting reconfigured now. That whether at all you require 5 years of, time to be spent on a PhD problem, that means basically having understood the advanced technologies, AI, ML integration, probably the time that you require to product development and process development at the lab scale as well as pilot scale is becoming easy now. So institutes should be the innovation factories, and this is happening now. And it has to happen at all places. We have number of institutions, centrally funded, state funded. Everywhere, I think probably this talk is happening, and walking the talk is also happening. So I think long way to go. And this kind of conferences under the aegis of NIE and then IIT ISM and the similar institutions will really give a boost. And the boost should be to the faculty and to the students who are sitting and listening quietly. So still I find, like a lot of integration of students to happen into these kind of forums. And I'm sure the faculty can take this message to the students who are not attending this conference. So I once again thank that this is a great opportunity for all of us to understand the national priorities and missions and integrate our capability and scale up our capability. And it's only the discipline, dedication, and innovation that can really make us success and reach our targets of Viksit Bharat. Thank you very much.
Thank you, sir. Your insightful address has reinforced the need to convert scientific research into dependable, accessible, and industry-ready technologies capable of creating a sustained national impact. It is my profound honor to introduce our esteemed chief guest, Professor Suhas S. Joshi, Director, IIT Indore. Professor Joshi is an eminent academician and researcher in advanced manufacturing, machining of difficult to process materials, micro manufacturing, and precision engineering. Before assuming charge at IIT Indore, he served at IIT Bombay in important academic and administrative roles. A fellow of the leading professional academies, he has made contributions to research and industry-oriented innovation that closely reflect the spirit of IMP 2026. May I now kindly request Professor Suhas S. Joshi to deliver the inaugural address. Over to you, sir.
Good morning to all of you, and welcome to this NATFOI Symposium. First of all, thank you, Professor Mishra, for inviting me and all the organizing committee. Just to show my appreciation, I'm wearing the same jacket you gave me few months back when I came here for other inventive program. So thank you. We have dignitaries, Shri J.D. Patil, President of INA, in the audience, Dr. Raju, Professor Murthy, and other professors and colleagues, and scientists and students from various institutions. Manufacturing is now changing from traditional manufacturing to digital manufacturing. So when you say digital manufacturing, the term looks good, but it's a highly, I would say it's not just interdisciplinary, but it's multidisciplinary branch. It has become a multidisciplinary branch. And where, you have to innovate in the sense that we have to know something of electronics, you have to know something of electrical, AI, ML, and then manufacturing also. Then only we will be able to innovate and create new products. Especially after COVID, we all realized that when the digital revolution reached the masses or the people at the lowest strata in the society, and at no extra cost. So that was one of the important things, that digital revolution went there, but the common people didn't have to pay anything extra. They now realize that the most advanced technologies can be coming to them at very minimal cost. And that has actually raised the expectations from both industries as well as the academia, that anything which comes out, they don't want only the theory, or they don't want only the, the concepts and ideas and prototypes. They want actually the product. So I was just looking at a very famous series of Titan, Titan watch, how it has evolved. And it is going on right now, some 6 episodes have come, that how J.R.D. Tata has decided that we should manufacture our own watch. And it's a big 6 or 7 episode program. And it has emerged from the market survey. Accidentally it has started, but the market survey has shown that almost 90% of the watches people were wearing in 70s were smuggled watches from abroad. There was no way to import those watches because they would become very costly. So these are all smuggled watches and coming through various routes in the country, and everybody was proud of wearing Citizen and all kinds of watches. And that is where J.R.D. Tata decided that why can't we have our own watch? HMT was there, but they were having a captive technology. So, and then when they decided, why do we go back to the old ways of watches, of mechanical watches? Let's go for quartz watches. And this quartz technology nobody was aware of the quartz technology. And then they actually got transformed, somehow managed to develop this technology, and entire this Titan watch plant came at Hosur in this. So one of the first watch the company manufactured was actually given to J.R.D. Tata. And when he went to meet various big industrialists, he showed that this is the watch which we manufactured. And the Swiss manufacturer was there, and he asked, sir, what is the time? He said 9:05. Actually, the time was 10:05. His watch had stopped working. So this is the first product of the Titan. It was given to J.R.D. Tata. He was among the eminent people, and they showed that your watch is not working. And so the Swiss manufacturer who challenged him earlier, saying that you cannot manufacture, said that I told you that time that you cannot manufacture watches. So what you are wearing is not the watch, but it is a prototype. It's not the watch. So JRD was absolutely devastated. His team was devastated, and then they went back to Hosur plant and then did again an inspection, and they found that there are a lot of dust particles which have actually stopped the watch. They corrected after some few months. They gave him again. They said, now this is not the prototype. This is the actual watch. So what I mean is that the time has come that we have to convert our research into technologies. Not only technologies, people won't wait for your technologies. You have to convert them into products, prototypes. That also people will not wait. You have to convert them into products and actually give them. So the expectations have surpassed significantly over a period of time, and nobody wants to wait for your research and your things to happen. But that doesn't mean that the research has to stop, but we have to have the translation of research, taking them into the products, into the technologies, and then taking them into the society. That is one of the most important things at this point of time. So I'd said some time back also that whenever a professor gives a project to a student, we must think whose problem I am solving. Either is the problem of a poor man, a problem of slum dweller, a problem of a soldier, or a problem of whose problem I am solving. Every project should be a problem solving, helping to solve somebody's problem. With these few words, I congratulate ISM Dhanbad for successfully hosting this program. We did at IIT Bombay some time back, and it is quite intensive. But yes, it is very educative in number of ways. And thank you again for calling me. All the best. Thank you.
Thank you, sir, for your inspiring and intellectually enriching inaugural address. Just to add on what sir had mentioned, so this is actually an interesting story. Titan is very famous for elegant, sophisticated, as well as stylish watches. The very first set that was launched contained Exacta, which was stainless steel watches, Classique, which was elegant watches, Spectra, Royal, and then Fast Track, which is very popular among the youth. So here we want to emphasize that you need the experience from seniors. We need the enthusiasm from our students to carry forward the spirit of IMP 2026. May I now request Professor Sukumar Mishra to kindly felicitate our chief guest, Professor Suhas S. Joshi, Director, IIT Indore. Thank you, sir. May I now request Professor Sukumar Mishra to kindly felicitate Dr. Ankati Rajuji, Distinguished Scientist and Director, DRDL, Hyderabad. Thank you, sir. May I now request Professor Sukumar Mishra to kindly felicitate Professor VMSR Murthy, Director, IEST Shipur. Thank you, sir. May these mementos remain a lasting expression of our gratitude for the gracious presence and valuable contribution of our distinguished dignitaries. To formally conclude the inaugural session, may I now invite Professor Alok Kumar Das, Coordinator IMP 2026, to express gratitude.
Respected dignitaries on the dais, of the dais, it is my proud privilege to propose vote of thanks on the behalf of organizing committee of 20th Symposium on National Frontier of Engineering and Innovation in Manufacturing Practices and also the E-Summit. At the outset, I express my deepest gratitude to our Honorable Chief Guest, Professor S.S. Joshi, Director IIT Indore, for his valuable time to grace this inaugural function despite his busy schedule. Thank you so much, sir. I extend my sincere gratitude to our guest of honor, Dr. A. Raju, Director, DRDL Hyderabad, for his presence and sharing with us inspiring thoughts and valuable guidance. Your presence has greatly enriched the symposium and reflects strong partnership among academia and DRDO. Thank you so much, sir. I express my sincere gratitude to our guest of honor, Professor Murthy, Director, IIST Shivpur, and also our senior colleague for his inspiring lecture and encouragement. I express my sincere appreciation to our director, sir, Professor Sukumar Mishra, for his valuable suggestion and guidance throughout this, for organizing this conference and symposium and also E-Summit. Thank you so much, sir. My heartfelt thanks to all the eminent speakers, fellows of INAE, scientists from DRDO, BARC, NPL, Tata Steel, SAIL, and other leading industries, as well as distinguished academicians from IITs, universities, startups, and MSME who have traveled from different parts of the country to share their knowledge and valuable experiences. I also thanks to the VCs present here and other delegates of the E-Summit, Mr. Rohit Kale, Mr. Ranjit, Dr. Balkrishnan from MIT, and Mr. Arijit for their presence and guiding our students, young students, and enriching knowledge for opening startups and valuable guidance, financial support, all those. Thank you so much, sir. Be here. I am also thankful for our sponsor, especially INAE, DRDO, Steel Authority of India, Ministry of Mines, ANRF, PAIR, then Kimberlite Chemicals India Private Limited, Mini Mines, Reschem Technology Private Limited, Ossini Magnets, Wadhwani Foundations for their support. Otherwise, it was almost impossible to organize this type of conferences, and also the innovation in manufacturing process. Finally, I thank all my colleagues, my team members, and student participants, and especially the young friends who are organizing e-summits here and making the event so successful, and inviting around 600 students, after that screening to 300, then finally around 150 students has come here to demonstrate, to pitch their ideas, to demonstrate their products. So thank you all. Thank you so much for being with us and making this event very successful. Jai Hind.
Thank you, sir. I request all the audience to remain seated after we formally commence the inaugural session because Joshi sir has to leave. So we'll immediately start with the plenary session after concluding the inaugural, and then you may proceed for high tea later. On this note, I would request everyone to kindly rise for national anthem now.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you, everyone. Kindly take your seats. The inaugural function of IMP 2026 is hereby concluded. May I request the other dignitaries on the dais to kindly join us as the audience as we hear Professor Suhas S. Joshi for the plenary talk. Sir, please. After Professor Suhas S. Joshi, we'll be hearing from Dr. Ankati Raju as the next plenary talk. So please stay back. Over to you, sir.
Okay, so good morning to all of you. Okay, so this work is which I am carrying out, not necessarily I am carrying out, but along with Professor Palani and one common PhD student, because now my all PhD students from IIT Bombay are over, they are finished, and now I am completely on this side, so very few, one or two students. But I do enjoy the process of innovation and research, so I keep continuing working with them. So this is a presentation on using the triboelectric phenomena for smart manufacturing applications, and what we call it as the machine skin applications. And there is one defense application also. So triboelectric nanogenerator is one of the new generation devices, I would say. It works on the principle of static energy, and you all have experienced in the winter season that when you remove the sweater, and then you find that your hairs are raised and you see the sparks, you experience sparks all around. Those sparks are nothing but generated because of the frictional energy converted into the static energy. Now, if you are able to, take those small, small charges, collect all those small, small charges and put into a capacitor bank, which can be further used by you for the purpose of, it can be used as a source of energy later on. So that is what is the tribo nano generator, a device which works on the static energy. Incidentally, in the nature itself, some materials are tribo positive and some materials are tribo negative. So some materials have ability to release electrons and some materials have ability to accept electrons, and that is where tribo positive and tribo negative kind of materials are there. And if you rub these two materials together, then there is a passage of current between the two. So take these two materials, attach two electrodes on the top of them, and then you find that from the circuit, the current is actually flowing. So it's a very small magnitude of current, but then this has a lot of applications. One of the applications we found is in the sole of a soldier shoe. And if it is put inside the shoes of a soldier, then not naturally it will undergo something called as the continuous friction, continuous movement, attachment and detachment, and then it will generate a small kind of power. Similarly, it can also be used for sensing the vibrations of the machines in variety of directions. It's almost like a piezoelectric crystals that you can sense the vibrations in X and Y directions and then or Z directions. The same way, these piezoelectric nanogenerators can be placed in various directions and they can sense the vibrations. And those vibrations can be converted into the again electric charge, and the charge can be sent back or it can be sensed, and it can be giving alert to some other device which will control the machine. So there are two applications here. One is for the control of the machine or monitoring of the machine, and the other one is for the shoe of a soldier. So the principle I have already explained that there are tribo-positive and tribo-negative materials. So for example, here aluminum is a tribo-negative material and this FEP is a tribo-positive material. They are put into a covering and then they are pressed together. So the current passes in one direction at one time when they come together, and when they go away from each other, the current is generated in the opposite direction. So positive and negatives, you get alternating current in this case. So this is the one which is explained here. When they are brought together, the current is in one direction. Then when they are separating from each other, the current is in the other direction. Now, this vibration-based sensing device has been placed at various places in a compressor. Like this is one, and this is one, and this blue one. And then it can sense the vibrations in one direction. So we call it as one-dimensional TNG device, two-dimensional or multi-dimensional device. And then it gives a signal, digital signal, to the actuator. And this actuator is somewhere here, that vibrations in a certain direction are exceeding the limits or whatever, there are changes in the pattern of vibrations or frequency or mode of vibrations, and then the sensing device or the IoT enabled actuator device actually then goes back and performs the controlling action. So you sense in one direction, then you pass on the information to the actuation device through a Wi-Fi, and then or IoT device, and then the actuator device actually controls the motion, and that is how this whole thing can happen. It's very cheap device. If you want to make a piezoelectric sensors in this direction, it could really cost you thousands of rupees. But this is like we are able to put it into a shoe of a soldier. So it's very comparatively very cheap and can be mass manufactured also easily. So another innovation which has been done here is that when the two surfaces come in contact with each other, how do I make the two surfaces little rougher? You have seen these sweaters and wool, they have furs, and those furs help you to create more friction. And when the two surfaces are there, they require some kind of undulations, and those undulations need to be created without disturbing the quality of the surfaces. And those undulations are created using, again, a patented technology, laser-based backside texturing. In the sense that if you take a conventional laser ablation process, the laser photons, incident on the surface, they actually evaporate certain amount of material. Some amount of material gets evaporated, some gets condensed, some remains there, some is melted, and that is where you get a cavity. But here it is not so. Here what we do is that we create a vapor here of laser because of the laser heating, and that laser heating, the vapor actually increases vapor pressure actually deforms the material. So when your two surfaces are contacting each other, you do not have the ablated surface, but you have a deformed surface which is fairly smooth. So you apply a laser, the laser vapor actually deforms the surface. Now it is so much so that you can move the laser on a surface, and it can create a ridge, or it can create a embossing of a particular size or shape what you want, depending on the type of the laser and depending on the energy of the laser. So this is a very important innovation by Professor Palani and his team. In fact, they have built a machine around it, and this machine is being now given to ISRO and I think DRDO also it is being given. So this is one of the things, as I was telling you, that innovation has to be done in such a way that people cannot easily copy. You all find that our legendary singer Lata Mangeshkar, she sings, and not many people can reproduce those songs. It's very difficult, very complex to come to that level of reproduction. So all of them are, whoever sings after her those songs, they are like a few steps below or many steps below. Nobody can match there, because there's a huge difference of level. So there is, every innovation should be something like this, that there should be a very key into it, which cannot be easily replicated. Otherwise, you do go to the market, the people will next day produce more than you. They will actually outsmart you in no time. And that is what the Titan watches, this program all of you must see. There is a series going on. I think it is on OTT platform somewhere. And you all must see that how they innovated. They brought directly they went to the quartz watches, and they faced so much trouble in accepting of that technology by a common man. They everybody was used to applying keys to their watches, and nobody believed that without applying key the watch can work. But these watches, they don't require, because they have a battery cell. So this is probably the heart of the innovation, and this process is something which actually helps the whole innovation intact, or not easy to replicate, because you require kind of high technologies and understanding of technology. So here there are a lot of experimentation which has been done. You can take a simple example of the polishing of your spectacles, glasses. You get spectacle glasses for 90 rupees also, and you get these spectacle glasses for 20,000 rupees also. The difference is that the polishing technology used by the solution providers abroad is so secretive that, or is so exhaustive rather, that they have done years of research and then they have come to that level of sophistication. So this is probably one of those that a lot of years have been spent into this technology, and then it has now been applied here. And it works, so these are effect of power, higher power gives you the best, the height and standoff distances. And then here it can be seen that at a scanning speed, at what lower scanning speed you get the best profile, which is deformed profile, rather than at the highest scanning speed. And then here, this particular diagram, which is a scanning electron microscope picture of the deformed part, it shows that there is no ablation which is happening, but it's only the bending of the surfaces which happens. So you can see the thicknesses at various instances are 176 and 170, and in between only there is a small thinning which is there, but there is no ablation which is happening. The deformation creates movement of the material, so there is a thinning which is happening, but there is no ablation, because only at the bend there is thinning, but here as well as here, 1 and 3 sections have the approximately same thickness. So, so a lot of work has gone into understanding the kinds of variety of texture patterns, etc. And then it is realized that the line pattern, straight line pattern, is the best for this particular application. And that is where this line, you can see that it has open voltage of very high value magnitude, and the current also is of high magnitude, highest magnitude. So this is the one which has been taken. Also the section which is created has to be repeatedly checked. So it has been brought in contact, brought apart, then cycles of contact and separation has to be tested. So it has been tested for almost like 1 lakh cycles, and found that there is a very small deformation on the sections which are deformed, and that's where up to 1 lakh cycles they can easily perform. So this is a example of a tank device. Here there is a vibration generator, and this is a power source for the vibration, whereas the output of a tank device is actually fed into the calculator, and then this is able to run a calculator. So instead of a batteries, now you can use this tank device for energizing a calculator. So as I was saying, that it gives a small amount of energy, and it can run smaller devices for that purpose. This is another example of the tank device on a compressor or vacuum pump, and you can see the signal which it is capturing, the vibration signal, and this is a enlarged profile of the vibration signals. You can now say that this is a normal profile of vibration signal. This is the flow restrictions. When we apply the vacuum pump, there is some restrictions in the flow of the incoming air, outgoing air, or you apply a load on the compressor, then the profiles change. Now you can see that you can generate a huge amount of data by running this tank device on a compressor, and then you can train a AIML circuitry for using that kind of a data, saying that this is my normal profile. This is when there is a choking which is happening, and this is when there is a excessive load, or there are certain restrictions in the circuitry, then this is the profile. So if you give the regular data and the fault-based data to AIML circuitry, it will be able to help you to detect or diagnose the functioning of the device. So normal running, flow learning, these are the various. So there is a loose bolt in a compressor, then what will happen? 2 hindrances on the fan have been created, then what will happen? So now you can apply the AIML technology and actually create much better solutions. And this is what it is, that you create the real-time data, and you have a predictive model based on the data. So the real-time data is flowing from one side, and the knowledge data, which you have already captured the knowledge, and that data is flowing, and then this is the place where there is a comparison between your stored data and your new data which is coming, and that is where you can say that a digital shadow of the device is now created. That my device may be running at some other place in the factory, but the signals from these are coming at my place. I have original data, I have a original AI/ML based model with me, and I have a Wi-Fi enabled, I have a data coming from an IoT device, vibration device. So I compare my AI/ML model with the online data, and I can tell that what is going to happen. So you are actually creating a digital twin or digital shadow of the device at your place wherever you want. So you can be here and you can diagnose what is going on in the machine at a distance place. So this is the example of the same. Now it is in the computer. Turning on the machine, then you can see on the screen of computer where the machine has been turned on, and the signals are coming out from this. Then you are introducing a flow restriction into the pump, because you are sucking air from a certain place, so there is a flow restriction into it. The profile actually changes. You have a load onto it, the profile changes, and that's how you will be able to diagnose the whole machine is turned off or whatever is happening. So I have a computer, I have a model, I have a digital shadow or digital twin of the pump itself, and I can now diagnose it. So same thing is done in the shoe of a soldier. So there are two Teng devices into this, and there is an RFID device at the center, Teng at the back and the front. And you can see this is the electronic circuitry. And Dr. Raju's laboratory we gave, he was the director of ARD when this 15 shoes of this kind were developed. So we got the shoes from, military shoes from them. We added the circuitry and Teng devices into it, and then gave back the 15 pairs of shoes. I think for 3 months our laboratory was working like a factory and produced those 15 shoes, and then these are given to them, and they are actually being tested in this field, that how these devices are actually helping. So this is what you calibrate. You run on your walking machine, and then you create the data, then you create, based on that data, you create a model, and you have now the knowledge of the model, and you have a new data which is created, and that's how they can be compared together. Well, that is what my presentation is. There are two applications, one for the diagnosis and condition monitoring of old machines, and then the old machines can start talking to you what is happening to me or what is happening to them, and then this is a new application for the shoe sole of a soldier. Thank you very much. I hope I'm in time.
Thank you so much. From audience, anyone has any questions for sir? Sir, please.
It's better on this side. I can see everybody.
Hello, sir. This is Dr. Ajit Bhattacharya. Congratulations for the excellent presentation.
Thank you.
Just a quick input and understanding when we are talking about digital twin. So we make smart cities very, very deeply. So the technology, I feel, should go towards extended reality, XR, along with digital twin, which can create a complete replica in multiple different iterations at the same time. Are we done with that? That's the simple question. Have we done anything on XR with the same similar kind of vibration yet?
XR means exactly?
Extended reality. So if we combine virtual reality, augmented reality coming together in our device, and we project that with a hologram, and it replicates the exact imaginary. That's extended
So,
reality.
so we have another project on digital twin of human body. I think there we are using those virtual reality platforms for creating the another data or information.
Okay.
So it depends. I mean, I would say that it requires a sensor.
Yes,
Basically,
yes.
it requires a sensor. The sensors can be of any type. So I'm not sure smart city. You are saying what kind of?
I'll try to explain, sir. We are partner of Intel and Microsoft. We
I
build
see.
products.
Okay.
So what happens? There is a motion sensor device
Okay,
connected
yeah.
with your hand,
Correct.
pretty easy to get, and you have a VR device, and there is a projector with a hologramic projector segment, and we can do multiple iterations at a time in thin air. That's it. There's no other thing. So if we do that, what happens? In one iteration, from multiple different time zone, multiple people can use it. So it becomes
Maybe
easy.
you can talk to us. We have a very big project on, as I said, digital twin of human body.
Sure.
And I'm sure some application of your system could be found out, could be applicable there.
Thank
That's
you so
what I'm
much, sir.
thinking.
Thank you.
Thank you.
Thank you, sir, for your talk. So I have two questions in this regard. So one is regarding the energy harvesting. So is it frequency dependent also? I mean, at particular frequency you can harvest maximum, then there will downfall or something like that?
It's a low frequency device.
Only
Right
also-
now it is, we are experimenting at low frequency, yes.
Okay,
Yes, it
and,
is frequency dependent.
And so for
Not
high
the one,
frequency you have not tested.
not very high frequency applications.
Okay.
Much of these are low frequency applications.
Okay,
yes.
second thing, which two material you found the best counterpart which we can use?
Right now, this aluminium and one polymeric material, these two materials are there.
Aluminium and what is other?
There is polymeric material. This is tribo-positive and fluorinated ethene propylene. So this is another material. So these two materials can go together, but there are many materials of this kind. Some are tribo-positive and some are tribo-negative. So we can
And-
choose depending on what is availability
And this is completely depending on the friction. I mean, if you can make the multi-stack and you can add in
you
series, then
probably can make multi-stack. We have made a single stack, but yes, it is.
multi-stack can give more
Yeah, I
harvesting
mean,
kind of thing, right? Okay.
See, yeah, this is the initial thing. But you know, instead of multi-stack, we are doing multiple tank devices in different directions rather than stacking them. This is a one way of stacking because you are sensing certain vibrations in one direction, then second direction, third. So we require three devices. But can they be linearly added the way piezoelectric crystals can be added? I mean, that we have to check. That we don't know about exactly about that.
Okay. Sir.
That kind of stacking we don't know, but this is the stacking. You know, like distributed stacking of the tank device is possible.
Okay. Sir. Thank you.
Thank you.
Sorry, audience, I think we are running.
One question, maybe.
So you have attempted several structures.
Yes, several devices.
Straight line giving best performance. Have you,
Huh?
or you say that a straight texture is giving better?
Then that is where the tests were conducted, the output was conducted. The output was giving, whichever was giving maximum output current, that is what is considered as the best one. That is
the experimental. What is the reasoning? You have any reason behind that?
From?
Or any reason behind why straight line performing better?
Well, the contact and, basically it should be like a contact and separation, but surfaces should be rough. If you provide two, varying textures, then you probably lose a control over the contacts and it becomes very random process. So better, the best one is like linear textures are giving a better results at this point.
Thank you, sir.
Okay, thank you.
Now I would like to call upon Professor Amit Rai Dixit to felicitate Professor S.S. Joshi. Thank you, sir. For the next plenary session, I would like to call upon Dr. Ankati Raju for his presentation.
Good morning to everyone. This presentation will be slightly different when compared to the last one. This will be mostly on application of the, the advanced manufacturing technologies in defense applications. So, copy, it's not shifting. Shifting? It's not shifting. Mhm. Yeah, sorry for the inconvenience. The presentation will be on basically advanced manufacturing for aerospace and defense applications. This will be the outline of the presentation. In defense, you all know that we use extensively various kinds of materials and different processes. So the materials constitute the composites, polymers. Then we have high strength materials starting from maraging steel, stainless steel, armor materials, and also the superalloys which have come into force for defense applications, titaniums. We use these materials extensively in missiles and fuel tanks and things like that. Also the composite materials are used in missiles. Many materials are used for making the rocket motors and airframe sections. The need for the advanced manufacturing technologies. As you all know that in the times of 1960s, 50s, where we used to make our missile systems, we used to take a lot of time because of the, at that point of time, existing manufacturing methodologies and process. And I still remember that when we used to go for the testing of missile systems at ITR Chandipur, we used to take almost 3 to 4 months to launch a missile system. Now, till recently, if you see, we build the missile in a shortest span of time, maybe 6 months or so. But then when you go for the missile launch, we don't take more than 10 days. So this is all because of the manufacturing process, the technologies which have come in force, and then it shows the improvement in the process what we are following, and the accuracies, precision, what we are able to get with the advancement in manufacturing process. So you can see the quite sea change in the process of manufacturing. See, for any progress in any system, we need to have the advancement in each and every field. So manufacturing also is one of them. Like I have already told, we are making progress in propulsion systems, navigation, avionics systems, and things like that. And also similarly, the manufacturing technologies are getting matured, because of which we are able to develop such kind of systems. So it shows the need and the way we are progressing in the manufacturing technologies. Basically, because of which we can, the systems what we make should have low-cost solutions, and also reliability has to go up. The defense systems, the precision and reliability are very important. Unless otherwise we are able to make, high precision components, it is impossible to meet the requirements. And also, as of now, we not only make the systems for ourselves, but we need to make the systems for other countries also. Make for the world, that's the slogan which is given by the Honorable Prime Minister. So we are working towards it. Unless otherwise make reliable systems to meet the best performance, we cannot export. That is the order of the day for making these systems. So we need the high strength materials, and then the missiles what we make, they travel with extreme high velocities to the order of hypersonics, that is beyond Mach 6 or so. So then we require high temperature materials, and then the manufacturing technologies that like near-net shape base materials, and of course, as you all know, that the additive manufacture is playing very crucial role. Now, as you all know, that the advancement in finite element systems modeling has come, then we are able to analyze properly and then make the systems with precision. Manufacturing process have matured, and then we need to make them lean manufacturing, and also we should meet Six Sigma kind of requirements are there. Quality control has been improved. Now laser techniques have come, computer-aided systems have come, coordinate measuring systems have become more matured, because of which we are able to make very advanced systems. And then we will spend some time on what progress we made in terms of manufacturing process. Similarly, the systems have gone up better, the materials have become more and more high strength materials have come into force, because of which we are able to make progress. So the drivers for these advanced machining technology are cost, time, quality, reliability. These are these things we should follow it. And then how it is possible is that the performance measures are, high material removal rates, high accuracies, less distortion, and clean environment. These are some of them. So the advancements, as you all know, that we are able to make with high spindle power, then rate of material removal rates have gone up. Precision machines have come, and of course, multitasking we are able to do, like in a single machine, we are able to do many, like milling, turning, and many more, drilling, everything is possible. And multi-axis, yes, we are able to do a lot of things. That means in a single setting, we can, make the final product. Previously, we all know that we used to go in a staged manner where it takes more time and stage inspections are there. Now all those things have gone by, and then advanced CST controls, CNC controls have come. These are some of the examples of how we progressed. These are all actual products what we are showing in this, which are used in missile applications. And then because of precision machines, you can see here, it's a mechanical actuator block, wherein the actuators have to sit, and then it is made in a probably in a 2-3 sittings itself, and sometimes in a single block. So these are the ways now we are making it. The seeker is a very complicated system, which is a radar system which exists in the missile, and it seeks the location of the target, and it high precision the technology is residing over this. And then you can see here the honeycomb structures of shells, airframes for missile systems. Now mostly because of multi-axis and the multi-machining process have come in force, we are able to do them in a single setting itself, in a single machine. And this is the interstage. These are the internal products what we make, very high precision. The systems are made for aerodynamic testing, where we need to generate the data of the missile system. So then coming to the advancement of machining technology, high-speed machining has come into force, wherein at this point of time we have graduated from increasing the speeds from 8,000 to 50,000 RPM, and then high feed rates have come in place. And then you can see the smallest features in the components. Rib thickness is close to 0.3, 0.4, and then slot width and depth have considerably reduced. As you all know that now our systems, we are making the systems for the design. That means we used to make previously, based on the limitations in the manufacturing technology, we used to design the article. But now we are designing to the exact requirements, because the manufacturing technology is so matured. That means there is no addition of weight, there is no addition of extra things which I am carrying in the missile system. It is to the exact shape of the system we are machining. That's where the advancement have gone in. Now coming to the ceramic materials, as I already told, we have graduated from subsonic to supersonic to hypersonics. So in the hypersonic systems, as you all know that we travel beyond Mach 10, and then considerable amount of time, not only like re-entry kind of a vehicle where it is only a fraction of second or something like that. But then the hypersonic missiles travel for a long duration at that speed. So the normal materials doesn't suit there. So then we need to use carbon silicon carbide tiles and things like that. So there are special materials with high hardness and high brittleness, and of course they are highly abrasive material behavior. So we need to develop a new process to make this to happen, so that the temperatures of the order of 3000 degrees centigrade or more than that, we are able to meet the requirements, and then they have to be formed to that shape. As you see here, see, this is a glide vehicle what we are in the process of designing, hypersonic vehicle, but then the regular materials definitely don't fit there. So we need improvement in the process. A lot of tooling has to be done so that we can meet. This is one more thing, the silica tiles, like spaceship kind of thing, what NASA was having. This is a hypersonic cruise missile which we are designing it. So silica tiles are designed and made to suit the contour of the vehicle. It was a quite difficult task for us, but then a lot of research has gone in, and then we could able to make. And then, in fact, I must say that we could test this for a long duration of 1200 seconds for a high temperature applications. Successfully we have done recently, wherein we are going to go for a launch at the earliest, probably in the next year or so, to meet the requirement. And then you all know that how we made progress in abrasive water jet machining. The principles are known, and it finds a place in making very critical components. Initially we used to use only for material cutting, but then based on the advancement in technology, the components to the exact shape we are able to make. And then also this is a abrasive water jet milling for a scramjet engine application. A 2x2 channel was made. It has got good advantage in terms of time and things like that. So it was made and tested successfully. I will show some of the pictures wherein the scramjet engine and then liquid fuel ramjet engine was also made in DRDL. These are all, this is the advanced metal forming process. You all know that previously in the beginning stages, conventional metal forming, we used to do it, like wherein you have to give a tolerances of 0.5 mm or more. But then with the advancement of metal forming technologies, we are able to make to the exact shape and size. This is the advantage what we could get it. And then there are, of course, many process, like this is a non-circular spinning process. It's unconventional, but then by making use of the proper mandrel and rolling process, and then this is a radial roller feed and axial roller feed, we can make this kind of systems as shown here. And then the dieless sheet metal forming is done by using the machinery what you have. You make proper tool, and then you implement the solution onto the components what you are able to make. So these are some of the examples. These examples what we are shown are some of them are from literature, and some of them mostly on our own, DRDL what we are doing it. DRDL engineering, technology is very matured, and that's a excellent, center of excellency for all missile systems program, which is we are able to make it. Now coming to the flow forming process, you know that this is the best of technology what it is made now for missile applications. You can see the flow form shell with with the 60 mm to 600 mm diameter, and with a length of 3 meters or beyond, we are able to make for missile applications. The materials what we use are maraging steels, 15 CDV6 and things like that. And this advantage is that we can make to the required shape and thickness. You can see, of course, you need to have a preform, and then mandrel is required. You have to roll it, either like 2-roller configuration or 3-roller configuration. You can make in different shapes as shown here. You can have a convergent section or divergent section, and these are all made in-house in DRDL with for our missile applications, mostly for airframes and the propulsion systems. And of course, these are the futuristic things where you can incorporate various features on the flow form shells, which will reduce the timelines, and then also the quality will improve, the accuracy also will be better with these systems. Now, of course, the order of the day is additive manufacturing. IIT Dhanbad and many educational institutes are working exclusively on this technology. DRDL is pioneering in additive manufacturing. We have established, and also with the help of my colleagues, we have made many systems in-house, and also we are going to establish one of the state-of-the-art additive manufacturing technology center in DRDL in the coming 2 years. And of course, all of you know that there are various process of additive manufacturing techniques are available. And some of the examples we'll show, these are the, of course, advantages. You will get the solution time, lower cost, and improved performance. And then, all these complicated systems you can make within a very short span of time. And then it finds a lot of space in the propulsion systems. You can see here, especially liquid propulsion systems. It's the best system, best technology which we can use. And based on this, yes, you can. Yeah, you can see this, some of the systems what we made in DRDL. This is one of the wind tunnel component, and this is a gas bottle, and there are many more components are made here. I will show you, yeah, these are quite interesting things which we have shown here. This is a scramjet engine what we have made with additive manufacturing technology, which was tested for more than 1,000 seconds. And now our aim is to make the systems for the future. These are the liquid ramjet systems, sector stabilizers, fuel injectors. These are good ones where you don't have requirement of high surface finish. But then there are good techniques are coming up to improve the surface finish also in the internal passages. They are coming up, and of course we will find it at the earliest. Now with the help of educational institutes, laser-based powder directed energy deposition technique we have used. IIT Hyderabad has made this kind of a system with a diameter of 2 meters and the length of 3 meters. It's made in IIT Hyderabad. Now it will be shifted to DRDL, and then we can attach the robotic systems to the additive manufacturing systems, and then you can make completely like it is wherever you want it can be made, and then it can be used. That's what is the order of the day now. Robotic systems have come in place, and then you can make much bigger systems as per the requirement. So everybody knows on this. Now the surface engineering also plays a very important role in missile systems. It has to be properly protected for the environment, what it is, saline environment. We need to increase the shelf life of the systems beyond 15 years. So they are required, right? So then the radomes, which where our seeker sits there, RF transparency is required, and a lot of coating process have been established in DRDL, and also the low emissive coating for the internal diameters for composite airframes have been developed, of course with the help of educational institutes. And now of course you need to improve the hardness of various materials. The plasma nitriding has been done, and these are all I am showing the actual systems what we have made, and of course the lubrication for bearings and things like that. The sputtering process are used to improve the friction in the systems. So once again, the spinneling technology is used for forming protective layer of ferrous oxide in the system, and there are many more coatings are used for rocket motors systems like maraging steels, 15 CDV6 and etc. This is one of the system, the TRIA stabilized zirconia barrier coating was developed with the help of ARCI Hyderabad and other partners. This is extensively used in DRDO missile systems. It is used as external coating as well as internal coating with a thermal conductivity of 0.9 watts per meter per Kelvin or so at 1500 degrees. Whatever you have seen the scramjet engine combustion chamber, we have coated with ITRIA stabilized zirconia, and then we have tested successfully for more than 1200 seconds. That means more than 20 minutes or so. That was the achievement. It was a big news in about 2 to 3 months back. You would have seen it. It is because of this technology what we have made. Of course, metal joining, yes, conventional welding processes are there, but then we have not stopped there. We have established electron beam welding. These are all for our internal systems. This is a propellant tank, titanium propellant tank. This is a 3D printed thruster which was made in DRDL, and of course we have laser beam welding where the heat input is very low, and then time it takes is very less, and so that our production numbers goes up, and of course the spot welding techniques are more useful where our thickness of airframes is very less, to the order of 0.3, 0.5. We join them with the spot welding process, and then in fact they are being used by our users also. This is a based on the technology what we make. And of course, there is a cold metal transfer welding is there. And because of which the propellant tanks and things like that are welded in DRDL. And then of course, TIG welding is always a process where we extensively used. All our rocket motors are used with TIG welding, and EBW also. The composites extensively used in missiles as well as aircraft industries. And some of them I will show you here. These are the actual composite rocket motors we make in-house to the diameter of maximum diameter of 2.5 meters. And then the advantages are higher specific impulse, better fatigue strength, weight is the advantage what we get it, and mostly we use them in strategic missile systems, ballistic missile systems, Agni and underwater missile systems they are used. So we have good facilities in DRDL to make such kind of things. Of course, now this is not our thing. We took it from internet where automated fiber placements because carbon fiber has to be placed over the mandrel and it is to be automated, and this is the one what it is going on elsewhere. Of course, smart manufacturing, yes, we need to connect each and every one, and so that we become lean. At the end of the day, there is no wastage of material, and then time is very less. We need to adapt to the industry requirement. 4.0 is coming up, and then we need to progress in terms of timelines. So the conclusions are the advanced manufacturing essential for each and every one of us. And technologies, what it has been developed, many systems have come in place. But then innovation is the driving factor for all of us to make the systems futuristic. And at the end of the day, we meet the requirements of defense industry. We need to transform the aerospace and defense industry by enabling the production of lighter, stronger, and more reliable mission-critical systems. So with this, thank you. Thank you so much. Any questions?
Do anyone have any questions from?
See now, yeah. In DRDL we make less numbers because we make it for meeting the prototypes, maybe 5, maximum 5 or so. Our idea is to establish the process, but then after establishing the process, we transfer to the industry so that the numbers are made by the industry. We never produce in DRDO any system, but then finally we make the industry partners comfortable so that whatever we develop, the process, we transfer it to the industry. Thank you. Yeah, thank you so much.
I have one.
Yeah, please.
So you have used 8% zirconia
Sir.
for the thermal coating barrier.
Yeah.
So actually, why don't you use lanthanum phosphate that is cheaper, and IREL also making in the very bulk quantity, you may be aware. In Itria, we don't have in our source.
Yes.
So it will it will give the same property.
Yes, sir.
So
Sir, we are going ahead on that. In fact, we are working on it. See, basically, these systems are more useful for our, as I told, the high temperature, external, internal, and things like that. So this is the way we started. Of course, we were somewhere else, but this is the one at this point of time. There is a next level of thing is going on, sir. So I think we are good to go to that. Yes.
Sir, I'm Chaudhary from BARC.
Yeah.
It's a huge amount of work you have been doing.
Yeah.
Very nice. Thank you. Congratulations for it. See, for additive manufacturing component, can they be used for, kind of a loading components where that component has to take the load? Is it used for taking the load part, or is it kind of a peripheral systems, or?
This statement is true probably some 6-7 years back.
Okay.
But now all the systems what we are making can take the load.
Okay.
And then we are making for the actual application only.
Okay.
Yes.
Thank you. Thank you.
Yes, sir.
Yeah, so in on first slide, we saw that you mentioned graphene is very applicable as far as advanced material is concerned.
Yeah, yes.
But in later subsequent slide, I did not see any application, if I did not miss anything.
Yeah.
So my question is, how much confidence you are for graphene as far as EMI shielding or heat spreading is concerned? And how positive DRDO is for graphene?
There is a research going on in graphene utility in our defense applications. In fact, I must tell you that we are yet to find complete solution as a graphene in our systems. So that's what at this point of time I can tell you that.
So what would be your response if some academician will be ready
Yeah,
to
very
give you
much.
graphene with
Very
heat
much.
spreading?
DRDO is very much, probably you may understand that DRDO is spending almost more than 1,000 crores for the R&D applications for our problems. There is a lot of scope to do research in graphene applications to DRDO.
Okay.
We
thank
can collaborate, and we will connect it to the our people towards that.
So which is more convincing, EMI shielding or heat spreading?
Sorry?
Which is more convincing, EMI shielding or heat spreading, or both? Which is more important for you?
First one, we are looking at it at this point of time. Yeah. Sir.
Because these inventions that you are making in DRDL,
Sir.
This patenting process, and then when you said that you transfer it to industry,
Sir.
How do we actually handle this, intellectual property and then the secrecy or repeatability or?
Sir, as far as the patenting is concerned, the basics of it we, do the patenting. But then, sir, finally, it has to be produced for me. So
Industry will take it forward and then they do
Yes,
the
sir.
patenting. Will it be a joint patent with DRDL?
Sir, the patenting, whenever we are doing something with the, educational institutes, it's a joint patenting, sir.
Okay.
But then the
With
production-related things,
Okay.
yeah, we
So
don't.
it scales up and then
Yes, sir.
industry will take the lead there.
Yes, yes.
Okay. Thank you.
Thank you, sir.
Thank you.
Now I would like to call upon Professor Alok Kumar Das to felicitate Dr. Ankati Raju. Thank you, sir. Now we would like to take a small tea break for 10 minutes. Everyone in the audience, please be seated just for 2 minutes. Will be resumed shortly. Thank you.
Session 4 of 20th Symposium on National Frontier of Engineering, NAT-FOE 2026 and Innovations in Manufacturing Process, IMP 2026. It is as being hosted at IIT Dhanbad. So we're now moving into highly significant and strategical important theme that is we are going on, that is manufacturing and integration of antennas and RF structures and RCS control technologies and stealth defense platform. So for this theme, the integration of these advanced antenna systems, RF structures and radar cross-section control technologies is playing an increasingly important role in development of next generational stealth and defense platforms. Okay. We are indeed fortunate to have us distinguished experts from academia, research, industry who are willing to share their knowledge and perspective on this important theme and for various technologies for these subjects. So I now my pleasure to introduce our distinguished keynote speaker, Professor Debatosh Guha, FNAE, Professor of University of Calcutta. Professor Guha is a renowned academic and experts in the field of antenna, electromagnetic engineering, and related technologies. His expertise in experience and contributions for the field making it ideal speaker for today's theme. Sir, we are privileged to having you with us. Can you please come on the stage? And may I request Professor Debatosh Guha to kindly deliver a talk. Give her a round applause.
This one. Anyway, thank you for kind introduction. Thank you. I decided to address you by saying good morning. It was intimated according to the schedule. But anyway, good afternoon to all of you. In this session, morning session, we listened to 2 keynote talks by 2 outstanding speakers. So I'm afraid it may be disappointing, the third one for you. I heard about this conference earlier, but this is the first time I am attending. So thanks to INAE, thanks to the organizing team, director of this institute, Professor Mishra, and my very good friend, Professor Gangwar. So thank you for inviting me. I'm starting at 12:15, so my time up to 40 minutes. Thank you. Can I have any slide change or anything with you? Or I should press this one? The scrolling part, it is different campuses of our university, University of Calcutta. And interestingly, I find some correlation or connection of 1926, this institute was founded. And 2 years before that, University of Calcutta introduced electronics and wireless teaching. In 1924, that is the second institute in the globe, entire world. The first one by Columbia University in New York. Second one is University of Calcutta in Calcutta. And third one, the third institute that started teaching, that is University of Michigan, Ann Arbor. So you are the second. Well, I'm using this one. So I start the topic. It is not like the earlier topics. I'm trying to address it from different perspective. I'm start one very specific challenge that was addressed historically by Marconi. When Marconi started working on antenna, can you guess what was his age that time? 1894. He was just touching 20. And to him, the first antenna, that is a dipole antenna, came in the form of two horizontal pieces of wire that is shown at the bottom. He is the first engineer or first scientist who realized that this antenna won't serve his purpose. So sitting in his own town, own city, Bologna, he made it half. So that is the birth of monopole. Within 3 years or 4 years' time, he came to England. His mother was British. And he planned one massive experiment, that wireless experiment across Atlantic, the west coast of England to east coast of Canada, Newfoundland. He took 3 years' time to build his apparatus, and particularly he took the charge of erecting his own antenna. That is on seaside in Poldu. That is was first antenna. And unfortunately, when he built this antenna in the month of April, I'm sure from the student side you have no experience of visiting that part of world, but many senior people definitely you have visited during that time, and you experience the pressure of wind in the entire part of Europe, not only England, in the entire part of Europe. So the whole antenna collapsed. He made his antenna, the structure you are saying, it is very interesting and important for antenna engineers, because when your science is over, we got the antenna in form of its science from Henrik Harge. The rest part that Marconi handled, it is engineering. So 20, the big structures, so he realized that this is not the right structures, I need to do a different antenna engineering. His second antenna engineering he did, it is a kind of fan beam, because he thought it is easy to handle the pressure. The air will pass in between space, so it is not going to affect the structure heavily. Mechanically what happened, I don't know, and nothing very specific is available what happened, but Marconi did not use this second structure. And very quickly, you see the timeline, April to September, October, November, December, within 3 months, he made the final antenna. The structure looks like this. Instead of 20 big structures, he took only 4 and made his monopole very streamlined. Unbelievable thing, that a person did this entire experiment in the month of December, December 11, 12, and 13. And December in Canada, particularly in Newfoundland, it is covered by snow. Why? Because everything is fine, but we cannot predict the antenna will persist up to that, the end of January, February, March. April would have been the best time. But his antenna engineering was so robust, so perfect. So I show you the second picture. That picture was taken in the month of July 1903, after 2 years. That means the same structure persisted over there for 2 years for his extensive experimentation. That engineering part was very robust and straightforward. So my own learning and understanding is that you will have to solve your own problem. And when you are trying to do some experiments, it is not only antenna, anything else. So in first chance, it may not give you the best result. Or the other parts of engineering, that you are doing antenna engineering, but you are not concerned with the mechanical part, that is not the right thing. After all, at the end of the day, it is the engineering. It is the experiment. And anyhow, you will have to execute it. So this holistic approach, that intricate vision and understanding is very important to every researcher, every engineer, every professional, of course for students. The rest part of this talk is based on my own understanding and my own story. And I have several interactions with Ravi because I am not very confident about the audience. And I'm always not very confident from my side that what to say and how to say. So I have chosen few very significant parts of my journey and understanding. So this is one that is important to follow for a researcher. Research problem, particularly those who are in research or in the master's level, they are thinking in PhD, and young professors, it is our problem. Particularly in this country, we have very limited feedback from industry, or R&D side, that this is the lacunae, we need it, you solve it for us. So sometime we need to find out our own problem. So exactly in the same way, it is our task to learn many contemporary works. So I was reading this paper. I realized few parts and I did not realize few parts. The purpose of this paper, Japanese paper, that is acceptable. Actually, what is shown, that the paper or this work was done to filter out some higher harmonics. Actually, when you are integrating your antenna in one system, there are many active devices. And active devices, the nonlinear part of the device, that generates harmonics. So you cannot avoid harmonics. So it is better to avoid harmonics in case of integration of antenna. So they did this work. My question was that you are trying to address the antenna, particularly the feed, but you are addressing the entire antenna by some kinds of defects beneath. I had no idea about those defects and their parts. Then I tried to understand what is this. It is actually during 1990s, when we were doing research, EBG term was very common. The first it is came as PBG, photonic band gap crystal, then is electromagnetic band gap structure. Nowadays, you explain and you work on different types of structures, and metasurface metamaterial is one of them. So every one has its own periodicity and interesting features. So it is like that. You look at this picture on the right-hand side. A simple microstrip line, but beneath there is lots of holes and is perturbations. Well, so it is for this periodic structure for the use of filter. Suddenly, we noticed that one group reported that we don't need so many defects because it is after all perturbation in the system. So one single defect will work. What's that? When the current is flowing, you look at that, when the current is flowing through this transmission line, it is stopped. And you cannot stop the current, it will take its own path. So it will take a different path, and effectively it gives some capacitive and inductive effect. And ultimately you are going to get one equivalent LC circuit that is pure band pass filter. So that was the principle. Perfect. But I did not like this because you are going to affect the entire antenna body. So I chose only 2 defects to temper the boundary condition, completely different perspective. Why? Because the boundary condition is along this axis, it is a kind of conjecture that it may help us. How? It may stop to excite one weak field or weak resonance which may create, I did not know that one, which may create some orthogonal polarization and cross-polar radiation. But the perturbation should not affect its primary radiation or primary mode. So one mode will relax and other mode will be killed. Problem was, the challenge those days, 2002, 2003, we are not equipped with this modern simulator. So just theoretical estimation, your concept, fabricate, do experiment. So we had the first option, that some calculation and fabricate. Very simple thing. That is also another aspect, that sitting in one Indian university, Indian institute, IITs are different because IITs are now rich institute or one of the top institutes in this country. So they are getting huge amount of fund, money, so they can spend for their good experimentation. But in poor university, particularly 20, 30 years ago, it was not possible. So our next phase was to do experiment. The first phase experiment, when we did, we found it is working because I am getting the resonance and resonance in the same location, and that was also my intention. But question is it going to radiate? I am trying to find out 1 to 5 dB order accuracy. And that's why the dynamic range of the chamber should be at least 80 dB. It was not available to me that time. Probably the electromagnetic engineers, antenna engineers, you can follow. If you don't, you just try to learn this one, the dynamic range and why it is so important. So I did this experiment. Within few months, I had opportunity to visit abroad. So I carried this one with me, and the experiment was done. And see this, my first attempt gave me the first result. The red one gave me 5 dB separation. the first success came to me. It's a completely new idea, new structure. Immediately, I published this work, and that is the first work we published. The antenna community first got that idea that the DGS, which is specially used for circuit, it is also possible to be used in your antenna structure. Within few years' time, HFSS, at that time HFSS just transfers its propriety from Agilent to not Ansoft, before Ansoft, because they have changed their hands multiple times. Now it is by some other company. Anyway, so that first gave us confidence that what he conjectured, that is visualized, that this orthogonal resonance is completely killed. Then I started reading the fundamentals of cross-polarization. I did not know about that. But without going through all these fundamentals, some idea came to my mind, and I executed and published a work, then started the entire theoretical analysis and more intricate part. So that's why I realized later on, that's why I always share with my students and also to you, that don't wait to learn everything and then start for your innovation. Innovation is a state of mind. Today, many people discuss this term, that innovative mind and innovation. So you have to be innovative from the very beginning. And the course of your activities will give you opportunity to learn more and more fundamentals, more basics, and give you opportunity to improve your innovation to the topmost level. I'm coming to this point very quickly. Suddenly, in 2005, I experienced another challenge. I received an email from one industry. It is completely different story. They had some demand from Spotwave. What is the demand? The crazy demand. Suppose you have a bucket. They told that this is my present shape of bucket, this is the weight. I don't like it. You make it simple, sleek, small, reduce the weight, but you will have to give more amount of water. You are telling me to reduce the volume. You are asking me to reduce the weight, height, and everything, but you are asking just the opposite, the contrast of this demand. So my advisor, he was not very confident, and in the afternoon, he came to my office and told that what to say. Should I say no? I think it is, you have gone through and you have seen it is not possible. I told, yes, you are right, but my philosophy is not to say no at the beginning. You have enough time to say no. So first we give some try and see that what's inside. Because it is the demand by one American industry. Their demand was in terms of antenna gain. They asked for one antenna, and they asked to increase the antenna gain and bandwidth together, but we had to reduce many things out of that. So apparently it is absurd. After a week, I'm not going to the technology, I'm going to the happiness. The problem was solved. Problem was solved, but that started the new problem. What's that? Then we sat together. Because today you are listening to manufacturing things, many things. So my experience of the manufacturing in North America was completely different. So I sat with them, decided. Then it was completely frustrating. Why? To me, 1 dB is more important, but to them, $1 is more important. They hardly care 1 dB. They want to save $1 during manufacturing. To me, the design should be elegant, novel, so I can publish. To them, no, it has to be simple. If we make it too simple, so it may not be that elegant, and that is not giving you mileage. So our intention, or our researchers' intention, is completely different. So anyway, so based on that, we had to do multiple sittings, multiple compromise, and finally, it came as a product. It came as a product, and they won the game. They made it simple, and they made it dollar efficient, not dB efficient. I had to compromise 2 dB. For me, 2 dB is the big amount of gain that I'm going to lose. So anyway, ultimately, it is the product, and it is still the product. It is now available in North American market. In 2012, I faced another challenge. Have you heard this name of NCAR, National Center for Atmospheric Research? It is in Boulder. It is American Atmospheric Center. They wrote to me. First they praised some works that actually, based on that defected ground structure based development. But after that, they told that your work cannot address this part. What's that? That is the antenna is suffering not in cross pole, not in the orthogonal plane. It is the diagonal plane is the dangerous one. So to make it useful, you'll have to address the diagonal plane. So I got this message from these hardcore engineers of NCAR. And I realized that it is really a big challenge because the antenna engineers, they don't know this. You see this year of publishing, you can get this here, it is visible. So from that time, 2012, finally we could find some solutions after extensive developments. 2020, 2022, 2023. So 3 significant works by 3 different groups of students. They're working. What is the significance of these works? The moral of these 3 works is that the main culprit in the antenna design is its conduction current. And that conduction current, it is contained in the entire body, particularly the ground plane. The entire antenna output print, that is, we call it the near aperture field, it comes from this current. You look at this, if you can control this current, the intensity of your cross-polar radiation can be reduced to what order? You can visualize. The red is the strongest one, and blue is the weakest one. How many minutes? 5 minutes. I'm trying. You show. See this. The impact when we really can control this ground plane current, how it can benefit you. First example, This is the shape of the ground plane. And that ground plane shape was conceived based on our understanding from these earlier works. This is the nature of this cross-polar radiation. That is my main concern. Suppose we don't know this engineering, we don't care, we just use our traditional ground plane or traditional configuration. So can you see the same scale? What order of solution or what order of separation you can achieve? Second was more interesting. This is the work to estimate two different components of current. One is your copolar current, that is our healthy current, and cross-polar current, that is unwanted, unhealthy current. So unhealthy current concentration, can you observe from this figure where it is concentrated? At all four corners. So what is the easy solution to you? Just remove the corner. Simple solution. Question is it going to happen or going to help us? Your theory, your observation says that it is fine, but after operation, the patient is good or bad? So let's see. So you see the two examples. The same action was taken, one for one circular, one for one rectangular. Can you see the solution in the diagonal plane? It is 545 degree. When 590 degree, that is your traditional orthogonal plane, very marginal. So unnecessary, for last 50 years, we have been using this entire ground plane without taking the truncation. Once you just truncate it, it is the easiest solution. Unfortunately, we did not apply for any patent that time. So all these different types of works and challenges, we observed that on this area that we started in 2005. So all these books covered one by one, 11, 13, 14, 19. And I was facing pressure from my friends here and there, many students, my friends from abroad, that it is the high time to make one comprehensive report from your side, and along with some science and physical interpretation that how this engineering could be effectively implemented. So finally, with two of my former students, my collaborators, completed this work. Probably you agree. Challenge never ends. It only changes its shape, its form. So if you allow me another 2 to 3 minutes, I can go through. Okay. Challenge is coming one by one, but you can invite your own challenge. That is the thing. Now, when we are actually accumulating our expertise, we are trying to improve the system better and better. So simultaneously, if our objective, our attempt is multiple goals, then how do we achieve this one? We'll apply our physics, our fundamentals, our technical know-how. We did the same thing. We applied everything, and we found one solution for one antenna. and an approximate shape of the antenna I'm giving here. That means I'm trying to control the conduction current by adding different types of perturbations. 14 variables. Question is, how do you optimize 14 variables? Because your objective is 4 different, very specific performances to be obtained, to be attained. So we found it is impossible, next to impossible. 4, 5, 6 variables, up to that you can do it. But as your number of variables, optimization parameters increase, you cannot do. So friends, you should be happy that it is your guess that the AI can do everything. AI is made by God, and AI is ready to solve all your problems. So AI can do everything. By that time, accidentally, one very robust group of Glasgow University, they contacted me and offered collaborative projects exactly in the same time. And that's why, okay, I told that, okay, so let's see whether your system can help us or not. And I tried to learn that what do they do. It is a kind of that OpenAI, I'm not talking about OpenAI, that is completely different aspect, different domain. But when you are applying the machine learning and artificial intelligence to solve your problem, this algorithm actually deals with the data you provide, the pure and purest data you'll have to provide. Question is, that is the challenge, that the AI cannot solve your problem until you provide it the basic information and data. So again, your research ability, your quality of data, your quality of research, everything will help you generate better world. So AI cannot solve all your problems. You'll have to solve your problem. AI can help you to make your life little bit easy. So when the solution came to us, it was really surprising. Our expectation was, or our experience was up to 20 to 30 dB. So the solution when came, it gave all parameters up to our expectation and mark or demand, and along with this cross-pole separation is 40 dB. And not only that, we have tested this one for other geometries too, and experimented the entire thing for both orthogonal and diagonal planes, because we are very curious to know whether AI is really robust or not. It's absolutely robust. So this power of Y, I was not very, very confident even then. Then I tested and I worked again and again used this one that you solve this problem, because I learned from industry that we need simple solution, as simple as possible. So better we can go for one simple design. Without the help of machine learning, it is impossible to find out the solution like that. So 3 dB, the entire bandwidth. It is not the 40 dB maximum to minimum. It is the entire bandwidth is over 21 dB solution. The similar solution is obtained for the other structure too. So anyway, I am just consuming your time. So ultimately, by combining some significant results, we tried to publish some of the results, and some are under process, to tell you in the future that the challenge is always there. So when there is challenge, as a researcher, you will have to accept it. And when we accept it, then really the opportunity comes to us to address and do good research. So I just tried to narrate a little bit in a piecemeal way, but it is not generated by me, it is by the entire group of students. Thank you.
Thank you very much, sir, for your inspiring research journey and insightful real-world examples and throughout-provoking keynote. So I feel this talk is mind-opening for all here manufacturing engineers as well, like me. And your perspective has provided us as an excellence foundation for understanding the challenges and opportunities associated with antenna technologies and AI in these particular areas. So we now forward to felicitate Professor Devatish Guha for this talk. And if you, in between, if you have any questions, audience, please ask if you have any questions in this.
So quickly you may ask any question or,
Yes.
or later, whenever you feel comfortable.
If you have any questions, you can ask, or else we can continue with this felicitation.
Any question, you feel free to ask. No, there is no question, so.
Okay. So upon, I'm calling our director, Professor Sukumar Mishra, to felicitate Professor Devatosh Guha, FNAE.
Okay, so I need to remove this one.
Thank you, sir, for your talk. And now we move forward to the expert speaker session, where we will hear our distinguished experts from various industries and research institutes. So to guide us, I'm technically in this session, so we honored Professor Guha to be on the stage again. Sorry for that. And we also call upon Professor Ravi Kumar Gangwar, who will associated with this section. And very warm welcome to you both, sir. Oh, you are leading.
Okay. If you gracefully can do this, I'll be very happy because I'll have to move right now because my wife is waiting. Yes. 5 minutes. I'll be there. So you start.
Yeah,
you
yeah.
start.
Okay, fine.
So I'll be there.
So no need to treat. Oh, no need. Okay.
Should I?
Just once more. So upon our first expert speaker, Dr. Pravakar Malik, scientist, ITR Chandipur, representing the R&D community. Yes, taking the lead.
Thank you so much. Good afternoon. Thanks to the organizing committee for giving the opportunity for a lecture on DRDO products. And moreover, it is test and evaluation of the DRDO products. Almost all we know, we are dealing with secret projects. We are restricted to say many things. Still we'll try. So after such a wonderful lecture, because sir is my ideal person whom I like to see when I did my PhD, I was interested to visit. Today I have seen him. So I am really, today we are going to talk about the test and evaluation. Yesterday during inaugural talk, Minister was talking about DRDO. And DRDO is in a path of doing R&D, basically in defense application and moreover for tri-services. Now time has come in a different way. This is not only for tri-services. Now DRDO is doing the research work for export. So the mandate has come, whatever product will be developed, so this should be export worthy. So earlier we were talking about for tri-services. Now it is one added requirement has come. It should satisfy the requirement of quality and reliability. And moreover, Operation Sindoor has proven the capability of Indian developed systems. If we look behind any system being developed, we test at integrated test range. And Operation Sindoor made us proof that it can be also tested wherever the practicality is designed for. Coming to the test and evaluation of DRDO development systems, I have just highlighted only 3 systems. One is missiles and strategic systems, aircraft and unmanned systems, artillery land systems, because these are the systems which are being tested in our test range. We'll see where are we. If you see all the test ranges in the world, these are the few notable test ranges in the world. And among them, ITR is one among. Integrated test range, it was established in 1982 under the leadership of Dr. APJ Abdul Kalam. He was our leader. He has shown us the path, how should go ahead with the test procedures. So that's why Operation Sindoor has shown that whatever we test, whatever activities we carry out in our test range, it is really praiseworthy. Because the certificate we have to provide, the development and the design is up to the mark. Now it is useful for the services. Seeing the global presence, integrated test range has come up. And these are customers. Earlier the customers were limited. Now these are customers who come with their product for test and evaluation. After test and evaluation, we certify, yes, now it is useful. The test and evaluation process, if you see, the private partners are also coming up now. As per the new government rule, the test and evaluation facilities usually open for any private, public or government, any sector who can want to utilize it. So the test range comes into picture in a design cycle of any product. Any product when you go for a development, so we must follow certain design cycle. We start with mission requirements. With certain mission requirements, then we establish a baseline, carry out the aerodynamic study, then propulsion, weight and structure, and we decide the trajectory. Once we carry out all these activities, we also carry out the static test at lab level or ground test also. But after that, the test range comes into picture. Once the trajectory is finalized, then it has come for range activities. And the first range activities is the range safety studies, because we are dealing with missiles. So when we test the missiles in our test range, first we carry out the study whether it is safe or not. Because instead of moving towards sea, it should not turn back to the land. So that's why the foremost important part is to carry out range safety studies. Then we find the launch feasibility analysis. Suppose Agni is designed for 5,000 kilometer. Are we well equipped to get the data up to 5,000 kilometer? The missile is designed for sea skimming application, only 5 meter from the sea surface, and it will move on close to the sea surface. Are we well equipped to provide the test data? So this kind of analysis we carry out. Then we go for the mission simulation. In a simulation platform we carry out, if the trajectory follows certain path, if the missile follows certain trajectory, how our equipment should behave, and where we should place the equipment, our instrumentation, so that all the data can be captured. Then we carry out the sensor deployment, finally test, and we carry out the post-flight analysis. And if the analysis data, we provide them to the designer who comes for test and evaluation. And with this test data, they verify, have they satisfied the requirements or they need any design modifications. So like this, it goes on number of iterations. So to test these activities, we should have some range instrumentations. Basically for trajectory measurement, we need radar, we need EOS stations, electro-optical stations. And those stations also, it can be deployed on the ground, it can be deployed on the ship, it can be deployed on air. That is airborne range instrumentations. To study that, if you see the electro-optical characteristics, what it does. The optics, it can be IR or it can be CCD. So with the gimbal performance, if you have a look on this number 2, you see measurement from 2 EOS stations. What do we do? From EOS stations, we find the angular measurement, azimuth and elevation. And from that, we try to find out what should be our trajectory point. So that is a concept of triangulation. Triangulation is nothing but it is a minimization process. So if you see the mathematical principle behind it, the distance to be minimized, the difference to be minimized. After minimization and using the triangulation method, we find out its XYZ. Minimum 2 EOS stations are required to find the trajectory point. Similarly, we have the radar. This radar, already we know from radar information, from radar we capture R, theta, and alpha. That is range, elevation, and azimuth. From range, elevation, and azimuth, we should convert into Cartesian coordinate, polar coordinate to Cartesian coordinate. for a 3D positioning, and we find out the x, y, z. So this is very common. These are for trajectory information. So trajectory information is not sufficient. We should also try to get the status or health parameter of the missile. How missile is behaving, how much is the vibration. So all detail can be captured through telemetry. And this is the total range operational scenario. All telemetry stations, electro-optics, and tracking radar, they are connected in a network, and all data come to our mission control center through data processing. And all the decision makers, including mission director, range director, and everybody will be available at the mission control center, which can give command and control to monitor all the activities. And if it deviates, also we should able to destroy it in air itself. Because our purpose is to test the missile, and it should be in a safe corridor always. When it moves for 5,000 kilometers, it does not cover only India, it goes up to Australia. So for any such unwanted incident, if it deviates, then we should able to destroy. So for that we issue a ground command, and that is called as range safety, issue a flight termination system. Through flight termination system, we can give a command, and from that distance you just imagine it should able to destroy the target. So this type of scenario has been simulated. Coming to our futuristic mission scenario, since we are here to know the challenges, what should be our future activities, that we should discuss most. Now the time has come. We have seen yesterday lecture that swarm concept, there is simultaneous attack, simultaneous target. So question comes, what is our futuristic mission scenario? These are certain futuristic mission scenario which I have just highlighted here. Simultaneous launches from multiple launch complex. Sea skimming, that means close to sea, the target will move. Because as a part of test and evaluation, as a test range, we must capable to provide them the data. Whatever will be the missile performance, what will be its trajectory, we should be capable enough to get the data and provide the designer for its development and provide to the services for their confidence so that they can use it in the real time. So these are the many various challenges with us. Challenges of data handling, challenges of sensor allocation, where I should allocate my sensor, where I should place my sensor so that whole the trajectory data can be captured. I'm having the limitation on line of sight, because when we go to EOT, that electro-optical sensors, they operate with LOS, line of sight, and also there is a sensor coverage. It cannot cover infinitely. And we also, we do have a challenge of RF attenuation and also low observability. So what are the solutions we have coined down? Now time has come for intelligent smart sensor allocation. We should have a database, and if I know this is my requirement, this is my trajectory information, so my database should drive us, my database should tell us where I should place my sensor. So that is called intelligent sensor allocation. We should have multi-target tracking instrument, that is a phased array concept we are using. We should have multi-sensor data fusion. We should have the resource sharing, because simultaneously 5 to 6 objects in air, and I am having limited sensors. How can I track? How can I get the information? I should not miss any information. So these are the many challenges. I just want to highlight this kind of challenge. We might have seen, we might have heard MIRV, Agni 5 MIRV. Multiple independently targeted re-entry vehicle. That means one missile will go, it will reach to the destination. At a certain height, at a certain altitude, it will burst, and maybe 5 to 10 independent target killing or independent missile will come out of that. So that I think government has named that Brahmastra. So this kind of application is there. So in that scenario also, there is a challenge to us. All the targets, whatever has come out, should be captured properly. Then only we can evaluate. So this is one of the challenges. And coming to another challenge, that is the directed energy weapons. Directed energy weapons, now what happened? The energy can be laser based, the energy can be high power microwave, the energy can be electromagnetic wave. So all these waves will come and destroy directly. So that is another challenge, how to track all the informations and multi-object in the AR. Since our theme is about RCS, I thought to touch up, because this is another challenge to us. Nowadays, most of the objects are stealthy objects, reduced to RCS. And in reduced to RCS, how we should capable, whether we are capable enough to get the data. So these are the various methods. Yesterday also we have discussed about shaping. If you change the shape, instead of reflected, it will scatter here and there. Because RCS is a factor. Suppose I have a target and my enemy want to track me. So what he will do, he will send a signal to my object. And after getting reflected, the reflected back signal and incident signal, from that you will calculate RCS. But instead of reflecting back, if I will just design such a way, it will get diverted here and there with a shape, different shape. So what will happen? The RCS will be reduced. It will not able to track. Similarly, radar observing material. Radar observing material is a such kind of material, when any incident wave comes and it falls upon it, instead of reflected, it will absorb it. It will just change its path so that it will not reflected back. It will not scattered back. So this is another method by which RCS can be reduced. And another is active cancellation. What is the active cancellation? Whatever the incident wave is coming, what is its amplitude, what is its phase, I should generate another signal which will reflected back, which of totally opposite phase. So it will be fully cancelled. So this is another method through which the RCS can be reduced. But for a test range, what do we do? To track it for a longer range, we put a device inside the aircraft or missile that it should able to track for a distance of 5,000 kilometers. We call it transponder. Transponder is a kind of transceiver which transmit as well as receive it. Then ITR has moved ahead. We have developed very good defense ecosystem. With many industry, we have collaboration. We have done many development work. So among them, one is a drone-based telemetry. This is a drone-based telemetry, just kind of airborne system. On the drone, there will be a receiver. And when any object with a low altitude, as it cannot be tracked by any radar, because it is coming with low elevation, negative elevation. Negative elevation, it cannot work. So what will happen? When we go with low elevated target tracking, we go for airborne range instrumentation. This is one of the development we have. Drone telemetry. In a drone, we put the receiver. So whatever is being transmitted from missile, that will get received by the drone and it sent back to the ground stations. Through this, we can capture the data. And these are certain critical futuristic technology. I'll just read it out. This is giving challenge to all the young researchers who can work on this and who can put your paper. Because DRDO has now opened up today, our director, DRDL director was announcing, DRDO is investing around 1,000 crore for a project work with academia as well as industry. So let us work together. These are the different challenges. If we have any solution, please come up. There is method through our ER and IPR. There is also with academia, we can go ahead with CARS project. Many ways are there. TDF project, Technology Development Fund project. We can give 100 crore for TDF project. So there are many opportunities. Now let us collaboratively work for the development of our country. And ITR, initially it was interim test range. Later on, with Agni test flight, it becomes integrated test range. So another abbreviation can be international test range. So it is moving towards international test range. Our test facilities is now being used, is being planned to be used by the other countries, our friendly countries. So ITR is moving towards international test range. Thank you.
Thank you for your talk, Dr. Malik, for your excellent and insightful presentation. And now, if students, you have any doubts, you can ask, or any questions. Thank you. I request Professor Gangwa to felicitate Dr. Prabhakar Malik. Thank you. We now go with our industry perspective. Our next speaker will be Mr. S.V. Madhusudan Reddy from Rods and Swords, India. Welcome him. Welcome. He is well known for its work and testing and measurement communication systems and RF technologies, making his perspective and particularly relevant to this today's theme. So I please Mr. Madhusudan Reddy to deliver his talk.
Yeah, good afternoon all. My name is Madhu. I'm working as an application engineer for Road and Shores. I hope today I'm the younger speaker here who has spoken all this day. So today I want to talk about, everybody discussed about research and everyone discussing about fabrication of this thing. So today I'm talking about the measurement part of it. So how to do the measurements. So which are, as a topic is corresponds to RF structures and RCS related these things. So I will be talking something about how the RCS measurements will be performed. So what is a radar? So radar is used for measuring the range, the distance from where the target is coming, whether it's a moving or it's a static one, right? So in today's challenge, what is this is? The increasing complexity in today's, increasing complexity in the electromagnetic spectrum. In this condition, understanding the behavior of the targets, how it is scattering and receiving at the radar systems is very important, and it's becoming more and more important in nowadays. So RCS is one of the fundamental metrics which will help us in determining the target's radar visibility. That means accurate RCS measurements will help you in determining the platform survivability, its detection performance, and also the mechanics, how it is working. So in this presentation, I would be talking about what is RCS, what is its importance, then what are the measurement setup that is required to do the RCS measurements, and finally, to improve the speed. So what are the mechanism, what is the architecture that we implemented into the instrument so that the measurements can be performed parallelly and we can increase the measuring speed. That would be discussing in the coming slides, right? So as everybody discussed, what is RCS? Basically the effective area that describes the amount of electromagnetic energy that a target reflects back to a radar receiver. So if the reflected power is higher, that means the detection range is higher. That means you can detect an object far away distance, like kilometers away. But if the reflected power is less, that means the detection capability is lesser. That means you can able to detect when it is closer to you. If it is an enemy radar, or suppose if it is an enemy fighter coming towards you, and you are detecting very closer to you, that means you don't have sufficient time to react and counter them, right? So in these conditions, you can able to see there are different objects, what is its RCS. So basically RCS measures in terms of dBSM or a meter square. So you can see over here, for a commercial aircraft, the dBSM, what it is having is 16 dBSM. Whereas a normal fighter jet has a dBSM of around 3 to 7 dBSM. And when you compare to see an insect which is of the range of 10 micrometer square, having a dBSM of minus 50 dBSM. And we are talking about stealth fighter, it is having a dBSM of minus 60 dBSM. That means the RCS of a stealth fighter is even lesser than an insect RCS. So how it could be possible? In terms of insect, it is very lesser, but when a fighter, it is very big when it corresponds to the physical dimensions when you see it. So RCS not only depends upon the physical size, it also depends on the shape, how it is, and also the material, what it is using on the top of the metal plates, what it is using. So this defines the RCS of a particular object. Next, if you want to see it, it not only depends upon these dimensions or this thing, it also depends upon from which frequency you are capturing it, or from which angle you are looking at. Suppose you are looking from the top angle, it looks like an ant, but if you are looking on the side angle, then it looks like a huge base, body, something kind of thing. And also it depends upon the polarization by which you are transmitting and you are receiving it. Suppose you are transmitting in a vertical polarization, and if the signal is coming from a horizontal polarization, then the levels will change. If it is coming in the same polarization, levels will be higher. If it is coming in a different polarization, then the levels will be lesser. So that for doing an RCS measurement, polarization is also very important, whether you're capturing it vertical or in horizontal or in a cross polarization, apart from frequencies and the type of the angle what you are looking at. So to do these measurements, so what is required? You can do it in open air. Only thing is, the waves what you are transmitting should be a planar wave. So why planar wave? How we can achieve planar waves? Basically, if you are in a far field region. That means, if the distance between the source and the target is 2d square by lambda, where lambda is your frequency and d is the diameter of your antenna. If your antenna diameter is huge, then the distance between the source and will be huge. This forms your far field region. Then, but the disadvantage of using an open air facility is you will have reflections from the corresponding buildings, and you have some background noise. To measure a minus 60 dBSM of RCS, the background noise should be very lesser, which cannot be possible in open range. And one more thing, the environmental conditions. If it is hot, then you get a good signal strength. If it is weathery conditions, or if it is raining, then you may not be able to see a good signal strength. So other side, if you can do indoor. So indoor means you are using an anechoic chamber, where you can able to reduce the reflections coming from outside. That is one thing. So you have clutter-free environment when you're doing inside, but the problem is you have to get a far field also. So if it is not in far field, then it would be in near field. So if you are using an indoor one, maybe you have to do a near field measurements, then you have to use some algorithms to compute it to far field, right? And one more thing, it is environmental free. That means you can do it in any weather conditions because you are doing in a controlled environment. And you can do 24 hours by 7 every time. But the problem is how to simulate a far field in a indoor these things. So to avoid this thing, they introduced something called compact antenna range facility. That means instead of transmitting the signals directly onto the target, you will be transmitting first to a reflector. From the reflector, it goes back to the target. So in this condition, you can able to simulate a far field region. So for doing RCS measurements, one thing is important is compact range facility. Then you need a positioner to place on the target, whether it can be aircraft or it can be these things. You have to need a positioner and it has to move 360 degrees. That is one thing. Next thing is we need some source and we need some receiver to capture whatever we are transmitting and the reflected signals. So for which we use network analyzer, vector network analyzer. So what is this vector network analyzer does? So let's see the architecture of a VNA, how it works basically. So when you talk about vector network analyzer, basically if you take an example of a 2-port network analyzer, basically it contains one source and it contains 2 receivers at each port. So basically it is using to help you sort out S parameters. Based on our S parameters, we will be capturing the RCS measurements. So here, how it works? So basically, a 2-port VNA contains one source, 2 receivers at each port, and to separate these 2 receivers, there will be a directional coupler which will be separating the signal from received and the incident wave. So example, when it is connected to the port 1, you can see the generator is connected to port 1 here. When you transmit a signal, it passes through the directional coupler and one signal comes to the reference receiver. That means whatever the signal we are transmitting it, we need some reference for it, right? To do the measurements, which we call as incident wave, and here we measure it at reference receiver. The same signal passes through the DUT and it is coming at the other end. So basically we are doing a transmission measurement, which is measured at port 2 of the VNA. So which measurement it is? Basically we are measuring S21 by using this form. Then if the signal is reflecting from the same port, then we are measuring the reflection properties of that particular device, which is S11, B1 by A1. So now the signal generator turns to the port 2 and it passes through the device, and the same signal will be measured at A2 receiver, which is again a reference receiver. And if the device passes through the signal passes through the device, then you get S12 measurement, which is B1 by A2. And next, if it is reflecting from the same port 2, then we are measuring the reflection properties, which is S22. So by using this VNA, we will be doing the RCS measurements. But there is some challenge in it. So we have discussed about RCS measurements that we have to do in different polarizations and at different frequencies, right? So if you are using this VNA, so you can able to do only one frequency at a time, because it has only one source and you can able to simulate only one polarization at a time. But if you want to do vertical, you want to do horizontal, and you want to do the cross polarization, and you have to do it at different frequencies. It's a time-taking process because you have to do one frequency of the other and you have to do one polarization of the other. To remove these difficulties, we have implemented a new architecture which is called ZNA. This is the model which we have launched recently, where it has 4 sources in it. Instead of one source, it has 4 sources for a 4-port device, and it has 8 hardware receivers, and they are phase coherent. That means whatever the data you capture, they are phase coherent. And next thing, 8 hardware receivers I am saying, but there are 16 digital receivers inside. After the down conversion, each and every receiver, there are 2 paths which are used for measuring different frequencies at the same time. And it also has pulse modulators in it. For each and every source, there is a pulse modulator. That means if you want to evaluate in pulsed condition, where radar works in pulsed condition, so you can use the internal modulators and you can able to simulate the pulsed condition, and you can see the RCS measurements in pulsed condition also. And next thing is, and if you can see it, each and every receiver will have some local oscillator to down convert. So in earlier architecture, the local oscillator was one. All the four were sharing the same local oscillator. So with this, what happens? You can able to do only one frequency at a time. Now in this, we have implemented dual LO concept. That means some of the receivers will use one LO, other receivers will use other LO. So that means speed can be increased by reducing the time. So here is a classic example of this. So this is for a radar measurement, RCS measurements, where one source is, two sources are using for vertical polarization with two different frequencies, F1 and F2. Other two sources are generating horizontal polarization with F1 and F2 with some delta. So why this delta frequency here? To avoid the interference between vertical and horizontal polarization. And they have been captured using a directional coupler to use it as a reference, which is given to the A1, A2, A3, A4 receivers. And it is given to the antenna. On the receiver side, again, we are using some splitters to split the signal and give it to the other four receivers of the VNA, which is B1, B2, B3, and B4. So in this condition, you are doing full matrix of the polarization. That means you are capturing horizontal, you are capturing vertical, and you are doing cross polarization. That means you are capturing HH, VV, HV, and VH. So you are doing full compliance matrix for a polarization for the RCS measurements using this. And your time is also saving because you are doing multiple frequencies at the same time. So not only this, as an R&S, we are from R&S India, we are also giving some solutions which are related to the TR modules which are using the radars. So basically, if you want to test the TR modules, basically it's a time-taking process if you are doing it manually. And it can take weeks or even months to do one particular TR module test. To overcome this, basically, we are giving automated test solutions where you can do the complete testing of one TR module in 20 minutes or 30 minutes. So here is a small video that what we do in India.
Are you facing challenges in ramping up production? Do you need to reduce development time and costs while still ensuring top performance? Now imagine a state-of-the-art automated testing system that helps you streamline your development, validation, and production. For over a decade, Rode and Schwartz India Systems has partnered with aerospace, defense, and satellite innovators, delivering precision, reliability, and mission-ready solutions. Rode and Schwartz drives next-gen aerospace, defense, and satellite systems, delivering secure connectivity, advanced radar, and electronic warfare superiority from aviation to satellites. Our custom-built, fully automated solution for TRM testing ensures flawless radar and electronic warfare performance, delivering accuracy, repeatability, and speed from design validation to production. At Rode and Schwartz India Systems, we believe technology should serve people and empower missions that matter. In the fast-evolving automotive world, safety, efficiency, and innovation must travel together. The shift to electric mobility demands faster charging, flexible designs, and higher efficiency, driven by wide bandgap semiconductors, higher battery voltages, and wireless connectivity, all enabled by new approaches to testing and validation. Our wireless BMS chipset automated test platform addresses the end-of-line requirements of leading semicon and helps automotive manufacturers guarantee battery intelligence, communication integrity, and long-term reliability from the factory floor to the open road. What connects these worlds is our customer-first approach. Every solution is tailored, every challenge is an opportunity, and every partnership is built on trust. Rode and Schwartz India Systems delivers customized RF solutions with precision and innovation. Our young dynamic team with experienced professionals leverages cutting-edge RF test equipment to design solutions that push boundaries, exceed expectations, and drive meaningful innovation to serve aerospace and defense, semicon, research universities, wireless markets, and automotive. Rode and Schwartz India Systems not only addressing Make in India, but is well poised to support with customized solutions globally. For nearly a decade, Rode and Schwartz has consistently delivered cutting-edge automated test systems that redefine reliability and performance. With a proven track record of success, we're committed to sharing our expertise at a global scale, empowering international customers to achieve their testing goals with confidence. Rode and Schwartz India Systems, where precision meets purpose and innovation drives progress.
Yeah. This is from my side. Thank you for listening patiently.
Thank you, Mr. Reddy, for sharing your valuable expertise and industry perspective in this area. So I ask audience, if you have any questions, you can ask. Yeah, I request Professor Gangwar to felicitate Mr. Reddy. Thank you, Mr. Reddy, for your valuable talk. We now proceed to our next expert presentation. Speaker is Dr. Preeti Kumari, scientist, NPL Delhi. Welcome, ma'am. And our expertise in research and technology development will certainly added to our today's discussion. I request Dr. Preeti Kumari to deliver her talk.
A very good afternoon to all the respected dignitaries, professor and students. Myself, Preeti Kumari from CSIR National Physical Laboratory, New Delhi. I am very thankful for the organizing committee for giving me this opportunity for this presentation. So my topic is microwave dielectric ceramics, from material development to microwave device integration. Basically, I will discuss what are all the parameters of the microwave dielectric materials are required and are very essential, so that for the final module what we develop, for the final system what we develop, it gives performance in the real scenario, real environment. So these are the outlines. We'll discuss initially the introduction to microwave, then what are the parameters of ceramic dielectric materials which affects the performance of microwave devices. Then we see the properties and applications of microwave dielectric materials. Then we also have some little bit introduction of high temperature ceramic radome materials and ultra high temperature ceramics. So microwave lies in the frequency range of 0.3 gigahertz to 300 gigahertz. Basically, it has photon energy of around 1.24 milli electron volt to 1.24 micro electron volt. So at maximum frequency, that is 300 gigahertz, it is generating photon energy of 1.24 milli electron volt, which is very less as compared to the electron volt or several electron volt which is required to break the chemical bonds or ionize the atoms. So microwave is also called as non-ionizing electromagnetic radiation. So there are different dielectric materials, magnetic materials, LTCC means low temperature co-fired ceramic materials, EMI shielding materials, radome materials. All these have different application in different scenario. So first we will discuss what are all the different microwave parameters, material parameters which are important for using that material in the microwave applications. So we'll go through with what is relative permittivity. Relative permittivity, it is the ratio of the amount of electrical energy stored in a material by an applied voltage relative to that stored in a vacuum. So dielectric constant or permittivity, it is a complex quantity. It has both real and imaginary part. So imaginary part corresponds to dielectric loss and real part gives the dielectric constant. So polarization mechanisms are there in different frequency ranges of the dielectric materials. So at lower frequency, we see the space charge polarization, orientation polarization in the material itself. So when the field is applied, electric field is applied, so there are permanent dipoles which are randomly oriented. After applying the electric field, it gets oriented in certain direction and polarization is developed. So these are the different polarization mechanisms which contribute to the dielectric constant of the material, ultimately to the dielectric constant of the material. So if we measure the dielectric constant of any dielectric material from low frequency to up to terahertz range or more than the gigahertz range, so there are some polarization like a space charge polarization. All these happens at the lower frequency up to megahertz range, but with the onset of microwave, means from gigahertz and afterwards, there is atomic and electronic polarization exist. So dielectric constant, when we measure the dielectric constant of a material at low frequency, you will get higher value. Suppose if it is around 15 or 14 for one particular material, then in gigahertz range, you may get the dielectric constant of around 10. So it will get reduced because at higher frequency, this polarization effect, the orientational polarization and the space charge polarization does not occur. Only the ionic and electronic polarization happens in the microwave range. There are other parameters which also influence the dielectric constant, like crystal structure of the material and temperature. With the onset of temperature also, dielectric constant vary. If you increase the temperature, dielectric constant may change. And electric field. Electric field, it has a direct relation, D equals to epsilon 1 plus chi E, where D is the dielectric displacement. So this is another parameter, loss tangent or tan delta, which we also called as a dielectric loss. So dissipation factor or loss tangent is just a ratio of the energy dissipated to the energy stored in the dielectric material. So if you take the ratio of epsilon double dash, means the imaginary part of the dielectric, imaginary part of the permittivity to the real part of the permittivity, it will give you the tan delta value. So if you see for different materials, like for air, it is around 10 to the power minus 6 loss tangent, and for microwave dielectric ceramics, it is around 10 to the power minus 4 to 10 to the power minus 5. For FR4, which is a very common substrate material, it is around 0.015 to 0.025 and so on. This is the another factor called quality factor. It is also for the dielectric material, it is just the inverse of tan delta. It is defined as the ratio of the energy stored to the energy dissipated per cycle. So a high quality factor indicates efficient energy storage, low dielectric loss, narrow bandwidth and excellent frequency stability, making it a critical performance for microwave resonators and filters. This is also one of the very important parameter, temperature coefficient of resonant frequency. So when for one dielectric material, suppose you are using it for certain application, it is giving good performance at the room temperature or up to 50 degrees Celsius. But in the real environment, if you increase the temperature, suppose 80 degrees Celsius, its resonant frequency may differ. So if it is for antenna application, its performance will differ. When you increase the temperature or the environmental condition, if changes, its response will change. So we also need to check whether the material is stable or not, resonant frequency of the material is, temperature is stable or not. So we need 0 TF, which is very ideal for the material. We try to tune our material so that we get the 0 TF, means temperature coefficient of resonant frequency for that particular material which we are going to use in different applications. Properties and applications of microwave dielectric ceramics. So these are some common dielectric ceramics like corderite. Corderite is basically magnesium aluminosilicate based ceramics, and forsterite, alumina, as alumina, beryllium oxide, aluminium nitride and glass. These are very common dielectric ceramics available in the market. So their epsilon R is reported 10 delta, and alpha is the linear thermal expansion. What is linear thermal expansion? When we increase the temperature, the dimension of the material will also, it will expand to up to certain extent. So that also give how much temperature affects the dimension of your device. And lambda, this is watts per meter per Kelvin. This is the thermal conductivity, which is also very important for the application of material as a substrate. Thermal conductivity should be good, because if at certain location, if it get heat up, it will certainly pass on the temperature quickly if it is very good thermally conductive. Alumina is a ceramic material which is also available commercially as a substrate. It has a thermal conductivity of around 35 watts per meter per Kelvin. This is the variation of quality factor and temperature coefficient of resonant frequency as a function of relative permittivity. So this has been taken from this reference which I have quoted at the bottom. So for wide range of microwave dielectric materials, they have prepared this variation of quality factor chart along with the relative permittivity, and we can see that high quality factor is obtained at the lower permittivity site up to 20 dielectric constant or 20 relative permittivity. On increasing the, when you go to higher relative permittivity like more than 50, the quality factor is decreases. So for substrate application, if you are using it, or for DRA, so for substrate application you need high quality factor because loss will be less at that point. And TCF, for this TCF, that is temperature coefficient of resonant frequency, it should be near 0, means it is on increasing the temperature or on decreasing the temperature, the resonant frequency is not getting much deviated. So if your application, if your device which you are making is having different environmental conditions, sometimes temperature will increase or decrease, it will not affect the performance if the material used in that device is stable TCF, means around 0. These are the commercially available substrate material for microwave applications which you people generally antenna designers use, like Rosers, RT Durite, and their relative dielectric constant, loss tangent, and the type of material they are using for its fabrication. These are the commercial LTCC materials, alumina and FR4 comparison chart. Here we can see that commercial LTCC means low temperature co-fired ceramic materials has very low loss tangent. This is reported at 1 megahertz. And one more thing is like when 5 minutes. Okay. These are certain microwave dielectric ceramic materials which are laboratory prepared, and generally if we prepare any material and when we choose it for the application in microwave devices, then we we do the microwave dielectric measurement at the frequency, desired frequency. Means suppose if you are designing an antenna at 10 gigahertz, we try to choose the material whose all the specification are reported at 10 gigahertz, like that, or prepare your material and then do its microwave dielectric measurement around 10 gigahertz, and then you can cite that material property in your simulation for the further antenna design or whatever microwave device you are going to. These are different glass system which has also good microwave dielectric properties. So I'm coming to. So for the preparation of any microwave material, generally we think of material composition first, then the how to synthesize it, go to the solid state synthesis route, which is very simple and even can be understood by other domain people also. The physics and chemistry people can also synthesize with other sol-gel method and other synthesis route, but solid state synthesis can be prepared by even other domain students also. Then we go for the different characterization. We should go for all the material characterization like XRD, SEM, XPS. SEM means microstructure characterization, then surface analysis, bulk density, temperature coefficient of resonant frequency, and microwave dielectric properties, all, etc. Then we select the material and we go for microwave device development using any simulation software, or it is like. So if you choose the right material and if it is suitable for your design, then it will definitely give the right microwave performance. So I can show you when the when you when you develop your material, then you integrate it in the device, and as you go to the system, the complexity of course will increase, but when you integrate all these things, its value will also increase. So we have to think all these before going into the device directly. Do think of what material you are taking, selecting for the designing of your devices, and also do think of the cost and availability and efficiency. These are the different substrate material. For power electronic substrate, we also take care of dielectric strength. These are these are antenna substrate, ceramic substrate, which is used for simple cylindrical dielectric resonator antenna designed, and this material is lithium magnesium aluminophosphate material, which is prepared as a substrate material, and all its material characterization and dielectric characterization is done, and then it is implemented for the design of dielectric resonator antenna. This is part of my work. Now, high temperature ceramic radomes. So, water radomes, an electromagnetically transparent, structurally robust and environmentally resistant enclosure of radar antenna. So, we also used ceramic materials because they are very robust for the radome material. So, there are different high temperature ceramic radomes available, alumina like pyroceram. Pyroceram is a Corning glass. It is also magnesium aluminosilicate glass ceramics. Glass ceramics are basically glass. At one go, first we prepared the glass, and then when you reheat it, it will become ceramic. It will get hardened into ceramic. Like other different glasses, it will not again melting, it will not convert it, remain in the glass form. It will convert it into ceramics. So this is a glass ceramics. Slip cast, fused silica, dense silicon nitride, reaction bonded silicon nitride. All these have very good rain erosion resistance, thermal stability, beta Cylon and silicon oxynitride. So all these materials have good properties for because it is suitable for the radome materials. So this is the properties which is required for radome materials for supersonic applications. Like it should have 500 degrees Celsius at, it can bear 500 degrees Celsius at Mach 3 up to 1400 degrees Celsius service temperature. Dielectric constant should be less than 5, and temperature variation of dielectric constant should be less than 7%. Loss tangent 0.1, bending strength more than 60 megapascal. So all these material comply with these range. But certainly there is some property for one material is good, for other somewhere it is a trade-off. So you have to select for that particular application which material is right for the utilization. There are another category called ultra-high temperature ceramics. So they are a class of refractory transition metal ceramics, primarily include carbides, nitrides and diborides. So it has the unique combination of ultra high melting point. The melting point of these ceramics are more than 3000 degrees Celsius. So this is one of the Nature Review article on ultra high temperature ceramics, although they have not given of promising application, but because of ultra high melting temperature, if microwave dielectric properties are also available for all these materials, then we can select certainly for defense application also these type of materials. So the future lies in engineered ceramic composites that optimize electromagnetic transparency, structural integrity, and thermal performance for extreme operating environment. So there is no single material satisfies all microwave device requirement. So you have to tune or select the material as per your device requirement. So thank you.
Thank you very much, ma'am, for your informative and enriched presentation to all of our students and faculty members. Now I ask audience if you have any questions to interact with. Yeah.
I have two questions. First one is that rudimentary one. And the imaginary part of the permittivity, what is the significance of it? This is my first question. And second question is that permittivity, electrical conductivity, and thermal conductivity, from the structure itself, from the microscope, can we predict?
So imaginary part of the permittivity signifies the dielectric loss. So 10 delta is basically dependent on that imaginary part of the permittivity, epsilon double dash by epsilon dash.
So loss is a very, very pragmatic thing. Why it is loss is imaginary?
Sir?
Why loss is categorized as imaginary? Loss means a definite real thing, isn't it? So how loss is imaginary? I want to understand that.
So basically, dielectric loss is what defined as the amount of energy dissipated to the, means it is the ratio of the amount of energy dissipated to the amount of energy stored in the system. Like capacitance, when we measure, suppose there is a one parallel plate capacitor. So once we measure the capacitor epsilon naught A by D, there is some material suppose, and second time we do the measurement without any material. So with that we can also calculate the dielectric constant, means epsilon. It is just the relation of the capacitance with the dielectric of the material itself. So with the field is generating and how the field is affecting the dielectric material. So how much it is confined within the material and how much energy it is dissipating to the environment. Like
how much confined is a real thing, isn't it? How
yes,
much
sir.
Confined, how it can be imaginary? I want to understand.
Yes, sir. So imaginary in terms of when we measure the dielectric constant in the system, like VNA and all material system, while doing the dielectric constant measurement, it will give both the parameters, epsilon dash and epsilon double dash, complex permittivity. Complete value it gives, sir. Yes, sir.
Can I ask one question?
Yeah. Yes, please.
Raman Singh from Monash University, Australia. When you have so many factors and that are generally electrical type of factors, I'm broadly saying, can you take those into account and develop what is called electrical equivalent circuit? And once you have that, you could put in all your parameters and you can predict instead of the need of doing all those experiments. So you predict and you do experiments only to validate it. Is my question clear? It is done very, very commonly in electrochemistry domain. You have electrical equivalent circuit, and in that you have components related to the parameters that you talked about. Do you do anything like that in this domain? Is my question clear?
Yes, sir, your question is clear, sir. So, for getting the electrical equivalent circuit, generally, suppose if it is, we design, using that material, we design the antenna. and we are using suppose substrate material, we have some components in. For that we do have the electrical equivalent circuit because it is a circuit part. But for the material specific property, we go to the material property by doing the by preparing the
Sorry for interrupting you.
Yes.
When you say material specific property,
Yes.
there are material specific electrical property. So you can put that into the circuit. What stops you from doing that?
Yes, in circuit, okay.
Yes, in the circuit itself, I can put those components, and then I don't have to do experiments. I need a property which I can predict using my circuit, and then I do experiments just to test it. So it will reduce your number of experiments. About the question that you had earlier, do you use AC current, AC type of electrical, yeah, or you don't? You DC or AC? AC, so the negative part takes care of the imaginary thing. Okay.
Sir, sorry for the interruption. So it's time to close this, the talk. Thank you, ma'am. Thank you very much for your valuable talk. And once again, and now I request Professor Gangwa to felicitate Dr. Preeti Kumari for his talk. Thank you, ma'am. And next, as a part of startup talk, now I call Mr. Chintan Mishra to present the talk and waiting for you. Mr. Chintan Mishra is the founder and CEO of Rebu Computing. He's delivering his talk related to startup speakers. Yeah.
Hi everyone. So the talk is revolving around a lot of things related to startups, what we are doing, and how to think about products and systems. So what we are starting with is, we can solve the link, but we can't solve the signature. Because as soon as you have a link, there will be associated amount of radiation that you're doing, and that radiation needs to be controlled because you are leaving signatures. So what we are doing is we can solve the link, but we can't solve the signature, and that is where the RF attenuators or RF absorbers come into play. So we initially started as a software company, focused on defense robotics, but we went on to become an accidental hardware manufacturer. And as it has been evident in the previous talks, that no matter what you do, if you are into hardware, you have to be excellent at understanding the manufacturing processes, the materials, because antenna is not a silo. You can be very good in simulation, but if you have to make it practically, then you have to understand how to manufacture the particular system, particular antenna. So I have 3 key agendas. So Arthur C. Clarke is a very good sci-fi author, and he said that any sufficiently advanced technology is indistinguishable from magic. And how we implement that magic is the part that we'll talk about. So you can build anything that you can think of. So if you have any concept or any product or a solution in your mind, you can build that. But what you have to do is figure out who needs it. Is it actually applicable? Do people require it? And can you make it simple enough so that people start depending on it? And finally, magic is only a trick. You have to understand how you can make it as simple as possible for the people who are going to use it. Moving on, so how did we become a software, how did we become a hardware company from a software company? So in 2015, there is a society called American Society of Mechanical Engineers, and through that, we participated in an event called Student Project Development Conference. And in that, there was a challenge. Like Haiti had experienced a very large earthquake, and we were given a challenge, and there were teams from Hong Kong and other countries around the globe. And in that competition, we participated and we made a all-terrain vehicle right in the workshop that you have in the mechanical engineering workshop that you have. So what we realized that in 12 weeks, we can spin up and use that workshop to create any all-terrain vehicle. But what we were lacking is understanding of how the environment operates. We had a lot of challenges related to how to prevent the contamination of the payload that we are carrying, because the ATV was supposed to carry a lot of medicines, food, and other equipments. So that is what prompted like how we can make vehicles autonomous, and that laid the roots of autonomous navigation, and that helped us build the next three things: the visual navigation toolkit, or VNTK that we call in short, the automatic target recognition that has been renamed multiple times, and Chakravyuh, which is a swarm control system, and Autonomy SI, which is again edge compute AI board. And what we realized is that if you're operating in contested environment and you have a lot of electronic warfare scenarios and you are being jammed, a few seconds of video failure leads to catastrophic decision making. So what happens is you are about to strike a target and you're not sure whether it's a military target or a civilian target. And there is no way the operator can decide because your link has dropped. And that is where the wall comes in. And finally, in 2023, we started building what we couldn't buy because of the blanket ban. It's not exactly a ban, but it's a soft restriction that has been put that we cannot supply to armed forces. We cannot supply products that are sourced from bordering nations, land border sharing nations. And that is where we became a hardware company. So visual navigation toolkit is where we spent a lot of our time. And so if someone has a hardware or vehicle platform, so which is the first layer of the vehicle system, so we build on top of it, we help make the vehicle drive-by-wire, and on top of it, it's autonomous control system or navigation control systems. Then we have perception and communication so that you can understand the environment and move forward, make the vehicle move forward. So you have to plan and control the vehicle as well. That is where the navigation planning and control comes in. And now, on top of it sits the autonomous navigation. So till now, whatever we have done is ensuring that the vehicle can navigate. Proprioception is what we have done. But if we talk about autonomy, we reach that after we have all the basic systems up and running. And finally, we spin up missions and application using that autonomous navigation or decision making. So we have one compute platform. It is built on top of Texas Instrument chipsets. Two are launched as of now. The Max is still under development, and Max competes with Jetson Orin AGX, if you have ever heard of. It's a edge AI compute board that is capable of overcoming very complex machine learning problems, specifically in physical AI domain. And then we'll talk about VNTK, which is Visual Navigation Toolkit. So for autonomous navigation, you require three core things. First is understanding the free space. So the system has to move. So you need to understand what is the free space that is available. Then you need to localize where you are within that free space. And third you need is path planning. So by fusing these three systems, what we get is autonomous operations. But on top of autonomous operations, there have to be multiple types of missions that are actually useful for the operator. And that is where the middleware SDK comes into play. So anyone can use that SDK to design their custom autonomous mission. And we also provide simulators so that you can simulate a lot of behavior of your autonomous system. So it's a complete system, and we have built most of our products using these two things that we developed in the first formative years. So first thing I'll talk about is GNSS denied navigation. So in electronic warfare, the first thing that gets attacked is the 1.5 gigahertz range. It's very common and used in almost every GNSS receiver. So what happens is that you will get, your GNSS will get jammed, and how do you overcome that? So we have a solution called No GPS, which relies on visual inertial odometry and a custom set of algorithms which perform satellite image feature matching. And it gives the platform the capability to understand where it is within the global scenario, and it helps the platform understand the geolocation of its system. Now, as I mentioned, that a few seconds of link drop leads to significant failure in the success of mission. So what we realized was that there is a significant gap, and we fill that with Chirayu CY2 radio, and it has the capability of connecting with systems that are about 15 kilometers away, and we have tested it in various firing fields in Mahajan, in Jaisalmer, in Pokhran. So what it does is that You have a remote unit that stays on the vehicle, and you have a ground control unit. And of course, there is an antenna tracker involved. So the antenna tracker constantly stays in touch with the platform. It also performs direction finding applications. So right now it is pending WPC certification. So WPC is a certification that is required for, I would say, supplying wireless products to armed forces in India. And we're also working on a CY7, which is the next variant, which will work on 70 megahertz to 7,000 megahertz frequency range. And the key thing that we are testing here by using 5 gigahertz is that we are relying on OFDM and FHSS modulation and frequency hopping systems. So the goal of releasing 5 gigahertz band is to validate that these two systems, OFDM and FHSS, are working. So I'll talk about Chakravyuh. So in modern battlefield, we experience a lot of entities. These entities can be hostile or friendly. And a lot of times we don't want enemies to advance from a particular location. And that is where Chakravyuh comes into play. So it's a swarm system, but it can help you orchestrate how the battlefield decision making happens. So you can bring in any number of unmanned systems into it. You can convert your existing SAM site into an unmanned system. You can convert your artillery into a SAM system, and you can bring it into Chakravyuh, and you can control as many unmanned systems you want. And this has been deployed with various fixed-wing drone companies. We have also deployed this with a jet engine-powered drone company. And right now, we are exploring the option of making it suitable for armed, fully autonomous drone swarms. Now, this product has been renamed multiple times. It started with track, target recognition and acquisition and kill. But right now we call it Dhurandhar because it's a name that clicks with everyone. It is a ATR module, automatic target recognition. So in the battlefield, we have a lot of targets that we encounter. And one of the key activities that we have to do is how to differentiate between a military target and a civilian target. So this module has been trained on a very large data set that we've acquired over a span of 5-6 years. And we have the capability of identifying tank, trucks, military aircrafts, military naval vessels, and also classifying like which country owns that particular system. And it also discriminates between civilian and military targets, so that we do not perform any attack on the neutral targets that are suddenly in the battle space. So this is Vyomastra. It is a terminal guidance system which again works on very small aircrafts and goes up to subsonic aircrafts, and currently being tested in the ITR Chandipur range with one of our clients. This system is capable of controlling the aircraft control surface at very low latencies and is built on top of autonomy SI. And it controls the aircrafts moving at 200 meters. So to give you an example, in 4 seconds we are covering 1 kilometer if the aircraft is flying at 250 meters per second. So in a blink of an eye, the aircraft leaves your sight. So now what happens is that it becomes next to impossible to understand how to control the target. And given that scenario, the target is also, you're closing in on the target at a very rapid pace. So the control systems have to be very tight. And that is where we are at with Vyomastra. So I'd like to highlight that if the machine is not making decision in the battlefield, and if we are still relying on the operator, so there are multiple things that can kill us. So yesterday we had a talk where it was highlighted that if we are detected, then we are targeted. So that is the truest thing that happens. So what Iran did, so Iran launched a mission on UAE and the NATO allies, and what they did was that they sent the aircraft without any EW signature. And the unsuspecting forces were struck upon, and there was nothing that they could have done. And that is what we achieve by combining Dhurandhar, Chakravyuh, and Vyomastra. You complete the OODA loop, which is observe, orient, decide, and act. And by closing the OODA loop, you not only perform intelligence, surveillance, and reconnaissance, you perform the action that helps you define what happens in the battlefield. So I'll slightly brief you about what is included in a missile system. So you have a propellant, you have an explosive, you have a detonator. So these three are usually supplied by whoever is manufacturing the explosives. On top of it sit two key components, assuming that enclosure is already there for the missile system. There are two key components that are still lacking. The first is fuse, and the second is the warhead control unit. So we have supplied warhead control unit and fused to various ammunition depots in India, and we have, this system has been ruggedized and tested and is mill standard ready. So because this talk is primarily about 5 radios and RF systems, so I'll try to keep the next few slides focused on the RF systems. So we use 6061 aluminum, which is a very standard aluminum that is used for machined enclosures for RF systems. So one of the key things that you'll realize is that you should not go for casting, because as soon as you have casting, you have the challenge of having aberrations. You have the challenge of encountering various types of RF behaviors or conduction currents. So you want to prevent casting. It is better to buy a billet and get it machined. Now, seam continuity. So if you have a RF circuit and if you have 2-part enclosure, so what happens in the 2-part enclosure is that the interface between the 2 enclosures start acting like an antenna, because it was mentioned earlier, if you remember the talk with Professor Guha. So he mentioned that if we have instead of having multiple holes, if we have a single hole, that gives us the capability of improving our antenna systems and reducing the number of holes. So the same thing or a similar thing happens when we have a 2-part enclosure. So how do we overcome that? So in order to overcome that, we have to ensure that the joint or the connection point between the 2 seams is grounded. That is the basic thing that we have to do. Next thing, thermal. So thermal is a very important thing, because you have to ensure you have IP65 rating. And after IP65 rating, what it means is that you cannot have any kind of opening which allows dust, dirt, water to enter into your system. So what you are stuck with is only passive cooling. There is no forced convection, because if you install a fan, you are still risking that the fan may get damaged. So how do you overcome this thermal problem? Is by ensuring that the whole enclosure acts like a heat sink. I would like to highlight my earlier point that I made, that engineering or building products, you may be good at RF design, but you have to ensure that you understand the complete background of all the materials and all the manufacturing processes, because you can design anything. You can design anything that you can think of, but can you get it manufactured? Can you get it manufactured at scale? What Professor Guha again said, that it has to be dollar effective as well. Not only elegant, but also dollar effective. Because when you're talking about scale, it has to be, when you're talking about scale, it has to be cost effective and economical. And then moving on to the qualification, like so when we design for military or armed forces, we have to get our equipment through a multiple series of mill standard testing. So 461 is for EMI, EMC, electromagnetic interference and electromagnetic compatibility. We have to go through 810, which is again dust, vibration, moisture testing. JSS Penta 5, which is a very comprehensive, testing setup, and it goes through mold formation, algae formation, and a lot of things. So you have to build something that you can rely on. So right now, if someone has built a drone, they must be using 2 to 3 antennas and 2 to 3 radio receivers and systems. Now, what happens is that if something fails, you have 2 to 3 things to blame. So what we are doing with Chirayu is we are reducing the number of RF connections that you have to maintain. So finally, I'll talk about how to integrate antennas in a fixed-wing aircraft, because that is something that we frequently do, and there are a lot of sources of EMI, EMC issues. So your magnetometer is very prone to any kind of RF radiation. So, but your GNSS receiver is heavily dependent on RF radiation. And you also have to ensure telemetry, because if you do not have telemetry, you don't know what's happening. So one of the things that can be done is you can have 2 antennas for telemetry and video placed on the edges of the wings of the aircraft, and you can separate the magnetometer and GPS by some distance. And now the thing is that the aircraft will not be made of aluminum, because or it may be made of aluminum, but you do not have the grounding done correctly for the aircraft. So there are a lot of nitty-gritty details that you have to verify before you start integrating all the systems. So designing an RF system in isolation is the easy process, but getting it onto a system and getting it validated with certain amount of quality, it's a long drawn out process, and you have to understand the finite details that go into it. So for example, I'll take a carbon fiber reinforced plastic. So if you have a carbon fiber reinforced plastic aircraft, what happens is that material is heavily anisotropic. Now, you don't know how the material or the tan delta, as mentioned in the previous slide, is behaving. So there are multiple things that you have to think of, and when you are flying at very low altitude, you also have to think about Fresnel clearance, because line of sight, when we talk about line of sight radio, it's not just line of sight that is visible to us. It's an elliptical body that gets formed as and when we move farther from the object. So in the previous trade-offs or previous discussions, whatever I highlighted, it was purely about RF radiation and how do we ensure communication with the platform. But again, in wartime scenario, what will give us the advantage is ensuring that we do not have any kind of RF signature. And there are measures to reduce RF signatures. How do we do that? Was covered in previous talks. I will not cover them today. There are various materials that are available. There are various approaches that are available. But essentially, removing the link is the primary thing that we can do to reduce the signature. However, that comes with another challenge. Are we ready for fire and forget missions? The operators who are going to use your equipment in battle are not ready for a fire and forget missions. So I would like to close with this, that again, I can solve the link, but I can't solve the signature. So signature is something that is a very extensive activity that has to happen, and people have to figure out how do we overcome signature. Autonomy is just one way. 3 conversations before I leave. So first thing is that radar cross sections and material groups. So there are things like cavity-backed apertures which are used, and you can have conformal antennas that only radiate when needed, and then I'll talk about manufacturing and process labs, because you can have you can design anything, but can you manufacture it at scale? And finally, for platform OEMs and qualification labs, like we have equipment that is getting validated in the field, has been validated in the field, and is undergoing tests. And we have a long drawn-out journey for CY7 as well, which is going to release in July 2027. If I were to look back and summarize what has happened since 2015 till today, so in 2015 it was don't contaminate the payload. So today it's don't compromise the platform. It's the same discipline, but with bigger stakes. And as engineers and scientists, our job is to make any equipment boring enough for anyone to depend upon. With that, thank you, everyone.
Thank you, Mr. Chintan, for your valuable insight and your product development to our audience. Now, audience, do you have any questions related to this? Yeah. After this, we will closing that. Yes, thank you. Yeah, anyone? No? Okay. Now I call Professor Gangwar to felicitate Mr. Chintan Mishra. Thank you, Mr. Chintan. Now I would call upon Professor Amitra Dikshit to felicitate Professor Ravi Kumar Gangwar. Thank you, sir, for giving your valuable time for this session. With that, we can conclude of this highly insightful technical session. Today's discussion have brought together perspective from academia, defense, R&D, and national laboratories and industry, highlighting the importance of advanced manufacturing and antenna integration and AI into these areas, and RCS control in developing future-ready stealth development defense technology platform. On behalf of organizing committee, I would like to express my gratitude and sincere to our distinguished session chair, Professor Debatosh Guha and Professor Ravi Kumar Gangwar and other eminent speakers. So I'm thank you to everyone, and you can go for the lunch, and you need to resume at 3 o'clock. Waiting for you.
Good afternoon, everyone. Welcome to this session of day 2 of the symposium. So this session is focused on advanced manufacturing, critical materials, and process technologies, a theme that is central to modern engineering, addressing the need for innovative material systems, advanced processing techniques, and scalable manufacturing solutions for next generation industrial and strategic applications. So we have keynote speaker for this session, Professor V.M.S.R. Murthy, who is FNAE and Director of IIEST Shivpur. So I request Professor Murthy to please come on the stage. So over to you, sir. Please.
Thank you. Good afternoon. First of all, let me thank you for your attention. Post-lunch, obviously, attendance is thin, but anyway, I thought, let me share some of my experiences on this topic, very apt topic actually of the times. Though I'm not a manufacturing man, but we help actually for manufacturing. So as a raw material provider and then subsequently process development and ultimately leading to manufacture. So the talk actually goes like this. I just prepared considering the theme of the symposium. So we'll talk about 3 important aspects, and with some case I'll try to explain. And I must thank my colleagues actually from IIST Shivpur, Dr. Apurva Das, Dr. Sunil Bisoi and Dr. Kaushik Das. 3 different departments, mechanical, mining and metallurgy. And here Dr. Kumaraswamy Das from mechanical, and Hemant Kumar and Janatul Bashar, the research scholars who are sitting here. So it's a collective effort. Would like to share like what we did with the help of L&T as our collaborator. So I think you heard about this manufacturing processes. I think I'm not an authority in this, but what I'm trying to learn, because ultimately the country, if it has to grow, our manufacturing particularly has to improve. That's a kind of mandate today, and this mandate has come with such a velocity, you can say, that we are unable to match the velocity that is required to ride actually, the wave that we have to ride. And the Honorable Prime Minister has already set the targets for the country, and the ministries are very strongly pursuing with academic institutions and industries through collaborative efforts, what we call as industry-academia interaction, which is one of the major theme also of this particular conference, and we have industry sitting here. And you can understand that this advanced manufacturing as the engine for India's 3 strategic priorities. One is technological sovereignty, that is our dependence we want to reduce, and everyone would like to achieve this, and we are the contributors for that. And aiming towards Viksit Bharat, and also net zero, while not forgetting the net zero goals. So it's an ecosystem which is integration of advanced materials. So that means one side the research should happen on this processes, precision processes, additive manufacturing. I think we had talks from various speakers in the morning session yesterday also. Intelligent automation, artificial intelligence and digital technologies. I think we have heard about this. So if you look at this, the space on which we are working is semiconductors and electronics, or aerospace and mobility, biomedical, energy and green tech, mining and minerals. If you look at all this, it has different verticals like materials and surfaces, and precision additive processes, and digital intelligence. These 3 layers we are trying to merge today. As I also understand and learn to understand that the digital twins are coming, And we are now into cyber physical ecosystems and predictive modeling for reducing the delays and improving the efficiencies and productivity. And of course, this is another important area, that the next generation materials and coatings and life cycle engineering, these are some of the important areas I think our mechanical engineers and the process engineers must work on, with different materials like functionally graded materials and different methods of doing coating and all. Advanced manufacturing transforms next generation materials from laboratory concepts into high performance application ready technologies through precise control of composition, microstructure, geometry and functionality. If you look at this, is a thorough marriage of various disciplines. So it's a necessity to integrate, and the people should think about just not only about their own vertical, they should think of how to integrate. And now the industry 5.0 tech stack is coming. Already we heard about it. 4.0 is already there. Now we are into human. If you look at industry 4.0 and 5.0 on the right side of the slide, basically if you compare them, the 5.0 is more into resilience, sustainability, human-centric AI collaboration, and cognitive cyber-physical systems. So basically this is what we are right now working with the advent of the technology, and what you are seeing, the two stacks are a digital twin basically that we are creating for advanced manufacturing factory that we are looking. It's a completely AI-assisted manufacturing ecosystem with real-time data analytics. So here the challenges come to the generation which is sitting here and learning, the UG, PG and PhD scholars and the faculty colleagues, how early we can get on to these important areas and see that we do advanced research in our laboratories and take it forward to industry application. In fact, the industry collaboration would give you a finer touch to that. Now, the sustainable and circular manufacturing through advanced manufacturing, if you look at, so it basically goes through take, make and dispose process. So sustainability is no longer an afterthought today. If you look at every stage of production to processing to evaluation to end of life cycle, you need to see that how sustainability has to be integrated. So if you look at the production stage, the zero defect manufacturing, I think you are the best, who are working in manufacturing side and mechanical engineering side. How do we make, so that's why the methods that we use in terms of various, processes like milling and all different kinds of, processes, manufacturing process, the zero defect is our target. And then the processing stage, green machining and energy efficient manufacturing is also another one where you consume lesser energy and also emanate, lesser carbons. And life cycle assessment, carbon footprint reduction, this is another one. You take up any processes, including whether it is not only manufacturing, any other process also. If you see mining also, or metallurgical, metal production and all. End of life recovery also, like we want that, the waste should be minimized. As you know that waste disposal is a bigger problem today. Zero waste is another target, like zero, slowly we are moving to zero defect, slowly to net zero carbon in terms of, and then zero waste also, where the manufacturing and sustainable supply chains can be maintained, and we end up with, a reduced waste and recycled processes so that, they are more energy efficient. Now, if you look at the manufacturing side, the national mission, alignment and the way forward, today we are talking about digital manufacturing ecosystems and sustainable engineering and circularity and advanced materials and AI. And if you look at the government missions, you are aware of Atmanirbhar Bharat, National Critical Minerals Mission. I think most of them are already grounded and they are now into the operational stage. Now the challenge comes now that how quickly we can onboard onto these missions at institutional levels, where industry should be a partner to take it forward. Let's say semiconductor mission, for example, and national hydrogen mission, defense indigenization. Today we talk, we heard of from, DRDL, Dr. Raju was talking about how missiles, the materials have been developed and how they have been engineered. Electric mobility and space technologies and railway. If you look at, I think probably there is no area that is untouched. So the missions are pretty clear. So the future of manufacturing will not be determined merely by producing components faster or cheaper, but by intelligently integrating advanced materials, AI-driven process technologies, digital manufacturing ecosystems, and sustainable engineering to create resilient, globally competitive. That's very important because we want to even export also, not only for own indigenous purposes, and environmentally responsible manufacturing systems. So this is going to be the mandate. On top of it, I was just trying to cover. And moving to this particular symposium has, very interesting components. One is the raw material component also. If you look at the manufacturing to happen, you require iron ore, for example, for making your steel. So now the raw material production equally has its own footprint. So let us understand that how this raw materials production and metals production will really help. If you look at now that critical mineral mission has been identified as one of our thrust areas, well, we have been working on, in mining sector for long, but now the emphasis is completely different. So no industry is left now beyond these goals of, zero waste, zero carbon, and zero defects. That's what we talked about. So critical minerals are going to be one of the important areas that are going to feed us, important metals that need to be utilized with different other abundantly metals like iron ore, aluminum, and all. So how our institutions are prepared, if you look at, and the roadmap if you look for making it. So these are essential for modern technologies, driving innovations, energy, communications, and transportation. So no sector is left. If without critical minerals, probably no sector can really move. So whatever manufacturing we are talking about, the raw material is driven from mining and metallurgical, extractions. So understanding the global geopolitics surrounding critical minerals, this is also essential as supply chains are increasingly intertwined with national security and economic stability across various nations. You know that recently the critical mission has been launched and several center of excellences have been established, one in IIT ISM Dhanbad also. And these are, basically the places where the hubs where the researchers should now cling to and work on. So the key policy initiatives for minerals, if you look at, the government is committed to strategic policies that enhance critical mineral sourcing, aiming to boost domestic production and ensure sustainable development aligned with Viksit Bharat 2047. If you see the defense, renewable, and EVs, these are the three major elements that the critical minerals are going to serve for. Now, if you see the current gaps, I only identified the major ones. The resource allocation. Efficient resource allocation is crucial for bridging the gaps in critical mineral exploration and production, ensuring that institutions are equipped to support national objectives. In fact, the ppm level concentrations are the challenge. So identifying the sources, because we are scarce with critical mineral resources, you all know, and it is coming as a byproduct, when you go for mining for, say, for example, copper or zinc or uranium or so and so, including coal. So therefore, it's necessary that to establish, already we are lacking in exploration. If you look at the area that we need to explore, if you look at, hardly we have explored about 15 to 20% of possible areas that we can reach. So we have a lot of areas that we can reach, which we could not explore, that while doing so, probably this would also help that if you keep critical minerals exploration as one of the targets. Another thing is, like, we have already cored this Mother Earth, and a lot of cores are lying. If you look at these base metal deposits, so we have a lot of cores already preserved, and along with these, mineralizations, you may find some kind of, critical minerals available with the host rocks, so along with the ore. So it is apt actually to utilize those core data, which is not like maybe digitized or the data has not been generated. So if you can get into this area, probably this is one area that the geologists and geophysical experts and mining engineers can think of. How do we catch hold of these cores, talk to these companies like Mineral Exploration Corporation Limited or Geological Survey of India Limited, or mineral companies that are producing, metal companies that are producing like Vedanta, Hindustan Copper. So we can, target this and generate this data, and probably you may find some critical mineral resources there. On one side, we have to look into the skill development programs to enhance or prepare our workforce for future needs, focusing on innovative practices and technologies in critical mineral management, because this is an area where we have not thought about so far. So it starts with obviously putting in place some curriculum. So I am sure many institutes have started now master's programs in critical minerals and metal processing technologies. Particularly, I know IIT Hyderabad has started this, and even IIT ISM Dhanbad also. So, and then centers of excellence have already been established, and the industry-academia collaboration is thickly happening now in a much more accelerated way compared to the previous years. And obviously, the technical expertise and the interdisciplinary collaboration, if you look at, this has to happen now in a very, very concerted way. Otherwise, again, we'll lose the time. Now, the time through which we are going through is a very critical time, and we need to understand this, and we should to get on to this particular job so that we reach to the goals that we are thinking of. Now, at IIST Shibpur, we are just looking at to contribute to the critical mineral sector with industry-academia collaboration through various seminars which are happening and so focused engineering research, meeting the demand of today's mineral sector. The institute has recently hosted a national seminar on and soon plans to introduce electives and aiming to work on mining 4.0 and slowly moving to 5.0 today we talk about. It is also actively participating in various research projects tailored to these areas and finding novel solutions to the critical mineral exploration and extraction objectives. Now, if you look at the processing technologies, this is another important area where we are basically need to develop certain multi-metal extraction, particularly whether it is in the critical mineral sector, or if you look at the nickel, cobalt, these kind of metals that we are really scarce, we don't have, lithium also. So we need to basically see how do we explore the raw materials and the process technologies and finally connect them to advanced manufacturing and then the national competitiveness. So the same thing I told you already, the 4 pillars now on which Viksit Bharat is now looked at is the critical mineral mission and India semiconductor mission, electric vehicle mission, and Samarth Udyog Bharat 4.0. In fact, there the manufacturing part will come. So overall, if you look at the entire process have to be advanced, efficient, sustainable, and scalable. So now what is the role of an academic institute? Now we are talking about academy-industry interaction. If you look at, now the targets are pretty clear for the academic institutions, and we don't have to beat around the bush now. The scholars sitting here or the undergrad and postgrad students can straight away get into these missions and work with their faculty and the industry which is onboarded with the faculty so that we can take them forward with more, objectively. So if you look at the different areas, I don't want to get into details of this, but if you look at, these are all pretty known areas. Sorry. Lithography, automation, I'm just going through the major ones. Computer-aided design, computational materials modeling, smart workflows, geomechanics, mining and automation, hydrometallurgy, and thin film deposition. Actually, I'm just trying to connect the important areas where we can start developing our own projects or research topics, etc., whether it's PG, PhD, or even undergrad also. So I know that students are pretty interested to work on the recent technologies. Obviously, if you look at the semiconductor mission or EV mission and critical mineral mission, so we can very well integrate them and see that this interdisciplinary state-of-the-art infrastructure is developed in the institutes with the help of industry participation. See, we normally create a lab-level kind of experimental backgrounds, but with the help of industry, I'm sure we can scale it up to a pilot project, which is there in some of the departments here in IIT ISM and many of the institutes like IITs and all, and including IIST Shibpur, obviously, and which has an impact directly, greater impact on the society. Now, if you look at why this is not happening, that is the industry-academia contact that we'll talk, in many forums, the disconnect is, still there. So because of various reasons, I think the previous speakers also talked about. So what industry needs on one side and what academia can offer on the other side, if you compare, probably the academia is working in isolation. If you see different labs produce different results, unless you integrate them. On the right side, if you see the academia, these are all lab A, B, C, D. What I'm trying to say is they're all different labs, disconnected. So we need to basically work together, and that overall view probably will, unless you develop, the faculty develops, or the head of the department develops, or the dean research develops, with the help of, industry, maybe consultant or something like that. So I think this gap still will remain. It's better that, particularly for, what I saw while I was in ISM for the last 24, 25 years, ISM, particularly IIT ISM, has long history of industry connect, and therefore it was easy for the industry to understand about the institute. Also, the institute understands about the industry problems, and that's how we found many projects where our students are a part of it. If you see, and also we involve many through interns, many through postdocs also. So therefore, the link is existing already. So if you understand this gap, like for example, the industry needs a scalable, robust process technologies, cost-effective, high throughput, quality, reliability and compliance, short time to market. This is one of the major impediment that comes in our way. But then there, the industry can support us, how early they can scale it up, end-to-end integration and support. So if you understand this, I am sure we'll be able to, and many are now doing this. The connect is now getting closer and closer. So obviously it requires a curriculum that supports interdisciplinary learning, and this happens during final year electives when we choose, our third year or final year when we choose our electives. So if the undergrad project itself is tuned to a particular product, so we see mostly our undergrad students are participating, including in patenting process at IIT ISM Dhanbad I have seen, and this is happening elsewhere also. And similarly, PG students who stay for about a year, who work on a thesis, that also is possible. And PhD, of course, is the place where you can, even up to scaling also you can think of. So understanding about data-driven foundations and analysis, analytics, industry immerse training, this is also another gap, that we don't go out of our four walls of a room or computer. It's necessary that you should visit the industry where you are trying to solve a problem now and then, and try to connect what you are doing is really meaningful to them. And then hands-on operations. So this is how an industry-ready professional is what now industry is looking for. So if you just learn a couple of courses and just do a simple project which is more theoretical, probably you are not the person they are looking for. So let us try to understand the requirement of the times and try to orient ourselves to grow to the industry grade learning. That's what, and then these kind of seminars, and that's what I was talking to my scholars, that we should not miss attending these kind of seminars or symposiums, because a capsule of knowledge is being given to you in a matter of 1 or 2 days, which otherwise you would have got by reading a full course for a 39 to 40 classes. So what you heard in the morning session or yesterday also, these are the technologies that are being used in industry, which probably you may not be reading and seeing them, many of them. So my urge to all my youngsters is to see that don't miss these opportunities, and the teachers should not run around the students actually, right? Whether you are coming into the auditorium or not. Now, I would like to say a little bit on connecting our IST Shipur to this particular themes. So we have a very strong School of Mechatronics and Robotics school, which works on different problems related to industry. So mechanical, robotics and automation, this is a very established school. So we are already offering some good solutions. Recently we worked with Science City for dinosaur movements, like how do we simulate a dinosaur movements. That has been done already and successfully delivered. In fact, it was displayed here in the innovative workshops that we had last time, which was conducted by IT Group. Advanced metallurgy and material synthesis, this is another area where extractive metallurgy we are working, and a good expertise lies with the Department of Metallurgy and Material Science. Aerospace is a unique branch that we have, like many institutes, even IITs and NITs do not have aerospace, very few IITs and NITs have. So IST Shipur, which is popularly known as BE College or BESU, has this, there for long, and then very eminent teachers like Professor Amitabh Ghosh and all, they come and teach. So it's a very good area people are working on, and you can see different products being done. And we have mineral beneficiation and circular mining. And we have a VLSI laboratory, which is a state-of-the-art laboratory. We have designed and developed one chip also, which was displayed in recent, semiconductor mission national exhibition done by Ministry of Electronics. So advanced materials and photovoltaics. We have a solar PV hub. It's called an Eastern Hub, which caters for the entire Eastern India to do research on solar cell design, fabrication. Industry-grade solar cell fabrication is happening in the IST campus, in the PV solar hub. So this is another area where and a very good amount of research has been done for the last 12 to 13 years, and good theses have been produced which are of industry-grade patentable work. And information technology and simulations, research, innovation, and commercialization. So there's a good bit of integration that is happening now, and this is just the connect with the themes that I was trying to make and how the institutions are gearing up. Now I'd like to take through a case where we did some work, and the scholars are sitting here. We took up a problem of design of a cutting drum for L&T. L&T is importing the cutting drum for a surface miner. You must be aware that surface miner is a machine that is used for cutting coal selectively, where the bands are cut separately and the coal is cut separately, but the limitation was it was able to cut only up to 25-30 maximum megapascals of uniaxial compressive strength. But as you go up, the production drops appreciably, and the peak consumption also goes up. So we wanted to design a drum that can take care of harder rocks subsequently. Right now we are targeting on a thick seam where multiple bands are there, and we want to selectively separate them so that on one side we produce, also we reduce the dilution so that a better graded product comes. So right at the stage 1, in 2017, when we submitted this proposal to DST, L&T was on board. Because of our previous association for the last 10 years on various geomechanical studies for surface miner productivity, particularly the diesel consumption, production, and peak consumption, we were trying to optimize and trying to tell them like how in different rock mass conditions things will change. So being a geomechanical engineer, we thought first we guided them, and subsequently with that association, they came on board to design a drum. So together we basically traveled through from 2017 funded project. We finished almost, the field trials are complete now, and we are going to finalize this product actually. So I'm not going to the details of this. This is the kind of seam that we are cutting in various Coal India mines. Those of you from coal industry are aware that we have thick seams being mined, and whatever that white patches and black-white combinations and layers, these are all stone bands which are existing in a 50-meter seam. Approximately 10 to 12 meters are stone bands at different horizons. So when you mine, so it's very important that which horizon you are mining. So the surface miner deployment requires an intelligent deployment, intelligent travel, selectively to separate these dirt bands so that, right at the mine itself, you selectively separate and dispose them in the mine. Otherwise, you will carry them in a mixed condition. Normally, you go by drilling and blasting. Let us say, if you go, everything gets mixed up. The quality of coal comes down, or the grade comes down. Therefore, the price also comes down, so that you can fetch. So therefore, selective mining has become order of the day way back in 93, 94, this was started. Today, entire coal is produced by surface miners. You will be surprised to know that whatever coal being produced from coal mines is through surface miner today. No drilling, blasting. This is the comparison I'm trying to give you. On the left side, drilling and blasting, you can see it gets mixes up. All this 50-meter seam, all that dirt bands got mixed up. The grade comes down. Now you can imagine you are transferring this mixed one through your trucks to different power plants, and power plants, after burning, throw all the material into fly ash or bottom ash. So that's again another menace for environment as well as energy consumption in the boilers. The boiler efficiency comes down. So if you look at the entire value chain, it's really a mess. So then the 90, 94, 95, this technology came, and slowly this got perfected. You can see the mine the machine working here, what you see here probably. And these white bands, are the bands of shale and sandstone and all. So they can be dozed off. You can see there's a front-end loader here, which tries to skim this particular intermittent portions out. And the black one is the coal that's loaded onto the trucks. So therefore, right at the in-situ stage only, you are separating them. This can happen with any other ore also, or selective separation of different grade ores also you can do. So obviously we went into the different mechanics of cuttability of rocks, understanding the rock side and tool side, and trying to develop a model for cutting force estimation, and finally coming out with a kind of design that can be implemented. So I'm not going into details. And then while doing so, the experience of L&T as well as our work with L&T for the last 15-20 years, we tried to integrate and see that how the machine can be designed or the drum can be designed to address this issue. And when you see a particular production chart of a particular year, the green ones is coal. Along with the green one, there is a smaller histogram that is the waste. So every ton of coal you produce, you are producing waste also. That whether this waste is being mixed or separately done is a very important one. So earlier it used to be mixed everything. Everything was getting mixed up. So now we are trying to work it out in such a way that this waste is separated, the red ones are separated, and the green ones are loaded actually. So that's how the quality was maintained, which has become now order of the day, but this still requires a lot of integration of technology, sensors, autonomous machines. There is another research that we can do, even the deployment of the machine, the layouts of the machine running on the face and all, because it's a very dynamic. Mining phases are very dynamic. Today something is there, tomorrow something is there. So therefore it's a very thorough good planning has to happen, and then integration has to happen. And typically if you see the idle hours and the distribution of utilization, the maintenance hours are about 4% and breakdown hours are about 17%. And the working hours are hardly 50%, you can see. So the rest of the time is spent on various idle hours and all. Mainly idle hours are for pick removals and other breakdowns, etc. So we went into the kind of rock mechanics studies that affect the abrasivity of picks. Abrasivity is one of the major property of rock that influences the pick consumption. So we try to characterize that, and different indices, different test facilities were there. I'm not going into details. Compressive, punch penetration, all these are different tests that we do for different materials. And also we simulated, in fact our researchers have simulated about how the forces vary with respect to when the pick cuts. So we have a linear cutting machine developed also. In modeling scale as well as lab scale, we have done that. And then we also use 3D printing, what we talked about the additive manufacturing at a smaller scale. A drum was conceived. You can see three types of options we have worked out with L&T. 25 millimeter line spacing, that means that picks are separated by a particular distance, that is called line spacing. So what should be the optimum line spacing is the question that we were answering in this particular study. So two alternatives only we tried, because 45 is currently in operation. So we wanted to go for a closer spacing, because for harder rocks we require more force. Obviously the more number of picks are required, so the spacing comes down. Simple logic. But then how much it should be, a methodology was designed. Now that design is our design basically, which L&T adapted. And you can see the characterization at the lab scale. We brought bigger blocks, characterized them, and then created a small pilot drum. You can see this is a pilot drum of 0.5 meter width and 0.5 meter dia. And then it runs actually on a moving table, like a milling machine and all. And we try to cut, and you can see the grooves here. The line spacing you can measure exactly 25, 35. After achieving that, we also did the image analysis for the rocks that have been broken rock. So this is basically the hydraulics part, the electrical control part, and the drum part. And this is the mechanical fixture for the moving the plug. This is what the manufacturing part was done by L&T. And this is established very close to this particular hall only, and our scholars are working. So if you look at this is the drum. It cuts, every 10 centimeters we made, certain attempts to optimize the different parameters. These are some of the rock parameters that were done. Of course, the strength, maximum strength that we could test was up to 47 megapascal, though we were aiming to 60. But fortunately or unfortunately, we couldn't get 60 for coal. So 47 MPa was what we did. Then this is the final drum that was designed based on the pilot study that we have done, the force analysis and everything, energy consumption, specific energy consumption, etc. And finally, the drum was designed, and this was put to use in Mahanadi Coalfields Limited in Garjanbahal. It's in Vasundhara area. So this was done already. This is the mine, and of course at mine level studies, we studied all that, vibration, temperature of the peak, all those important studies we have done. Finally, we compared the old drum and the new drum. You can see the performance is good comparatively, and of course the specific energy remained in the same order. So you can see it's between 1.2 to 1.6. The bottom old drum and the new drum, the difference is on the effective production in cubic meter per hour. We could establish the new drum actually could give a higher production. This is what basically we were looking at. And obviously this was a good kind of merger of knowledge at the lab scale, theoretical knowledge to lab scale knowledge to scaling up with the help of industry. So I thought this could be a study that could help the young researchers who are sitting here, the faculty colleagues who are trying to work, that how an industry institute interaction can help us to create a facility for our researchers to do something. And also I'm happy to tell that my research scholars who are sitting here could publish a paper in Q1 journals having an impact of 11 or close to 7 or something like that in different areas. So I'm sure this synergy will really help, and this case could be a sort of thought, sharing this will help you to understand a little more. So that's all I have to offer now, and thank you very much for your kind attention. If you have any questions, I'm ready. Sir. Can you give a mic? Rain is coming. Yeah, please.
Professor Murthy, great talk. And the question that I have, I could put only to someone like you, because you come from mining background. I understand that Government of India is very serious. I'm talking more like an observer. I wouldn't say outsider, because I still consider myself as Indian, even though I don't have citizenship. It's all right, yeah. So my question is more like an observer from outside. Government of India is very seriously taking up the critical minerals issue. And they have established, I think, 7 centers of excellence,
yeah.
Right? My question is why things are not progressing as fast as it could. You can duck very easily that you are not heading one of those institutions because your institution does not have, but still because you are basically a mining person. This is issue not of mining, I think it's issue more of mineral processing, and your institute has one such activity. So why it is not progressing as fast as it should? I'm also part of that. I was part of the Spark that Professor Murthy led at IIT Hyderabad. And in fact, I'm part of the course that he's giving on critical minerals.
Yes, metals.
So,
yes.
so macro course, and I'm part of that. I'm running one unit there.
Okay.
But why it is not? Is it because institutions are working in isolation, number one? Sorry for being blunt. And number two, is it because enough expertise, as a matter of fact, is not there in institutions? And these may be my wrong assumptions, but I would like to have your answer.
I think this is, I partially agree with you, because it has come to the notice very recently, as you know, maybe last 6 months only. If you look at seriously, all these things were being planned for, some have started a little earlier, like IIT Hyderabad has started 1 year ago or something like that. So one is all these 6, 7 centers of excellence are at different stages of their graduation in terms of pursuing the mandate of critical minerals. As you said, right, workforce actually are the research think tank actually, whether they have accepted this as their research topic. If you look at the faculty, if you look at the researchers, they are the people who try to bring the change. So what I understand with my limited knowledge is whether they are really accepting this as their research topic and wanted to take it forward, and how well we are able to do that as an institute administration or a center of excellence, head. That is number one. Number two, I don't think there is any dearth of any expertise. See, we are already doing the similar studies for other minerals, minerals that we are producing. But the amount of exploration towards critical minerals, if you look at, has not been done the way it should have been. So a concerted effort from the companies have to start now first. It has to be, again, the industry, like exploration industries like MECL, GSI, they have to come forward with, working with industry, academia, and think of, generating the physical resource so that can be studied. So an integration has to happen between the industry efforts and the research efforts. So the problem statements are not at formulated the level, the way it should have been. This is what I think. Right? So industry, academia cannot go for drilling and all. They can do some remote sensing, different kinds of technologies they can use and find out some methods and all. But ultimate proving has to happen. So that proving will happen only when we get onto the ground and get into the rock and then try to dig out those portions and try to go for the rest of the things. So pilot scale studies have to start first, and that will start only when the industry come forward and collaborate and pick up some important test beds actually, and then take it forward. This is what I think. But people can be integrated with this, and that's a requirement.
Can I ask a follow-up?
Yeah.
Thank you. Is it also the case, and sorry for being a bit too open, is it also the case of people working in isolation? Reason I'm saying is that you have very good example from BARC. Professor Dr. Day said yesterday that how they worked on, nuclear minerals, and they have very successfully indigenously delivered it in the nation, right? Why, by having those 7 centers, have they put barrier that one competing with other without having enough expertise, rather than them working together in a field that is new? Is that a fair perception?
I think you're right. We are working in isolation. That's what I told also. That's that's a usual way that we are working even today also, not only in critical minerals, anywhere. So now obviously we need to bridge those, break those barriers and work in team. And we have to identify those teams, and mission mode target projects have to be identified and should be pursued. Yeah.
And if so, how did you measure? That is the only question.
So there's a different force sensors are there, X, Y, Z forces. On the bed itself, they are put. So when a block is there, block sits on load cells actually, and then when the cutting happens, no, cutter is free, because it's that we had a telemetric system also, but that we could not install for temperature measurement and all. But here the bed actually below the rock portion that we are trying to cut, we have put some XYZ direction sensors, and it will get you the forces XYZ. You can have a look, it's there in the laboratory. If you get time, and my scholar is here, they can show you also. Right. Okay. Thank you.
Okay, so I thank Professor Murthy for this insightful presentation. And I would like to, may I request Professor Amit Rai Dikshit to kindly come forward and felicitate our keynote speaker. Sir, please. Okay, so now moving towards our expert talks. So I would like to uh, acknowledge our esteemed session chairs, Professor S.K. Ghoshal, Head of the Department of Mechanical Engineering, and Professor Asim Mukherjee from the Department of Fuel, Minerals and Metallurgical Engineering. So they will be guiding this session. So now we will begin the expert presentations. So our first talk is from the expert from industry, Mr. Ayush Dutt, Additional Director of Ashwini Group from Pune.
Hello. Yeah. So a very good afternoon to the respected session chairs, fellow expert speakers, distinguished members, fellows of INAE, faculty members, researchers, industry colleagues, students, ladies and gentlemen. It's a privilege to be here at IIT Dhanbad for the 20th Symposium on National Frontiers of Engineering. I sincerely thank IIT Dhanbad, Professor Amit Ji, and organizing committee for inviting me to contribute to this session on advanced manufacturing, critical materials and process technologies. I am Ayush Dutt. I'm an additional director at Ashwini Group, comprising of Ashwini Magnets and Ashwini Rare Earth. I will present an industry perspective on the journey from rare earth oxide to advanced magnet applications. The central argument here is simple. A magnet is not an isolated product. It is the outcome of a connected chain of chemistry, metallurgy, powder and polymer processing, magnetization, testing, and application engineering. India already possesses the important pieces of this chain. Our opportunity is to connect them, qualify them, and scale them as one ecosystem. Let me begin with the most basic question here. Why do magnets even matter so much? So as you can see here, magnets are the hidden enablers of motion, sensing, and control. They're often invisible to the final user, but as you can see across the slide, they sit inside many systems that create motion, sensing, and control. In EVs, they enable compact traction and auxiliary motors. In wind turbines, they support high torque generators. In robotics, drones, aerospace, defense, and medical equipment, they make actuators and sensing systems smaller and more responsive. Their importance is therefore not the magnet itself, only itself. A well-designed magnetic field can improve efficiency, power density, size, thermal loading, and control accuracy. The electricity or mechanical input still supplies the energy, but the magnet supplies the persistent field that makes this conversion possible. So precision systems rely on compact magnetic motion and sensing. Here the common requirement is compact, accurately controlled motion. In a robotic joint, a permanent magnet servo motor creates torque, while an encoder or resolver measures position, so the controller can continuously correct the movement. A drone uses brushless motors for propulsion and smaller motors for gimbal stabilization. One values power to weight, the other values smooth, precise response. Aerospace and defense systems add higher limits on mass, temperature, reliability, and available space. The applications here are expanding, but the supply system behind them is far less diversified. As you can see here, this slide puts into perspective the strategic problem in numbers. Demand for rare earth elements doubled from 2015 to 2025. The IAE expects continued growth as electrification and automation expand. Permanent magnets also represent about 95% of rare earth consumption by value. So the highest commercial value is concentrated in its downstream use. Now look at the center of this slide. China's share rises as we move further downstream. Approximately 60% of mining, 91% of refining, and 94% of sintered magnet production in 2024. These numbers are really alarming. The diversification gap, therefore, is most severe where the manufacturing value is highest. So the bottleneck is not simply geological availability, it's qualified downstream manufacturing at an industrial scale. Another major news in 2025 was China's licensing shock. It showed how quickly the magnet dependence became factory downtime. On 4th April 25, China introduced export controls on specified rare earth related items. Exporters needed case-by-case licenses. This case was a licensing regime, not a universal export ban. But in a highly concentrated supply chain, the approval process itself became the choke point. So European component suppliers reported production line and plant shutdowns, and automotive manufacturers in other markets reduced utilization and even paused production. The lesson is not that trade will permanently stop. The lesson is that qualified alternatives cannot be created after a disruption begins. Automotive and industrial components have narrow performance windows, so changing a magnet grade, supplier, coating, pole pattern, or can require testing and customer approval. With that global vulnerability established, the next question is, what does India actually possess? So though mining is not our core domain, these are some of the numbers that we've pulled up from the net. I'll just speed through it pretty quickly. India has a meaningful rare earth resource base, as shown at the top. The established total is approximately 8.52 million tons of total rare earth oxide TREO equivalent. About 7.23 million tons associated with monazite and 1.29 million tons in identified hard rock resources. The limitation is composition. India's established monazite resource is predominantly LRE, light rare earths, including neodymium and praseodymium. Official sources report occurrences of heavy rare earth bearing minerals such as xenotime, but India does not have an established economically extractable domestic supply of dysprosium and terbium, the gap that matters for high pressure grades of NdFeB magnets. Now, we will move to the REPM scheme. This is where the government of India's scheme to promote manufacturing of sintered rare earth permanent magnets became important. The approved outlay is 7,280 crores with a target of 6,000 tons per year integrated sintered NdFeB capacity across 5 beneficiaries. As you can see in the process chain, the scheme is not meant to support one isolated activity. The beneficiary must connect the NdPr oxide to rare earth metal, alloy, powder, pressing, sintering, machining, coating, magnetization, and a finished qualified magnet. This is the right policy direction because it targets India's missing industrial middle. Before moving into conversion technology, I will briefly establish how permanent magnet performance is measured. I'm just going to skip the hysteresis loop. So within the hysteresis loop, the second quadrant reveals the terms that we use more often. Br, or the remnants, is the flux density retained when the applied field returns to 0 after saturation. HCB, or coercivity, is the reverse field at which the normal B curve reaches 0. HCI, or intrinsic coercivity, is the reverse field at which the material's intrinsic polarization reaches 0. HCI is therefore the more direct indicator of resistance to irreversible demagnetization. BH max is the largest B times H rectangle that fits under the normal demagnetization curve. It indicates the material's magnetic energy density potential. In very simple terms, it is how much useful magnetic capability can be obtained from a given volume. These parameters help explain why different magnetic families deserve different duties. Okay, coming to the 5 magnetic families that serve different engineering duties. There is no universally strong magnet or best magnet. As this comparison shows, each material family resolves a different balance of magnetic output, temperature, corrosion cost, and geometry. Ferrite is economical and corrosion resistant, where moderate performance is enough. Alnico offers good temperature stability, but comparatively lower coercivity. Samarium cobalt is valuable in severe temperature and high reliable duties. Sintered NdFeB gives the highest commercial energy density, BH max, but it needs careful attention to temperature, corrosion, and demagnetization margin. Bonded magnets are different because bonded describes a manufacturing route, not one chemistry per se. Ferrite, NdFeB, SMFEN, and hybrids can all be combined with a polymer binder. The correct question, therefore, is not which magnet is strongest. It is which magnet is more suitable to your application. India has resources and markets, but the missing middle must scale. Think of the value chain as 7 connected links: resources, separated oxide, metals, alloys, powders, magnets, motors and components, and end-use applications. So starting with the rare earth oxides, which is established in India by IREL, as we all know. I'm also going to run through the capability map of Ashwini Group in these processes. Coming to NdPr metal, we have established 2 routes. The CTR, calciothermic reduction route, has been established with a tri-party agreement with IREL and technology transfer through BARC in July 2021. The other route is MSE, or molten salt electrolysis. We have a total of 180 metric ton per year installed commercial capacity. The commercial plant was inaugurated in October of 2025. Moving down, we have the same oxide to metal technology for other rare earth metals. Then we have processing of magnet alloys, industrial alloy melting, casting, etc. Then after the alloy and powder is made, there are 2 further routes of bonded magnets, sintered magnets, and then finally the motors and end use. Oxide to metal conversion establishes the quality foundation for downstream magnets. Rare earth oxides are stable and transportable, but magnet alloys require reactive metallic rare earth with controlled chemistry. The bridge shown here has 4 jobs: break the chemical bond to create metal, remove residual reactants and byproducts, protect the metal from oxygen and moisture, and release a traceable lot against specification. So the product is not simply metal, it is protected, purified, and alloy-ready metal. Coming to the first route, calciothermic reduction. CTR uses chemical affinity to release rare earth metal from a stable compound. In calciothermic reduction, or CTR, a selected reductant, here calcium, has a stronger chemical affinity for the non-metal part of the feed. In the simplified reaction shown here, calcium forms a stable calcium compound and releases the rare earth metal. After the reaction, the metal must be separated from the non-metallic product. Further, vacuum-based purification then removes volatile residual species from consolidation and testing. The chemistry releases the metal. Separation and purification make it usable. The detailed recipe and operating window are intentionally not shown here. Coming to MSE, or molten salt electrolysis. It uses electrical potential rather than a chemical reductant as used in the CTR process. Rare earth ions move through a molten ionic medium. They receive electrons at the cathode and become metal. A balancing reaction at the anode completes the electrical circuit. Industrial performance then depends on factors such as stable feed, current distribution, heat balance, electrode life, containment, and protected metal collection. The principle is simple. Stable, qualified operation is the difficult part. Now, CTR and MSE both solve the same conversion problem through different operating models. Both routes aim at the same output: qualified alloy-ready rare earth metal. CTR is chemically driven and naturally suits discrete, traceable batches followed by separation and vacuum purification. MSE is electrically driven and naturally suits continuous or campaign operation where the cell remains stable. In our root context, CTR with integral vacuum purification generally offers a higher achievable final purity. MSE can still deliver high industrial purity and steady throughput. The route choice follows production mix, scale, operating rhythm, and measured output. So metal production creates value only when it connects to downstream magnet manufacturing. This flow shows why producing metal is only the beginning. Qualified rare earth metal is combined with iron, boron, and any designed additions to create a controlled NdFeB alloy. Rapid solidification then creates the required alloy structure. The material is broken down through hydrogen decrypitation and then refined to a much finer powder by jet milling. The powder is aligned in a magnetic field, compacted, sintered, and heat treated to develop density, grain structure, and coercivity. Even then, the customer does not have a finished component. Sintered magnets are brittle and usually require machining, surface protection, final magnetization, and validation. As you can see, every single step here changes the quality requirement. Metal purity has strategic value only and only when it can be translated into controlled microstructure and qualified application performance. Let's come to Ashwini magnets, or bonded magnets that we produce at Ashwini Magnets. They are a mix of magnetic powder with a polymer. Because the binder occupies part of the volume, magnetic loading and BR and BH max are usually lower in these bonded magnets than a dense sintered magnet of the same family. The exchange is visible on this slide. We gain net near shape, thin sections, a complex geometry, inserts, overmolding, application-specific pole patterns. A lower output magnet can still produce a better system if it removes machining, adhesives, carriers, alignment, and assembly operations. So bonded magnets should be evaluated at component and system level, not only from the material data sheet. Now let's look at the route through which injection molding happens. Injection bonded manufacturing begins by compounding the magnetic powder, polymer, and additives into consistent pellets. These pellets are dried, melted, and injected into a precision mold. The part is then cooled and ejected. If anisotropic material is used, an orientation field may align the particles while the compound can still flow. Performance depends on the complete process: powder loading, dispersion, moisture, melt behavior, filling, shrinkage, and magnetization. Injection bonded magnets integrate geometry, magnetism, and assembly. The strongest advantage here is not often the molding of the magnet, it is the elimination of an entire assembly. Thin walls, asymmetry, internal features, net near shapes can be created directly. The magnetic compound can also be molded around a shaft, a bush, or a hub. This can improve concentricity, remove adhesives, and reduce tolerance stack-up. The mold defines the geometry, while the magnetizing fixture places the pole pattern relative to a mechanical datum. The trade-off is that more engineering moves into the beginning. Tooling, shrinkage, insert location, thermal expansion, and magnetic validation must all be designed together. Now, another route here is compression bonding. Compression bonding normally uses lesser binder and more magnetic powder than injection molding. The illustrative values shown here, roughly 65% of volume percent for injection and 79% for compression. These explain why compression can provide a higher density, higher BR, and higher BH max. The manufacturing flow is comparatively direct. Formulate and blend the powder, dose it into a dye, compact it under pressure, eject, cure, finish, and magnetize. But the geometry must remain press ejectable, typically rings, discs, blocks, etc. The trade-off here is also that it is a little more brittle and can chip during ejection or handling. So the advantage is higher loading with simpler tooling, often with lower engineering and development costs than injection molding process. To understand the magnetic choices inside both routes, we must separate orientation from magnetization. So, yeah. Okay. I will quickly speed through the Ashwini Group case study here. So, as I mentioned earlier, upstream AREPL or Ashwini Rare Earth Private Limited reports we have an installed capacity of about 180 tons per year of ND metal. This is approximately 500 tons sintered magnets. I mean, it translates into approximately 500 metric tons per year of sintered magnets. The strategic value is the feedback loop shown here. Application duty can help define upstream purity, consistency targets, while better upstream control improves downstream reliability. The value lies in connected learning, not simply in placing capacity numbers besides each other. I'll quickly run through the next opportunities. They are a circular, digitally controlled magnetic ecosystem. It begins even before recycling, actually. It begins with accessible product design, material identification, traceability, collection, sorting. Manufacturing scrap and known grade rejects are the best early streams because their composition and history are much more clearer. End-of-life motors, vehicles, generators will create larger future streams, but they also bring into the play adhesives, coatings, steel, copper, and mixed grades. Depending on condition, an intact magnet may be reused, clean, known grade material may stay in short loop, and mixed material may require chemical recovery. I'll just quickly run through something new that we are developing at Ashwini Group. A very common customer problem is knowing the available space, force, torque, temperature, volume, but not the correct magnet family, as I discussed earlier. A catalog or a grade alone cannot account for air gap, temperature derating, or demagnetization risk. Orsted is a platform that we're currently developing to bridge this knowledge gap. As the placeholders show, the focus is a structured grade database, first pass calculators for surface flux, pull force, temperature, demagnetization, followed by physical testing. It is intended to make decisions more structured and traceable, and it supports engineering. I'll just go through my closing remarks. Let me close exactly where I began. Rare earth permanent magnets are strategic because they enable systems at the center of electrification, automation, advanced manufacturing, and national security. India's opportunity is not just to merely replace one imported product, it is to build an entire ecosystem capable of converting these resources into qualified materials, magnets, and applications, and then continuously improving them. We need capability across oxides, metals, alloys, sintered and bonded magnets, and application engineering too. We must design for quality, commercial scale, and market qualification right from the very beginning. And we must connect industry, academia, national laboratories, government around shared executions, as many of the speakers have discussed here earlier. A plant is an important milestone, but a complete value chain that can learn, qualify, improve itself, and compete is the real objective here, from material security to manufacturing leadership. Thank you once again to IIT Dhanbad, INAE, the session chairs, and the organizing committee for this opportunity. Thank you everybody for your patient attention. Thank you.
Thank you, Mr. Ayush, for that informative presentation. So maybe we can take one or two quick questions.
Hello, very good presentation about the critical mineral processing. I want to know this fact that the People's Republic of China has started these things 3 decades back. And now they have a terrific strategy. They are sending different kind of components in Nepal, stamp made in Nepal, and through this porous border, they are just sending all those things, dumping them throughout the border, because Nepal and India is a very porous border, and all sort of things, and definitely it will be true for the magnets also.
Yes, absolutely.
So what should be your strategy in order to take that, because they are 2.5 decades ahead, and if you plot the curve, this 95% is going to 96, 97, 98, and maybe something which is very, very monopolistic in nature. How to curb that?
So, sir, that's a great question, and we've been competing with Chinese prices for the last 3 decades. So, yes, absolutely, it's very tough to keep up the competition. But then, the reason they're able to do that is because they get these backdoor subsidies from their government, which reduces their costs and enables them to undercut the market prices even further. Plus, dumping these magnets at lower prices then drives the market price even further lower. So one of the suggested plan of action here could be introducing some sort of a duty measure so that these we get preference. I mean, the Indian industry gets preference, and the cost for the magnets which is coming in from China and other places, there are no other places, frankly, it's just China. That has to come up. So that is one way that we can remain competitive. The other way would be to go backward, like integrate backward and capture the entire supply chain, so we are able to compete with even their undercut market prices. Yeah. Thank you.
Okay, so now I would like to request Professor Asim Mukherjee to kindly come forward and felicitate our invited speaker. Okay, so now I invite our next expert speaker, Dr. Pratik Swarup Das from Tata Steel R&D. Over to you, sir.
Good afternoon to all of you, respected session chairs, Professor Amit, and the organizing committee for inviting me to attend this session, Professor Murthy. So it's an honor and privilege to present over here. I would like to start on a different topic altogether. We have been discussing about manufacturing critical minerals, of course, but I will be talking mostly about process technologies. Steel industry, as you know, is actually going through a transition at this moment. India, as you know, is still a developing economy, and it is we are on our growth trajectory. And to sustain that growth, we need to have better infrastructure, and infrastructure means it needs cement and steel. And steel being integral part, we are going to take that growth part, but at the same time, the challenge is to produce steel in a sustainable way. So my topic will be mostly on the towards net zero steel and the technology pathway for industrial decarbonization, where I'll touch upon the various materials requirement as well as process technology and manufacturing that we need to work on. This slide talks about this total carbon dioxide emissions that almost India 2.3 gigaton of carbon dioxide is being emitted, out of which almost 34% is through industries, though electricity and power sector takes more major share, but out of 34%, which includes auto industries as well. Steel industry, around 10 to 11% contribution is on account of steel industries. Now let me come back to the Indian scenario. So India, this number is 2024 as on date. Today we have almost 222 million tons of steel is being produced. Now we are targeting for almost 2070, 500 million tons, and by 2030 almost 300 million tons. Now what that means? For every ton of steel that we make, almost 2.5 tons of carbon dioxide is emitted. And at this rate, if you want to achieve this we want to achieve 2.2, which is around 25 to 30% reduction. Also, almost 100 million tons of carbon dioxide needs to be abated. At 500 million tons, 2070, if you want to meet that target of net zero, almost 70 million tons of carbon dioxide need to be abated. Then what it means? To touch upon that, just to tell you that Tata Steel, we are the 10th largest producer and almost more than 25 million tons of steel only in India at present. And it is the second most geographically diversified steel industry, integrated steel industry in the world. Now, before getting into a steel industry, I'll just touch upon these slides. This is a busy slide, but I would just like to tell, this talks about how steel is produced typically. The bottom part of the slide, it talks about, typically if you take the raw materials are coal, iron ore and fluxes like lime, dolomite, and the coal is converted to metallurgical coke, which acts as a reducing agent, and this coke reduces the iron ore, lump iron ore, as well as agglomerates, which are made through sintering and pelletizing process to reduce to pig iron. That is in a blast furnace, which contains around 4% of carbon, and that further is refined in a BOF, which is mostly prevalent these days, and subsequently refining is done. On the top half, the new technologies that is coming up is not the new technology, but new processes that people are venturing into is natural gas or hydrogen-based DRI, where it is taken into electric arc furnace, and it finally goes through the same process of refining. Now, almost 92% of steel is currently being made through blast furnace route. Now, what it means the blast furnace and BOF route is going to remain. And till the blast furnace is there, entirely fossil fuels cannot be replaced. Now, we need to look for alternatives, because these blast furnaces, those have been set up recently, are going to be there till 2050 or maybe beyond that. So now that means we need to abate these carbon dioxide from the steel industry, that we have to do it from blast furnace, because blast furnace accounts for almost 70% of the carbon dioxide that is emitted in a steel industry. Now, Tata Steel scenario, if you want to achieve that 40 million ton, almost 98 or nearly 100 million tons of carbon dioxide needs to be abated. And if it needs to be abated, then 16 million trees needs to be planted if you want to, abate the carbon dioxide through the photosynthesis route. Now, that is really an unrealistic target, so the option is to look for alternatives. Because steel industry is going to grow, blast furnace is going to remain, so what is the way out? India, since it is a growing economy and second largest producer of steel in the world after China, if you want to achieve this target, I need to look for sustainable way. That means to meet the need of the present generations without compromising on the ability of the future generation to meet their own needs. So how we can achieve that? So there are basically three pathways. One is how you can improve upon the existing process through process improvement by optimizing your raw materials, the energy, the process footprint. Second is, there are two other levels which we call it carbon direct avoidance. So it means you are using something which is non-fossil or non-carbon based, like utilizing hydrogen per se. The third is the carbon capture, utilization and storage. So all these three needs to be worked in sync to achieve the net zero target. So because not one solution will solve all the problem, it needs to have a bouquet of solutions to solve this problem. Now coming back to process efficiency, how the materials would be of importance. Now if you want to achieve this target, let us say we want to use non-coking coal, more and more of non-coking coal in coke making, then we need to synthesize some additives which can convert non-coking coal to coke, or it will reduce the carbon requirement in the steel making process per se. If you are talking about iron ore pellet making, we need to have greener flux, which will have lesser carbon dioxide footprint. Just these are food for thoughts. The other is, let us say we have installed one waste recovery systems which captures the waste heat, and these kind of materials needs to be developed which can capture the waste heat, and either you can convert into provide the heat where the requirement is there, either as a heat pump or a craft block or some technologies like supercritical CO2 cycle, where you can capture this heat and you can utilize as a waste heat source, or utilizing something like a ORC, organic Rankine cycle, or a thermoelectric generator, or thermophotovoltaic to convert this waste heat into electricity. So then it will be greener source. Now coming back to this, like I was mentioning about 2 decarbonization pathways, if you want to achieve net zero for in a steel industry, one is carbon direct avoidance, and for which hydrogen would be required, and if it is CCUS, also hydrogen would be required. So we have 2 major verticals through which we can achieve the net zero. It is CCUS and CDA, and 2 enablers are, of course, hydrogen, and for generating hydrogen we need renewable electricity. Now, to achieve all this, if we talk about hydrogen, then there are possible pathways, like what are the green ways of generating hydrogen? Because hydrogen is required at bulk and at a scale, and for which the electrolyzer still remains the only way, and that has very high area footprint. It is not also cost economically viable. Second is biomass routes are available, but biomass supply chain is an issue. The other is what we are expediting is utilizing the off gases and convert it to hydrogen bearing or hydrogen rich gases through some processes we will touch upon later. With regard to carbon dioxide capture and utilizations, sequestration, India doesn't have that geography to actually sequester beyond a certain limit this carbon dioxide. So if you want to capture also carbon dioxide, the utilization becomes an issue, because utilization means we need to work on various technologies which will have lesser carbon dioxide footprint, lesser energy footprint, and works without hydrogen, because hydrogen is at the end of the day, will be required. This talks about, for hydrogen, we injected the highest amount of hydrogen till date in a blast furnace, and for which it was done at scale, so it can be done. But problem is that where to get the hydrogen at cost. So these are the various hydrogen production technologies that if you want to achieve, then it needs to be less than $1.5. What kind of volume will be required? 600 tons, which is very huge, and we are calculating if you want to decarbonize on this the Tata Steel through use of hydrogen, it will be consuming almost 1/4 of the hydrogen that will be India's target is there. So that is the kind of numbers that I'm talking about. So we are working on various technology through water gas shift, through chemical looping combustion technologies, through a process called stepwise, also electrochemical pathways to convert these off gases to hydrogen rich gases, and these are at the advanced stage of this discussion and designing. This is a strategic pathway or decarbonization radar, I would say. So what it talks is on the left side of the this semicircle that we are talking about, there are some exit technologies, there are some retrofitting we need to do, and there are some disruptive technology we need to work on. So exit, I'm already talking about this hydrogen injection or methane injection kind of thing. Retrofitting, I touch upon a couple of technologies, which is EasyMelt and Hysana, which we are doing at a very scale, investing thousands of crores. And on the disruptive, there are also technology which doesn't use hydrogen. Like Israel, there is a technology called Helios, who are using sodium to reduce iron ore. So because sodium will not have any carbon dioxide footprint. There are people who are working on leaching followed by electrowinning technologies. There are people who are working on molten oxide. You must have heard about Boston Metal. So all these we are expediting. So all these are being parallelly worked on, but there is some way to go till these technologies reaches the final stage of deployment. But if you want to achieve this net zero, then all this needs to be work in sync, like makeshift, retrofitting, as well as disruptive. Now, EasyMelt that I was talking about, you must have read in newspaper, this is in public domain, where actually EasyMelt is a technology where the stop gas that comes out from the blast furnace, this is composition of carbon dioxide, carbon monoxide 25% odd, then 3 to 4% hydrogen, and rest 45 to 50% will be nitrogen. So now these top gases can be converted along with CO. We can do dry reforming, where you can get either the off gases or coke oven gas or natural gas once it is available. This can be converted to a syngas, which can be injected through a shaft, or if you heat it through a plasma, can be up to 2000 degrees centigrade to the bottom of the blast furnace, that is called TUR as well. So now what it means? It means that with this technology, almost 70% of fossil fuels can be eliminated. So it has the potential. But these are all at a pilot which Tata Steel would be doing. And This is this blast furnace PCI, which call it pulverized coal injection, all this agnostic, and here we can also utilize part of low-grade material. Now coming to the other technology that we are betting upon is being developed for quite more than 2 decades at our Netherlands R&D center, where actually this is two part of this. This is kind of a converter furnace where actually bottom part is smelting reduction for vessel, and upper part is your basically this is cyclone converter furnace, where actually you can utilize through this technology very low grade ore having high alumina. This doesn't need a coke oven or agglomeration, which will have their carbon dioxide footprint itself. Besides, the carbon dioxide that comes out from the top of it is quite pure. So if you want to utilize this carbon dioxide for any application or usage or capture and convert it to some other product, you don't need further purification. So these also we are setting up a new plant, and the investment is to the tune of thousands of crores. After that, the strategies on the CDS that I was showing, this is on the carbon dioxide capture utilization on the CCUS, which is basically makeshift, retrofit, and transformational. All these 3 parts I have tried to cover. On the makeshift part, we are currently working on technology which is CO2 capture. Already we have installed a 5 tons per day CO2 capture plant, and on the chemical looping combustion, which converts the off gases to hydrogen-rich syngas. On the retrofitting, of course, we are trying to work on through whether we can do CO2 sequestration, we can do, or convert CO2 to methanol, these kind of products, or biomass gasifications. On the transformational part, of course, the CO2 needs to be utilized, and for that we are working on various thermochemical pathways, electrochemical pathways, where CO2 can be converted to either syngas, or subsequently CO2 can be converted to ethylene, and subsequently ethylene is the precursor for many other platform chemicals, like whether it can be ethanol or ESF or any kind of products can be formed. We are working on SOEC and photothermal waste as well. Those are actually early stage of development. So this needs, I mean to say, a bouquet of solutions to achieve this either carbon direct avoidance or CCUS kind of targets. This already I have touched upon, like blast furnace gas, how it can be utilized with or without hydrogen into various products. It can be polycarbonate. We are also expediting into biological routes through a company. You may be knowing that you can convert through biological process CO2 to ethanol. Now, of course, if you want to achieve net zero, it needs to come with circularity. So where academia interface would be required is a lot of DFT and molecular dynamic simulations would be required to develop, synthesize right kind of materials, like whether you called it MOF or COP, like metal organic framework, or COF or POP, whatever you are trying to capture CO2 in an efficient way, having less energy footprint, less carbon dioxide footprint and area footprint, then the breakthrough material needs to be worked upon, and for which AIML and DFT would be required, which needs to be think upon by the academia. Besides, we also need very disruptive catalyst. If you want to utilize carbon dioxide in an efficient way and cost-effective way, then the catalyst needs to be developed, which is cost economical, non-toxic, as well as can convert with lesser energy and carbon dioxide footprint itself. So all these in sync needs to be worked so that this industry and academia interaction is very much required, and breakthrough disruptive has to be brought in if you want to achieve net zero in a steel industry. Now, of course, chemistry, durability, and circularity are 3 pillars of sustainability. So circularity, I touch upon some part of the circularity that we are working upon, where materials is important. Like we have developed a pilot plant where the low-grade manganese ore have been converted through a leaching followed by electrowinning process to generate gamma manganese oxide. And gamma manganese oxide is a potential source for EVs, so which you can use as a cathode material, like lithium manganese oxide or LMO chemistry. The gamma manganese oxide is used. So this we have done at a pilot scale. I will not getting into the details because of paucity of time. Similarly, on the cathode part, when we are working about lithium iron phosphate or lithium manganese oxide, on the anode side, graphite is the most preferred material, or synthetic graphite. So we get coal tar as a byproduct in our coke plants. So through that is a potential materials for many aromatic products. Like this can be carbonized, further subsequently calcined, and it can be converted to synthetic graphite, which are potential anode material. And all the batteries as on date mostly use this anode material as graphite. Besides, these carbon materials are also potential source of not only needle coke, which is used for electric this graphite electrode manufacturings. We can make actually carbon fiber from coal tar pitch, which a very high modulus carbon fiber can be made, which can be used for many applications using defense. We have worked on process, we have developed graphene quantum dots from coal tar, which can be utilized for various applications like bioimaging and biosensing applications, as well as many other applications. Quantum dots you must have heard about. There are many applications where including LEDs and anywhere you need high fluorescence. So this is in a nutshell that many things that we are working on. Apart from that, also that materials that we need to work on is, because if you want to decarbonize, waste heat to energy conversion is going to be important. What we have worked on, we have collaborated with JNCSR and developed some material which basically thermoelectric. Through Seebeck effect, we have installed this plant as well and generating from low grade heat to electricity, where we have worked on a special material. This is bismuth telluride material with some germanium selenium doping, where you can actually, we are getting the highest level of ZT reported till date, from which can convert low grade waste heat to electricity. So if you want to achieve this net zero target, we need to work in sync. We need to work on various materials, new processes. We need to also keep in mind the circular economy part of it, where industry byproduct and waste can be converted into value-added product. And this needs a whole ecosystem because it needs a bouquet of solutions. So government is putting a lot of efforts, a lot of task forces, like Steel Ministry recently has set up 14 task forces for working on various areas of steel decarbonization and making green steel. DST has set up many task forces, and CIA is also working to work on various task forces to decarbonize the hard-to-abate sector like steel, cement, chemicals, oil and gas, etc. So we need collaborations, finance and support, and to work together and make this fundamental research into translation and subsequently commercialize. Thank you. I think I am on time. Thank you so much.
So thank you, Dr. Das, for this wonderful presentation. Now we can take one or two quick questions from audience.
Sir, what are the green ways to reduce the carbon ash coming after burning of coal from the factories? Like the carbon or ash coming out after the burning of coal.
Oh, you are talking about combustion. You see, did I understand your question properly? So you want that from coal combustion that is coming out, that product, how to decarbonize? That is what your question is?
Yes, and mainly the ash coming out after the burning of the coal.
Okay, ash is an issue. Of course, I'm talking about steel industry where you use coke as a reducing agent, but I can answer your question. So combustion anywhere will generate fly ash, and that is an issue. So people are working on various ways of utilizing, like fly ash bricks are being made. We are working with Monash on some projects for extracting, rare earth from material from fly ash. So these are the various ways of utilizing for potential sources. But if you combust coal, there will be carbon dioxide that will be emitted for sure. Okay. So the only way is that you need to work on CCUS, like either sequester it or you need to work on whatever you can capture the CO2 and convert it to various products, which are considered green. Although not entirely, but you can at least recycle in the system itself. The other aspect is now people are looking into biomass in a big way. Once the supply chain is established and you can grow some fast growing variety of biomass, the biomass is considered carbon neutral. So if those can be utilized in a power plant or for combustion applications, you can reduce the carbon dioxide footprint. I think government has mandated already to utilize, I think 5% if I remember correctly, to utilize biomass-based material, torrefied biomass or biochar into the power plants. So does it answer your question?
Yes, sir. Thank you.
Okay. We have one more question.
Very recently, our neighbor has implemented 1 million ton near net steel production in Zhangjiang in Guangdong. So when we can achieve these things in the coming decade, or we will take more than a decade to go for that?
That's a very good question, but actually there are roadmaps, like I was showing you a few roadmaps. So people are working on various technologies. Some are breakthrough, some are, like the easy melt that we are investing on, or Haisarna, that will reduce the carbon dioxide footprint substantially at scale. But at the same time also people are working on DRI, that if you can use DRI, but DRI fuel natural gas, still it will have some carbon dioxide footprint. But if you use hydrogen based DRI, of course you can do it. But the real situation is when the hydrogen will be available. So that is the question. So hydrogen is stopping from getting complete decarbonization. And also, like I was mentioning about few technology, one is molten oxide, this electrolysis process, or the sodium based reduction. These are actually at TRL level 4, 5, 6 kind of things. So those will materialize. Obviously these will be breakthrough. But let me tell you and accept here the fact that blast furnace steel remains the more efficient process for producing steel at scale and at the cost that we want to achieve. Till we get that premium kind of thing, or carbon taxation would come at that scale. Like India, we are still discussing, hopefully in October, November, something would come, but that numbers that I'm hearing about is maybe 1/10 of that what we are at present in the western part. So till those get materialized, since India is already growing, so we are taking the target, not exactly science-based, but specific usage-based kind of emission target, not the science-based target. So hopefully by 2050 some numbers would come, but I cannot tell you exact number when it will be achieved. I'll be wrong if I can tell you the right number, but parallelly many agencies are working. Yeah, true. Yeah, Europe. Tata Steel, we are trying to go together. Yeah, like electric arc furnace you are talking about, those are possible ways to get into the next way. Like you can use scrap, DRI, or you can get scrap based. So at Europe we are going into that. Those will come very quickly. So if you are talking about Europe, those are already in target, and the Europe it is going to be, particularly Port Albert plant is going to be electric arc furnace based. But in India it will take time to come. So thank you.
Thank you, sir. Now may I request Professor S.K. Ghoshal to kindly come forward and felicitate our invited speaker. So our next expert speaker is from academia, Dr. Ankur Gupta from IIT Jodhpur. Yeah, over to you, sir.
Good afternoon, everyone. Before I proceed, I would like to take this opportunity to sincerely thank all the organizing committee members of 20th Symposium on National Frontiers of Engineering and Innovation in Manufacturing Practices. Special mention to Professor Amit Rai Dikshit ji, who has invited me to come here and present my work in person here. The title of my talk is Next Generation Multi-Material 3D Printed Pyrolytic Hybrid Scaffolds for Textile Dye Remediation, in which I have taken this particular work to present here, considering the theme, Innovation in Manufacturing Practices, which have some innovative manufacturing approaches. In fact, it is the integration of not only 3D printing, but also pyrolysis and nanostructured fabrication. So here, this is the place where from where I have come, IIT Jodhpur. So I would like to visit this place. It's a newly growing institute full of flora and fauna. Coming to the motivation of the work that I am going to present here, there is a burgeoning need of purification of water. Even in the Rajasthan, in the state from which I am coming, have thousands of industries, textile industries, which dumps their used water, which has not only contain heavy metals, but also a lot of colors in that, which basically the complex dyes, mixed dyes, and they dump into water. So not only Rajasthan, but if we talk about all across the globe, even we have 70% of the space filled with water, but only 1% or even less than 1% of water is of use or drinkable in capacity. So considering the major theme and the real problem, in fact, which I would say from fashion to pollution, this is the harsh reality of textile industry practices, which we as a scientists or researchers are bound to take some remedy and possible remedy for future generation. So here, it's a kind of graphical abstract that I have put up for the brief overview of the work. So first of all, we do 3D printing and then pyrolysis to make it intact and rigid structure, and then followed by the functional platform in and around being developed by certain processes, in-house processes that we have developed in our lab. Mostly we worked on the miniaturized devices, which is the combination of microsystems and nanotechnology. And the beauty of this going into miniaturized scale is having high functionality and that too at the miniaturized scale. So overall, with the help of photocatalytic degradation mechanism, we have done this task, which is not only environmentally friendly and sustainable, and also it degrades a wide range of organic pollutants, and it requires only a photocatalyst and light, which minimizes chemical usage, which helps in breaking down pollutants into harmless substances like water and CO2. And in that way, that can be applied not only for the smaller scale, but also for large scale wastewater treatment. The textile industry's mechanism is a bit clear. It is used for sizing, desizing, bleaching, massaging, and then dyeing, followed by printing and finishing. In the process, they dump all the residual and water into the rivers, which affects the human life. So overall, if I were to speak, this work aims to fabricate parallelized 3D microstructures, which is decorated with nanowires. That is a network that we have been able to develop in and around those limbs of the 3D printed structures. And then we measure the photocatalytic performance. So there's a portable on-site solution which we are exploring in order to have wastewater remediation using not only UV light but also sunlight-driven photocatalysis. So overall, these are the steps that we have followed. We have optimized these steps. First is the 3D micro lattice creation, which is the limb is of 400 micron. Overall, the 3D printed structure of 10 by 10 by 10 millimeter cube, which was printed using digital light processing 3D printing, and the commercialized customizable, the photoresin was frozen aqua resin, which was followed by the 60-minute UV curing process after following this printing. Then structure underwent pyrolysis. This is also a two-step process in which at 300 degrees Celsius, we allow certain thermal treatment to get rid of all the solvent precursor, and then followed by a next level of heating at 900 degrees Celsius, where actually those structures, those photoresin becomes carbon in nature. And then we grow after this process. We allow zinc oxide nanowires to grow via chemical synthesis. We have set protocols to follow. And after following all those protocols, we have grown zinc oxide nanowires as a functional film in and around those structures. So while pyrolysis, what we have achieved is the shrinkage of the overall area close to 50%, which has made that whole structure intact and lighter in weight, so that its density is lesser than the water, so that it can easily float on the water. These are the characterization. What we have done all the intensive characterization in the form of FESM, EDEX, etc. So if you see, these are the first picture on the left side is the structures that we have drawn up via 3D printing, and then after pyrolysis, the structure got its shrinkage up to 50%, and apart from that, the carbon also thermochemically degraded, thereby leaving pores and rough structures. And then at the next third step, which is a unique one, which is the creation of those nanowires, which is of around 1 to 5 micron in length and around 50 to 100 nanometer in diameter. So there's a woodside crystal creation that has been formed in and around the limbs of these microlattice structures, which has actually created this cubical functional platform. And we have also tested for its contact angle measurement as a goniometer, through which we realized that these structures have turned up into hydrophobic. Then we tested for its whole compatibility with this, whether it is degrading with the help of photocatalytic mechanism. We have in-house setup, which we have used for its exposure to the UV light, and the being zinc oxide being associated with the carbon that creates being a semiconductor, and then upon specific wavelength exposure, this the electrons from the valence band goes to conduction band, and then they releases electron and whole pair combination, and because of that free radicals arises, and that are responsible for breakage of this complex bond. So here in this case, rhodamine B dye as a nascent we have tested, and there are other dyes we have also tested. In fact, we have characterized it in extensive manner in the form of variations of pH on the degradation efficiency of structures, which is under UV light, and we have also tested for repeatability. This is the NMR spectra. You are seeing the slide, which actually indicates the disappearance of aromatic group, which suggests that the breakdown of chromophore structures, and that also gives us the proof of removal of the coloring reagent. So as a summary, with this work, with this innovative manufacturing approach, we have successfully fabricated three-dimensional hierarchical structures by growing zinc oxide nanowires, functional nanowires on 3D printed pyrolytic carbon microstructures. And we have demonstrated this whole hybrid structure in photocatalytic degradation of rhodamine dye, which is one of the complex dyes to break even by the natural instinct. Under UV light, we have achieved 98% of degradation efficiency. That is within 180 minutes. Under direct sunlight, we have tested these films, which has achieved near about 80% degradation efficiency of rhodamine dye in near about 280 minutes. And these structures eliminate contaminants from the wastewater without any additional equipment. And it has, so at the laboratory based testing has been done, and we hope to envision it, to extend it for the, to go it for commercialization and the practical aspect exploration. So these are the references that we have taken to refer for this work. And I would like to acknowledge once again the organizing team. Professor Amit Rai Dixit ji is here, and the whole IIT Jodhpur infrastructure, which has assisted us in performing these tasks. The great assistance that has been, and great support, in fact, I would say, of MTech and Masters and PhD students, that those few have been graduated, few are there here. So overall, with the support of all, we have established this microtechnology lab. I would like to acknowledge here, and thank you very much for your attention. I will be happy to take questions now.
Yeah, maybe we can take some questions. Yeah.
Wonderful work. I was just curious, the second stage you said reduction. Is it three-dimensional uniform?
It's a three-dimensional and geometry confined in a similar manner, similar fashion.
Acha. So how does it happen? Any science behind it, or?
It happens because of the thermochemical degradation, because it's a resin, photoresin, and based on the equal kind of pressure and pressure ambience that we are giving.
Sir, you can use the mic so that. Sorry. You can go to the mic. Yeah.
So here the logic is we have created that structure, and then we put up in the furnace where the equal air pressure or all sort of optimized parameters that are being impacted on the body, and thereby equal shrinkage that has happened. Okay. So let's say 10 by 10, 10 mm by 10 mm by 10 mm structure was there. It has beautifully shrunk down to 5 into 5 into 5. Okay.
Okay, it's almost like hydrostatic pressure inside,
almost.
you did aerostatic pressure.
Absolutely, sir.
Acha, the second step was, then you started burning. Pyrolysis happened.
Burning pyrolysis happened up to 900 degrees
And then
Celsius.
Zinc
oxide, that is a separate third step process,
Third
sir.
step process. Okay,
Right.
excellent, excellent.
Any other questions? Okay, so since we don't have
Thank
any
you
other
very
questions,
much.
thank you very much, sir. And I would like to request Professor Asim Mukherjee to kindly come forward and felicitate our invited speaker. Okay, so we have come to the end of this session. So I would like to request Professor Amit Rai Dikshit to felicitate Professor S.K. Ghoshal and Professor Asim Mukherjee, our session chairs. So next we will be having a mentoring session for young engineers to make startup. The resource person for this session is Professor J. Ramkumar. Sir, please.
So good evening. आप लोग थक चुका होगा ना? So इतना अच्छा खाना दिया, एम्बियंट भी सोने के लिए अच्छा एम्बियंट है, एंड बाहर बारिश और ह्यूमिड भी था ना, so इसके लिए you would be forced to sleep. Okay, so let me help you in motivating you. Right? So that is the session for the next 20 minutes. First of all, about innovation. So this is exclusively for students. So एक request है, आप लोग आगे आ सकते हैं क्या? इधर उधर अलग अलग जगह पे बैठा है. So थोड़ा आगे आ जाइए please, so that आपके देख के बात कर सकते हैं हम. हाँ हिंदी, हाँ, thank you sir. Thank you. So thank you very much. आप लोग, you have been so cooperative, so nice. Okay, so the first question to you all. It is not a session of teaching, right? It's a session of discussion. It's more of dialogue rather than monologue. हम अभी teach करने के लिए नहीं आया, हम सवाल नहीं पूछते हैं, हम अभी mark नहीं देते हैं. So it's you have to practice. So the title of this today's workshop is IMP. Expand करिए IMP. Can you please? Very good, very good, very good. So what is innovation? What is innovation? हाँ बोलो, जोर से बोलना है भाई. Very good, very good. Something which tries to solve real life problem, right? That's innovation, isn't it? Or any other definition? Any other definition? भाई इसमें एक important चीज ये भूल गया. What is that? Uniqueness. Okay, then? See, innovation means it is you try to do or try to solve somebody's problem for which there has to be somebody to get or give you money for it. Right? That is innovation. If there is a real life problem, you try to solve the real life problem, and if somebody comes forward in buying that solution, then it becomes innovation. What is the difference between innovation and invention? आपने बोल दिया एक बार. Or anybody else can make an attempt? If not, then you make an attempt. Anybody else? What is the difference between invention and innovation? बोलो. समझ नहीं पा रहा है भैया. बोलो बोलो. Okay, so you can pass on the mic to her. Yeah, yeah, please go ahead.
Okay, the invention is something that unique for particular person, and invention is something that the first is generated by to solve some problems.
Good. So she is right. So invention means it has to be new. It need not solve anybody's problem. Right? For example, 16th century somebody found out binary. And then the first use of binary came in the beginning of 19th century. So it was 300 years inside a dabba kept deep inside. किसी ने आके then 19th century में हाँ ये important है sir, microprocessor के लिए लेते जाएंगे. So he started using it. And then today we use quantum and other things. So there is a big difference. So innovation means you don't have to be new. You can do cut and paste technology across departments or streams. But try to solve a problem and for which somebody is ready to give money. If you try to solve a societal problem, maybe काफी कुत्ता है, I will try to now drive away all the dogs. Will you get money? No. So what Government of India wants is innovation where your idea, you can sell it and somebody else buys it and he should be able to feel happy by your solution. So for innovation, there has to be only 3 steps. It has to be novel. For example, if I want to give a notice to you saying that please come to my shop, please come to this conference. If I give a plain paper, you will take it and then you will throw it and go. Isn't it? But vice versa, if I crush it and give it to you, आपको इतना time लगेगा पूरा को open करके, then पढ़ेंगे, oh conference है क्या? ठीक है, उसके बाद भी फेंकेंगे. But the difference is you have made me to study what is there in the notice. So it is a novel approach. Is that clear? So the first thing should be, it has to be novel. Second thing, it has to be societally useful. It has to be societally useful. For example, I cannot develop a bomb and come and say, here is a bomb which can blast and then remove everybody here living in this society. So here is a bomb. I can clean up the world. So here is an interesting solution. Will somebody buy it? No. And your innovation should not be for that. So that is a point number 2. Point number 3 is, it has to be non-obvious to a regularly using person. For example, moment I say swing, what comes to your mind? The swing goes like this, isn't it? If I invent a swing which goes like this, why not? A swing, can't it go like this? Or can't it go like this? Or can't it go like this? It can, right? But for you, when I said swing, this is obvious. If it goes in a sector, it is non-obvious. For you, even a swing enjoying person, you would have not thought of a swing which can go in 0 to 180 and come back to 0. So this is non-obvious. So there has to be 3 things in your innovation such that you try to develop it and then demonstrate. Is this clear? So jo innovation hai, innovation has to have 3. And then finally, the innovative solution has to give a wow factor. That means to say, by looking at the solution, I should say, oh man, good. For example, we all buy Cadbury's chocolate. And all of us, Gen Z, Z, whatever you are. So you're all more conscious about your health. So what do? You immediately look back and see what are all the ingredients in the chocolate. Don't you? How many of you see the ingredient? मतलब ले चिप्स है, ले चिप्स का picture देख के, अच्छा ये है. How many of you see? Good. So suppose if it says 2.5 grams of sugar is there. So what do you feel? It's pretty high, pretty low. What is that? I don't have a feel at all. No? It says 2.5 grams. So maybe in that 32 grams of chips, whatever is there, 2.5 grams of sugar is there. Now you tell me, is it a big number or a small number? It's a small number, right? Earlier you felt 2.5 is big. Now it's 2.5 is a small number. Out of 32, 2.5. But still, I don't have a feel for 2.5. But if I convert that number 2.5 and just put a tag or a logo besides it saying that आप ये जो 2.5 digest करने के लिए 15 minute दौड़ना है. Now you will realize what is the amount of influence if I eat this chocolate is going to do on me. How do I burn the energy? I have to run for 15 minutes. So now the innovation here is making a small tag and telling 15 minutes. This is innovation. This is non-obvious to all of us, isn't it? Right? So this is what is innovation. Government of India, what they want is, this is what they want. They want you to develop products which you can go to the market and sell, wherein which people are happy to buy your product and then they try to give you money. Is this clear? Many a times what do? We try to develop a product which is fascinating for us. And then we say, sir, ये बड़ा project है, बढ़िया project है, चला के देखिए, ये कर सकते हैं, वो कर सकते हैं. But कौन मांगा यार आपसे? You're able to differentiate the difference? The projects, whatever we do, like you, when I was college student, I also did many projects. I always will say, ये बहुत बड़ा project है, sir, ये करिए, वैसे करिए, ऐसा करिए. But कौन, किसको चाहिए? So हम लोग fundamentally कहाँ miss करते हैं is the user. We try to miss the user. User को जो चाहिए वो हम देना है. So for doing innovation in this country it is very easy because this country has 150 crore people, right? Every person has his or her own problem. If you try to put some amount of people, so you can find out a commonality in the problem. So ये सबको यही चाहिए, right? And then what do you do is, for this common set of people, what do they want? You ask them and you understand. For that understanding, if you can develop a product, then you get an innovative product. Is this clear? So rather than doing what I want, what I like, what technology is here, I would like to integrate. That's okay, excellent. That's for a project, but not for an innovation. So is this clear? So now the prime person to involve all these things are a user. Now, how do you find your user? That is a question. User is not so easy. For example, mere samne aake, if somebody brings in chicken 65, very well presented, very decent, they keep everything and present nicely, put all sorts of carrot around it and keep it on top of the table and say, sir, aap taste kariye. Bahut acha hai. Smell also comes very nicely. So immediately I will say no. Why? Because I am a vegetarian. If you take me as a user and say, Ram ko pasand nahi hai, if you say that, and if you identify as a user me, then I have no sense to you. Correct? So first you want to identify user who are truly user. देखो हम भी यूजर काफी समय पे है, जोमेटो में सामान लेते हैं, उसके बाद हम लोग 4 स्टार रेटिंग देते हैं, 5 स्टार रेटिंग देते हैं. Do we do it truly? भैया बोलेंगे भाई देखो यार, दे दो यार, मेरे को कुछ इंसेंटिव मिलेगा, 5 दे दो यार, 5. So immediately you go 5. You don't know whether he is black or white, whether he is Ram, Rahim, pata nahi. And what did he do? He gave something to you, what for which you paid money. What is the service he gave? Nothing. He just delivered to you, and for which he would have made 10 times phone call to you when you and your girlfriend are discussing. You still say, okay, sir, pagdo. And then you give a 5-star rating. Are you the user? No. Achha, aur ek example dete hain. My son who is now in college. The moment I say my son comes on phone. Okay. So my son who is now in college is my son, right? So I am a professor. So naturally what I want as a father, I want my son to get into JEE mains लिखो, उसके बाद JEE advanced लिखो, IIT के अंदर घुसो. Because हम 30 साल से काम कर रहे, मेरा बेटा भी उधर पढ़ेंगे तो अच्छा है. So what I did, I gave him all sorts of online material, offline material, 3 teacher के वजह से 6 teacher दिया, और उसके बाद घर पूरा AC कर दिया. इनको अभी बैठ के सोचना है, पिज्जा आ जाएगा, और ये थक गया, treadmill खरीद के रखा. Everything I did in my house. Then on top of it, I will teach him, my friends will teach him. छोटी सी सवाल है, then my friend will teach him. Everything has been done. We have been doing it for 2 years. 2 years we have been teaching. Then this fellow should be all India topper? Yes or no? हमने सब दे दिया भाई. Book, notebook, whatever you want, digital, teacher, khana, rehna, sona, everything I gave. So now he should be all India topper? Yes or no? Yes, no. But he was not. He was not. So he is my son, mera beta. I brought him 17 years. So I know him much better than him. Isn't it? Yes or no? So I know much better, because before he could speak, I could speak. So I know him much better. But unfortunately, the important thing which I missed as a father, was I did not motivate him. If I would have motivated him properly, he would have studied by himself without my support. So what is the problem I did? I did not understand the user. Sahi hai na bhai? So first is understanding the user. When you are trying to develop an innovative project, you should always understand whether the user is giving a true feedback or not. Moment you understand he is giving a true feedback and there is a genuine problem, then you start solving the problem. When you start solving the problem, you will try to figure out many more things important will come. Pehle he will say, I need this. Then you say, okay, give me 10,000 rupees. He will not be able to give. So you will say, हम कितना देंगे? 5,000. 5,000 के लिए ये मिलेगा. Then you will try to reduce it and try to improvise your product. So if you do that, then you can develop an innovative product. From an innovative product, you can try to start your own startup. When you start a startup, then you can give job to many people. So this is what is the track. The base is it has to be innovative. And product, right? Product also is very important. So what product you are going to choose? Let me give another example. My son plays every day 8 hours video games. Every day 8 hours video game. वो कॉलेज का बच्चा है. शाम को क्लास से वापस आएंगे, खेलने के लिए शुरू करेंगे, रात 12 बजे तक खेलेंगे. And he is not the only player. अभी आजकल खुद का playing, then intra wing playing, then intra hostel playing, ये सब चीज होता है ना. So you try to play soldier, whatever, kingdom, game and other things. So ये सारा चीज होता है. So this fellow plays 8 hours video games every day. And he and his friends, they play together. So let us assume they all play together in a month. They play somewhere around about 20 days. So each one plays 160 into 20. So 3,200 man hours has gone into video game playing. Now, ये लोग आपस में बैठ के they make a big list of things which the video game was missing, or these are the faults of this video game. If this would have been there, it would have been much better. They make a big list. And then they come to you and say, bhai, ye sab, if you improvise, the new video game will be very good. So is he the user? Because he has used it, he has given the big list of 20 items which is missing, and then he comes and gives it to you, saying that, bhai, ye problem hai, ye solve kar do, aap naya video game shuru karo, that will be the top. So ye user hai kya? And whatever he gives, if you try to solve, then that is a problem, innovative problem. इसमें कुछ गलती है नहीं है तो whatever he gives is correct. Should I start working on it? हाँ बोलो, जोर से बोलो.
We should first evaluate that we have does we have that resources we can solve that problem or not. Either that except these 20 people, either on the whole country can be our user, except these 20 users. So we must think first that these 20 people are definitely our user or not. Are we have these resources to solve this problem? Are we have this passion to solve this problem? That's the thing I think.
Yeah. So it is like this. Whatever you have analyzed nicely, you are there as a startup to develop a video game, right? You have the resources. Here are people, 20 people who have spent 3,600 hours, and they are giving their, which are all missing points, and what is your stand? So you will go ahead, take that problem statement and start working. That's what is the question.
I will validate this problem with more users also.
हाँ ठीक है करो, more users करो.
So if I
20
get
वजह से 40 ले लो बस. और इसके आगे नहीं जा सकते भाई, आपके पास भी समय limited है. You can't do everybody.
Yes, sir. If there's a problem, I will work upon it. If they are going to pay some amount of money for solving this problem.
Good. So yeah, I'll get back to you. हाँ बोलो. Social benefit क्यों मिस हो रहा है भाई? ये आदमी बैठ के खेल रहा है ना, अब चुपचाप बैठ के खेल रहा है, इसमें क्या मिसिंग है? अब ऐसे है तो हम लोग वीडियो स्मार्टफोन ही नहीं ले सकते. And she is right. So she says she is going back and telling to my definition. We all said that it has to solve a societal problem. But when you are innovative, you don't have to solve a societal problem. That's what she is trying to say. I agree with you. So video game is also, it's not a societal problem, but it, for which there is a product for which you can pay money. Okay, so I agree with you. Societal problem nahi hona chahiye. That's fine. In the innovation definition, she is removing a word. Agreed. Somebody else? Please, please. You are also part of. Correct. Okay, so you say that, okay, so as an innovator, I will also go play right? I will also go play and then I will see what he says and what happens is true. Is that right? Okay, personal experience is also there. Fine. So, okay, so let me go ahead with the story. So whatever my son and his friends give, whatever is my experience as a innovator, I do, it is of no meaning. Why? Because my son cannot buy the product by himself. He needs a sponsorer. So I decide the product usage also, wherein which I don't play video games. Look at it, how interesting it is. My son can play. My son can give all sorts of problems. He can give you, these are all missing. And you as innovator, you can go verify whatever he says. But if you don't keep me in your innovation cycle, then the product fails miserably. So I, as a father, or I as a sponsorer, play a very important role in buying a product at this age, 20 saal, right? 20 years, none of us in India, we go for part-time work. So we always look at father and mother to solve. So we go by it, right? So now what I am trying to say, I am trying to add one more variable on top of your user. User is my son who uses the product, but he cannot tell what is the price he will give because the price component is decided by me. Okay? Is that clear? So when you are trying to do an innovation, you should keep me also in picture. Which is also true, right? When you run a course, you always try to fix 500 rupees or 1000 rupees. How do you fix? Because you look at middle class and then you look at how much they can give for a kid. So then you try to pitch in. Whereas the user, the kid, does not know what is it. Right? Correct. But I don't play. So interestingly, the father and mother does not come and participate in your whatever, right? So does the story end there? अभी दो ही इंट्रोड्यूस किया, दो कैरेक्टर, एक यूजर कैरेक्टर, एक फादर कैरेक्टर, दो कैरेक्टर इंट्रोड्यूस किया. सो इन दोनों का प्रॉब्लम सॉल्व करेंगे तो आपका प्रोडक्ट अच्छा हो जाएगा क्या? और कुछ कमी है? ओके, हमारा घर में क्या है? I have an interesting personality, my wife. My wife. She also comes and decides. My wife will come and say, if I decide to buy, then my wife comes and says, भाई देखो, अभी तक he does not study. अब ये भी खरीद के देंगे तो he will not at all study. So now, my wife who does not even touch the product, she decides whether I can sponsor or not. So this becomes the third variable which you have to decide. Right? So you have to get input from user, you have to get input from the sponsorer, you have to get input from the sabotager. So my wife did not allow the decision to go further. Sabotager. Right? So 3. Now I'll introduce the fourth variable. When I don't know video games, I go to my colleague and ask, भाई मेरा बेटा ऐसे ऐसे बोल रहा है यार, आपका बेटा क्या करता है बताओ? So then he says, नहीं नहीं मेरा बेटा अच्छा है, he does not play. Then my friend stops my purchase. So he becomes the colleague who is again a sabotager who tries to stop buying a product. Right? So now in this entire thing, what I was trying to tell you is, you have to look at a user. You have to find out a problem. You have to solve the problem for which he is ready to give money. Moment money comes, what is the quantum of money is important. So for which you have to study users and customer architect. This is called as customer architect. So you find out, then you try to find out his father, then his mother, or in business, you try to figure out who is the sponsorer. For example, if my son comes and says, buy a Rolls-Royce car, buy a Rolls-Royce car. I as father cannot be a sponsorer. So I put all my bank papers to the bank officer and say, bhai, mera beta ke liye ek Rolls-Royce car chahiye, dev. So then he looks at the bank manager. He looks at all these things and he says, sir, आपका पैसा के लिए नहीं मिलेगा सर. So now I get a loan. He is the sponsorer. He will not allow you to buy the product. So when you try to understand any problem, please understand two components. One is user who tries to define the problem. Two, there has to be a cost component which is given to you. And for this cost component, you will always try to figure out who are all the stakeholders, try to map all the stakeholders with this problem, and then decide your price. So 2 points are very important: problem identification and the costing which is involved. These two are there. When I say innovative product, the product can be service also. For example, Ola, Uber, you can be a tuition teacher, right? Service can be there. You can have a product also. The product can be virtual, the product can be physical. So you have to understand the user first and then try to develop multiple solutions, right? And when you are a user, many a times you will not realize what are the pain points for the user. For example, kahan se dikkat ho raha? See, you also study, I also study. You get 100 marks, I get 35 marks. Previous day night, you also studied with me. I also studied with you. But now, as an intelligent person, I have to go back and see how did she or he get 100? Why did I get 35? So what did I do? I analyze my mistake. So when I analyze, I find out the pain points. So you have to find out the pain points. And how do you define a user? That becomes very difficult. As I told all the examples, that's fine. Suppose you are trying to develop a device, then you become the user first. For example, you are trying to develop, look at it, blind man stick, blind man stick. You have seen blind man using a stick? Yes? So blind man stick, this stick is been there for almost 100 years, right? Can you tell me any place where the defect size is in two-dimensional? Defect size should be in two-dimensional. That means to say, gadda, whatever is there, it has to be two-dimensional, or it has to be one-dimensional. Why? Because when you use a blind stick, the tip of the stick is a point. When you touch it, you touch the floor, and when you touch it, it is a point. And when a blind man walks, he always sweeps. He always sweeps like this, left, right, left, right, left, right, and he goes. Why? Because he has to understand how large is the way created for him, wherein which he can walk and go. So he will sweep, which is very difficult. अब करके देखिए, 1 किलोमीटर ऐसे एक लाती लेके swing करके जाइए. We will see how difficult it is. You will pain, it will pain left and right. But still, why did it happen? Because the first man who developed a blind stick was not a blind man. He did not understand what is the problem of a blind man. So now what is that? When you become a blind man or blindfold yourself, then you understand the problem much more clear. Right? So many a times when we see a hero dancing on the stage, we all make fun. He's a comedy figure. आप आके इधर 2 मिनट डांस करो देखेंगे. उसी समय आपको पता चलेगा what are all the difficulties. When somebody dance on the stage for 5 minutes continuously, multiple steps they do. Amazing. आप आके करो देख लेंगे 10 स्टेप के बाद आप भूल जाएंगे. फर्स्ट स्टेप कौन सी था? We have missed it. We don't do this. We don't do this. Because we are not dancers. And when we opine on others, we did not realize the pain. So while identifying the user, you have to be the user itself. Then only you will try to understand the problem. Okay? So next time onwards, when such competition come, this time also you should go back and see, why did I not get the first prize? What was missing in my prototype? Then you will realize what was the pain points in your prototype. Did I understand a customer? And if I have understood the customer, we will always try to find a solution for the problem. Is this clear? Clear, right? Okay. So let me go to the next. Forget, user ho gaya, sponsor ho gaya, bhul jao. next problem statement, next identify करेंगे. See, in academia, in teaching, in school, college, whatever it is, somebody defined a problem. It can be from a book, Kurmi, Agarwal, whatever it is, some Johnson, they would have defined a problem. Your teacher would have said, you solve the problem like this. These are the constraints, and when you solve, in the entire class, everybody gets a unique solution. Yes? Then he gives 10 out of 10, or 5 out of 10, or 0 out of 10. 3 options. That's what he does, right? Then you will go back and argue, sir, step mark के लिए 2 दे दीजिए, इधर 1 दे दीजिए, formula ठीक है sir. ये सब चीज़ होता है ना? And then finally the teacher is expected to find the end answer. But in reality, there is nothing called unique solution. Please understand that. There is nothing called unique solution. We all wear shirt and pant. How many of you have a similar shirt and pant? Raise your hands. Similar. Oh, that is uniform. Wojo. Other, apart from that. But everybody has paid money. Everybody paid money. Everybody bought a shirt and pant for his choice, fitting, whatever it is. So what does this convey? This conveys very clearly, for every problem, there can be n number of solutions. And there is nothing called a unique solution in innovation or in design. What is good to you need not be good to me. What is bad to you can be excellent to me. Right? So, this is the other thing which you don't understand. For any problem you define, there can be n number of solutions. So, we pick the optimum solution and then we try to innovate. So, is this clear? The second important point. There is nothing called unique solution. So, Ram ने किया, मेरे को नहीं क्यों नहीं आ रहा, वो छोड़ो यार, वो नहीं आ रहा तो छोड़ो, दूसरा रास्ता निकालो. So, that is the best part of innovation. So, you can have n number of solutions. Why did it happen? Right. The third thing is, you should understand, when I said n number of solutions can be there, for n number of solutions, there can be n to the power n number of ideas. Solution is multiple hai. So, for generating the solution, you can have 100 ideas easily. So, when you have 100 ideas, you become more creative. And then, when you have 100 of these ideas, you try to put down all these ideas and then pick 2 or 3 or 4, you make a small prototype. When you make a small prototype, then you realize how many of the ideas will work and how many will not work. Then you take the prototype and finally you do testing of the prototype. When you do the testing, you are not supposed to speak. You just throw the product in front of the user and see what he does. Right? For example, many a times we buy toys for babies. बच्चे के लिए, so 1 साल का नीचे जो बच्चे हैं, we try buy toys, multiple toys we buy and give. And always we try to buy toys which are attractive in color. Right? But truly speaking, at that point of time, the kid eye concentration will not be so much. किसी ने बोला हम लोग भी कर रहे हैं. Will not be so much. And when you throw some toy in front of a baby, the baby will first try to keep the toy in his mouth. So you should spend more time in identifying the material of the toy rather than the toy or the mechanism. So this is testing. So if you do all these things properly, then trust from me, friends, all of your ideas are innovative ideas. So there are only 5 steps. I'll try to wind up. Sai, aa gaya kya? Achha, theek hai. Okay, there are 5 steps which we discussed now. First is empathy study. Empathy study means understanding the user thoroughly. That is empathy. First, we should try to do an empathy study, find out whether there is a problem, and if there is a problem, what will be the cost he gives. Now, currently, how is he using or how is he understanding the situation, and then what is missing in it. All these things will come in empathy. The second step is nothing but definition of the problem. जो हमने बोला है ना, book में जो है, somebody defines a problem and you all get a unique solution. Now there is nobody to define the problem. So you will have to define the problem. Problem is, say for example, Ram Kumar, in the next 5 years, would like to become a crorepati by doing professional job. So I have defined myself saying that 5 saal mein hum ek crorepati banayenge. But how do I do it? I can also do murder, I can do kidnapping, I can do some sale of something. But I said, no, I will do it professionally. But what is professional? I can do share, I can buy land and give, I can buy lottery. Pura lottery kharidenge, pura saal kuch na kuch milega na. So these are all professional, straightforward. Or I can buy gold, do trading, possible. So I have defined, so second step is definition of the problem. In the definition of the problem, you should clearly say, I am going to solve this problem for this set of people. The cost for the solution cannot be more than 100 rupees. And my solution will be delivered in 5 years, 3 years. Now you have a clear definition of the problem. This is the second step. The third step is you try to develop multiple ideas for the defined problem. So that is the third step, ideation. The fourth step is going to be prototyping. You make multiple prototypes on the ideation which you have created. Right? On the ideation which you have created. Fourth step. Right? And the fifth step is going to be you will do testing of your developed prototype. So these are the 5 steps you do to develop an innovative solution. Is that clear? Right. So now we are going to, I am done. So if there are sawal, you can ask me. I always love to give assignments, so I will give you an assignment. Okay? So you are now, if you have doubts, you can ask me. Any doubts? You can ask me. I am not clear, sir. Is point mein clear nahi hai. Nahi to sab clear ho gaya, sir. Aane wala samay mein everybody will make patents. Excellent. Make it. Any doubts? Okay. Almost everybody has a pen, paper. Pen, paper with you? Paper, pencil, rubber, whatever. है ना? एक पेज उठाओ. नहीं, मोबाइल नहीं चलेगा. एक पेपर ले लीजिए, एक पेन ले लीजिए, किसी से बोरो कर लीजिए, आसपास में है. किसी के पास पेपर नहीं है तो दूसरे से बोरो कर लीजिए. एक आइडिएशन एक्सपेरिमेंट हम करेंगे, उसके बाद खत्म. Yeah, please.
How do we actually know? I'm talking in the sense like, I might think that this is a problem because I've been talking to people and I've been coming across answers like, this is not there, vague answers from people, but then I feel that, what, if I create something like this, it's gonna work. This is my thought. How do I actually collect valid data points?
Generally, valid data points generation will take time. So typically, if the students want to, next year, if they wanted to come up with an innovative solution, now it is September, August, so they will have to do a field study till November. This is the toughest part in the entire cycle. Understanding customers is really, really a challenge. Many of the kids will say, oh, it's a wonderful course, there's a beautiful teacher coming and teaching, why don't you send your son? So the basic thing is today kids are very busy, so they don't have time. So they will not be able to say, my son, there are two things, my son cannot cope up to the course, possible. My son does not like come to the course, or would like to come to the course. Or maybe you offer it in a venue which is very far off. So all these things put together, they will say, oh, in your course, this is missing. So that does not mean that is truth. So, and how do I do it? So how do I do it is, you have to sit with them and have a long conversation to understand what they want. See, many a times, the user will not tell. The user will not express. He will try to feel, or he might try to shoot in air. So you have to spend time in understanding the customer. And I told you, there cannot be a universal solution for everything. For example, I have a workshop program for school kids from 6 to 8. Can I extrapolate it? No. Now I find an audience 4 to 6. Can I do it? No. 4 to 6 intellectual capability are different, 6 to 8 is different. And then you try to say, I am going to make it for 10,000 rupees. There are customers for it. I run a course only on weekend where 12 days course, 10 days online, 2 days offline. The course charges 22,000 rupees, right? I have audience for it. And I don't look at audience who can pay 1,000 rupees. So you have to also pitch in your level, who are your customers, understand your customers and the bandwidth. If they say no, try to understand to spend more time. And never ask a closed question. For example, do you like me? I say no. Conversation over. What if I come to you and I express my liking and this and that, oh, I look, so something like that if I say, so you have an open-ended question where you can keep building the conversation and assess me whether I truly like it or not. So your question should also be open-ended. Yeah. हो गया सबके पास आ गया very good. So now you are supposed to do only one exercise and you don't have to submit to me. You will understand what is your capability. You will, all of you will try to draw a teacup or milk cup or pani ka cup, whatever it is. You try to draw a cup wherein which the top cross section and bottom cross section should not be the same. Right? And you will try to draw 25 different variations of the cup. First हमने बोला cup draw करो. Then I said the top cross section and the bottom cross section should not be the same. Clear? For example, ऊपर circle है, नीचे circle नहीं होना चाहिए. ऊपर circle है, नीचे square होना चाहिए. Right? And then I try to say, try to draw 25 different cups. 25 different cups, where in which the similarity between the two cups should not be more than 20%, not 10%. समझ गया? 4 points. First, you should draw a cup. The top cross section and the bottom cross section should not be the same. I am asking you to draw 25 variants of the cup. Between two variants, the similarity cannot be more than 10%. Can you draw? You draw it. And no teamwork. Individually आप draw करिए. Now you will see what is your creativity and your ideation. Fine? So if there are no questions, thank you so much.
Everyone, please be seated. Good evening, everyone. The next session about IMP awardee and felicitation segment is about to start. I would like to call upon the coordinator of IMP 2026, Professor Alok Kumar Das, to continue the ceremony.
Good evening to you all. So, today morning we have inaugurated Day-2 functions, Innovations in Manufacturing Practices 2026. So, let me brief about the things. We have received approximately 84 applications. Then after sophisticated screening process, total 15 number of applications were selected. Then today they had presentation and also demonstration round. Evaluators were consisting of the VCs, venture capitalists, faculty members, and entrepreneurs, and Ministry of Electronics officials. So they have given the selected list to me. 3 proposals were selected, but before declaring the result, I would like to invite Professor Raman Singh, Professor of Monash University, to the stage. Sir, please. Then Professor Ram Kumar, a Professor of IIT Kanpur. Sir, please come to the stage. Professor Amit Rai Dixit, Professor of this institute and also convener. Please come to the stage. Professor Ankur Gupta from IIT Jodhpur. Sir, please come to the stage. And my colleague, Professor Ravi Gangwar. Professor Ravi, on the way. Okay. So after screening process and today's evaluation, 3 proposals were selected for award. In the UG category, the first award goes to Ashutosh Rath and Biplab Sarkar. So it is the first. They have developed in-house portable 8-channel EEG device. Come, first. So they won the first prize. So, congratulations. Professor Ravi, please come.
So wherever you feel like comfortable space.
So second prize goes to UG category, Aman Kumar Gupta and Mridul Chaudhary, Abhishek Raj. The second prize goes to them. They have developed, their title is Smart Aqua Track, IoT-based real-time water monitoring and leakage detection. So congratulations. Then in the PG category, they have given NFS report, not found suitable. In PhD category, they have selected one, Piyush Kumar. Mr. Piyush Kumar, are you here? So big congratulations to him. So he has developed sustainable and advanced machining of critical mineral bearing alloys through controlled disintegration using abrasive water jet machining. So it was a DRDO project. So congratulations. So thank you so much. Acha.
The faculty from
Faculty members from BIT Sindri and Government Engineering College, Godda, please come forward. So they have supported. Please, please. अच्छा, I'll give you.
अच्छा यहाँ पे ये वाला
नहीं ये नहीं है.
अच्छा ठीक है आप बस मुझे एक बार अच्छा अच्छा हाँ ठीक है that's it.
So thank you, sir, and thank you, dear all. Now we can move forward for the tea.
Thank you everyone. On behalf of organizing committee, I extend our sincere congratulations and appreciation to the awardee for the outstanding contribution. With that, we come to the end of this session. High tea is served outside the Penman Auditorium at the Dome. Thank you all.